similar to IPv4 packets. And then we'll go on to deploying IPv6. So what are the stages? How do you actually deploy IPv6? Then we will talk about transition mechanisms. Originally, the idea, of course, was that we introduce IPv6 and it's fantastic, and overnight it just stops, and then suddenly there's no IPv4. But of course, you realize IPv4 is actually going through a very long death. So they live side by side for many years. So how do you deal with that? That's very important. So that's why we talk about transition mechanisms. And finally, we'll let you go at 11 o'clock when we finish this presentation about some tips, final tips, and that will be the presentation. So we start the first section, and the first section is IPv4. And what do we answer to that? So basically the question, of course, means, do we really need this IPv6? Can't we just somehow, by NATing or whatever means, just stick to IPv4? Everyone knows how that works. And with IPv6, there's still, even after so many years, a lot of what in Dutch you would call cold water fear, that you really don't want to just go in there. So the question is, do we have to do it? Well, I just want to present to you a graph, and internally we call this the plane crash graph, because you can see how the IPv4 pool of IANA, in case you don't know what IANA is, so they have the central registry, or the central pool of IPv4 addresses. They distributed then to the regional internet registries like the RIPE-NCC. And here you can see the percentage of IPv4 addresses that were in the pool. So when we talk about IPv6 runout, you have to realize it has been going on for 12 years. So I wasn't exaggerating when I said slow death. So IANA ran out of IPv4 in 2011. But that, of course, didn't mean that we don't have any IPv6 addresses, because what they did, and that was the policy that was agreed, that IANA handed out the last /8s, and the /8 is about 17 million IPv4 addresses. So it handed out 5/8s. That was the final thing about IPv4, as far as IANA was concerned. They handed out these last /8s, one for each regional internet registry. So RIPE-NCC received a /8, and something else that's interesting about these last 5/8s that all the regional internet registries received, each one, of course, is that there was a specific policy. In the case of the RIPE-NCC, the policy was that before the standard or the minimum allocation size, so what we give to our members when they want addresses, was /21. So that's about 2,000 something addresses. And that changed for addresses from the last /8 block into smaller, into a /22. So that's about 1,000 something addresses. And the other rule was that every member, the LIRs, they could only get one allocation of this 1,000 and something addresses, and then that was it. Why did we have this policy? Well, the idea was that obviously IPv4 and IPv6 are going to live side by side for some time. So that means even now, so many years later, most of the content is still on IPv4. So in case if you have IPv6 addresses, your client has IPv6 addresses, if no one in your network has IPv4, then there's no way you can do a translation mechanism. So because of that, it was deemed essential that every LIR still, even new LIRs, should still have a few IPv4 addresses available. And let's see what happened. This is then the later stage. So 8 years later, you notice 2011, now we have 2000, in this slide, 2019, and of course it has even the minute. That is when the RIPE-NCC ran out of IPv6 addresses from this regular, not regular, but from this last /8 pool. So you can see it took actually, because we subdivided this /8 into /22s, and you can calculate it yourself, how many /22s do you have in a /8, and it lasted us for 8 years, right? So you can see that the RIPE-NCC then ran out in 2019, and that was the end of it. Or actually not, because of course what happens is even though we ran out of our last /8 block of IPv4 addresses, we still kept reclaiming addresses. People returned addresses. So that's why there's no clear end that, okay, RIPE-NCC doesn't, because even if RIPE-NCC didn't have any addresses, IPv4 addresses to distribute right now, tomorrow it might be different because we might reclaim some addresses. So that's why, as you see, running out of IPv6 addresses is not a very clearly defined point in time. It is a process that is dragged out over time. And what happens then? Well, now I'm just going to be talking from the point of view of the LIR. And from the point of view of the LIR, this is the situation. You sit and wait. And the reason for that, obviously, we have, well, imagine what happened. There were lots of new LIRs created because every new LIR could then claim a /22. That was some time ago. So you can see that there was a long waiting queue, and there's still a long waiting queue. And the waiting queue is about, a year, a little bit more than a year. So if you ask for IPv4 allocation from the RIPE-NCC, it will take at least a year. So that's the reality as it is now. And of course, what you see here in this slide, also that things changed. It got even smaller, 4 times smaller. That means that now you get an allocation not of a /22, which was already a smaller allocation than previously, but now you get an allocation of a /24, 256 addresses. And you have to wait for it for more than a year. So that's the situation. Okay, so let's go into IPv6 address basics. So we'll just talk a few things about the basics of IPv6 addresses, and we'll just assume you know nothing about it. So as I said, I know that is not the situation, but we'll start from the beginning. First of all, the distribution. And you might have remembered that with IPv4, IANA held all IPv4 addresses, which was 4 billion plus addresses. And then over the years, they distributed that. Now, what happens with IPv6 is there's something called the format prefix, is a specific arrangement of the first 3 bits, 001. And so basically from all IPv6 space, which you see here in blue, IANA only holds 1/8. So one combination of the 3 first bits. And that's, as I said, the format prefix. So that's what we are using, a /3. So as opposed to IPv4, IANA holds a /3, not a /0, not everything. So you can ask, what happens to the rest of the 7/8 of all addresses? Well, the best way to imagine it, we went into the garden, we dug a hole and we put it in there, or we put it into a freezer, basically. So the idea is we have this system, this is how we are distributing IPv6 addresses. If the whole thing either doesn't work out well, or if we run out of it, we still have plan B. 7/8 of the addresses is still there waiting to be used in a better way, perhaps. So anyway, that is this section here. And that part is called global unicast. So that is the name for public addresses in IPv6. So in IPv4, you had public addresses. Now you call them global unicast. It's the same idea. And global unicast are distributed from IANA to the regional internet registries. They are distributed in chunks of /12. And we're not going to go into how many addresses that is. That is humongous amount of astronomical amount of IPv6 addresses. But the important thing is, perhaps if some of you are LIRs, then you will have remembered that in IPv4, the blocks that RIPE-NCC and the other RIRs would get from IANA would be /8, and I mentioned that's about 17,000 addresses. Now with IPv4, the blocks we get from IANA are /12, and it's zillion, million, quadrillion, quintillion, whatever you want. It's huge. I mean, you can calculate it, /12, how many addresses it is, 2 to the power 128 minus 12. You can put that in your calculator, but it's meaningless. It's just a huge number. So what we have is /12s that are distributed from this part that IANA has, which I told you was 1/8 of all address space. And luckily, we don't have to calculate it. It's written on the slide, but the /3 is 504 /12s. So from this total of 504 /12s we have in our address space to be distributed centrally from IANA, IANA has distributed 7 /12s, 1 for each registry, and 2 registries actually needed a second one. And you think, how on earth did they need a second one? We're not really going to go into that, but you actually realize in IPv6, hierarchy is also very important. So as soon as you use from a subnet or a sub-block 1 or 2 addresses, basically it's counted as used. We can go into all kinds of philosophical discussions, and perhaps I'll just stop a bit because we, and just, what's the word, sort of deviate for a moment, because this is perhaps something that people, this one doesn't seem to work. That's okay. So there's always a discussion like, oh, why are you wasting these addresses? But what you have to realize is how many of these we have. So we are actually, as opposed to what you might conclude from what you see here, we are not advocating wasting IPv6 addresses. We're actually strongly advocating conserving IPv6 addresses, but that works on a different level. You're not conserving individual addresses because that just doesn't work. Then the whole system would not work. Anyway, getting back to these 7 /12s, so the RIRs will have these 1 or some of them 2, sorry, and there is 1 extra /12 for miscellaneous uses. Right, this is just interesting. So if you ask for an allocation from the RIPE-NCC, you will see that your prefix for your allocation, which will be either a /32 or perhaps a /29, will start like this, because this is our /12. And you can see there's a RIPE-NCC got another /12, and also Aaron got another /12. So these are the address ranges. Now, how are addresses distributed? And this is basically the same diagram we used in our training courses for distributing IPv4 addresses. The only thing we changed is we changed the numbers inside. So you can see it works exactly the same way, the whole hierarchy and how it is distributed. Let's go through that briefly. So as I said, IANA has /3. So for all purposes, that is considered all the public addresses, all the global unicast addresses we have available until we do something else with the rest. But at the moment, we have a /3. From that, you can see on the right-hand side, IANA distributes /12 blocks to the regional internet registries. So like RIPE-NCC. So far, so good. And then it's interesting what happens next. On the one hand, and you can see here the levels, here you have the LIRs, so the members, the local internet registries. They can request an allocation. And the standard allocation, the minimum allocation size is a /32, which is again huge. And that's this one. And that is called provider aggregatable allocation, PA allocation. Why? Because the LIR then, as you can see, will distribute addresses from this range to its end users. So that's the black, or actually dark blue boxes there. And what you see here is the /32 and the /48. These are called provider aggregatable addresses. The terminology is also important when you deal with the RIPE-NCC. This is called allocation. And if you need a mnemonic, I can't pronounce it, then allocation is from large, allocation, if people can't remember it. And if you mix it up with assignment, you have assignment, the S for small, and that is perhaps a way to remember allocation assignment, yeah? That's important terminology for the RIPE-NCC. And you can see it's called provider aggregatable PA addresses because they are aggregated on the LIR's level, on the level of allocation. So the idea is then afterwards, the LIR will announce the entire allocation, this /32, as one block. Again, of course, you realize that the size of the routing table is an even larger concern in IPv6 than IPv4. So that's why we want to make sure aggregation is followed. And you see actually typical assignment sizes here for end users. And that's also very useful for if a member asks for addresses and they are new to IPv6, and then they think, okay, now we have all these different sizes. What sizes do I assign to my end users? And of course, we'll have a slide about that. We'll go all into detail, but if you want a very quick and fast rule that you can always use is for an individual user, the idea is you hand out a /56. So even if, let's say, my uncle somewhere just living on his own would get an assignment for his house, then it should be a /56, which I'm jumping ahead a bit because we'll be talking about /64s, which are the standard size for subnets. So we don't calculate then the sizes of blocks really anymore with how many addresses there are in it, but we consider how many subnets, how many /64s fit into that. And the /56 help me if I'm not calculating it correctly. /56 is 256/64s. Anyone can? Yeah, okay, thank you. I had a bit of a blackout, but I think it's 8 bits, so that should be fine. Yeah, thank you. And so the thing is, so even if someone in the old days with IPv4 needed one IP address, then what happens now, they get a /56, which is 256/64s, and each of these /64s, of course, have zillion addresses. We'll get into that. But this is the moment when people start throwing rotten tomatoes and eggs at us because they get really upset. They're so used to conserving addresses. But what you should really think about is how many /56s do you have in a /32? And here I'm also a bit at a loss, so that someone can help me. 2 to the power, to the difference between these two numbers, it is, I think, about 16 million. Am I correct? Yeah, I see someone nodding, so thank you. So basically what you should consider is in the olden days, we would have in IPv4, we had, let's say, a /22, and you had 1,000 addresses. And now if you get an allocation, a /32, you'll have 16 million /56s in that, yeah? So if you're worried about wasting address space, you should realize there's quite a lot of it to go around if you use it sensibly. Anyway, that was a bit of a digression, but going back to this arrangement is called, provider aggregatable addresses, because they're aggregated at the provider, at the LIR's level, at the allocation level, and announced together. But then we have something else. Excuse me, I forgot what I still wanted to say here. So you'd give to an end user a /56, and if it's a small organization, then you could give them a /48, which would be 65,000 /64s, 65,000 subnets, as opposed to the /56, which is 256 subnets. So if you are really not very well prepared for this, but you have to do assignments, then the quick hint is to individual end users, give a /56. For a larger organization, if they are your customer, then give them a /48. And in most cases, you'll be fine and they'll be fine, yeah? So that's the easy way out for how do I assign, what sizes do I assign. So that's why this example here is not a completely random number. There is a thought behind it, yeah? Okay, and then moving on, the /48, that is PI assignments, that goes directly from the RIPE-NCC to the end user. And the thing here, this is portable. So if you leave an LIR, then you have to give back these PA assignments, but the PI assignment you can take with you. So the basics is IPv6 addresses are 128 bits. It used to be 32 bits in IPv4. And the important thing about IPv6 is that every subnet should be a /64. That is the basic. We calculate in subnets in how many /64s are we using, yeah? And the customer assignments should be between a /64. Actually, I don't quite agree with this. I think the lowest should be a /56, as I told you in the previous slide, and up to a /48. And previously, you needed justification and to request if you wanted to give a larger than a /48 to a customer, but nowadays you don't have to do that. So the minimum allocation size is a /32, and I went through the numbers before. But nowadays, if you want more, if you want a /29, then it's quite complicated. You just put in your request, I want a /29, and you get it. So there's no, you just have to say it and you can get more than a /32. You don't have to justify it, you just say, give me that. Right, address notation, in case you haven't seen an IPv6 address, this is how it looks like. So it is quite slightly frightening, of course. You might consider it, but otherwise, actually, if you look at it long enough, not really. What we have is 128 bits converted into hexadecimal numbers this time, and not into decimal as with IPv4. In IPv4, you had 8 bits that were converted into hexadecimal numbers, and you had 4, whoops, excuse me, you had 4 of those, and you, of course, you had the dots in between. In IPv6, what you have is for each nibble, 4 bits is converted into a hexadecimal number for human legibility. Of course, a number that goes between, the digits go between 0 and F for 15. And you can see this is how it looks like. For 4 hexadecimal digits are always divided by a double colon. And this is how your address looks like, except it never looks like this. Why? Because you are going to compress it. So what happens, since you know your address has 8 quads, these are called quads, 4 nibbles, so that's 16 bits actually. So each quad, of course, has 4 hexadecimal numbers, and you have 8 quads as such. Then, because you know in a quad you have 4 hexadecimal numbers, if it's all 0 like this, then you can just write this, because you know between 2 columns you have 4 hexadecimal numbers, so you can pad it out with zeros on the left. And something else you will quite often see is entire 0 quads, trains of 0 quads, and you can shorten it. And what you do is, if you have a train of 0 quads, you can just substitute it with a double colon. And of course, here you have to be careful, because you have to be able to reconstitute this number now that you see at the bottom to the number at the top. And because of that, you can only remove 1 train of 0, or 1, yeah, well, I call it train. I suppose you know what I mean. 1 train of 0 quads. And if you have 2 of them, you have to use the double colon just for 1 of them, because otherwise you will not know, oh, well, was it, because you know you have to go back to 8 quads, but you don't know whether you had 2 quads of zeros here and 3 there, or the other way around. That's why you can only use it once, and you use it with the longest train of 0 quads. And if both like trains of 0 quads in the IPv6 address exist, then you use it on the left-hand side. So there are special rules. And in case you forgot, if you look at this quad, this stands for this in binary notation. It's the same number in binary. Okay? Right. And then we get to the part that seems to be the most difficult in IPv4 address, basic IPv6 courses. That is the subnetting. So once you decide, okay, I need a /56, I need a /48, what is the prefix? And that seems to be the most difficult for most people. That is our experience, that more than half of the class can't do it at the training course. And because of that, we have this quick aid. So basically, if you say a /32, obviously /32 means that the first 32 bits are fixed. And now what we do here is to keep things simple. We stick to nibble boundaries. That means we only talk of CIDR blocks where the number is 4 multiples of 4. So we don't have to cut up hexadecimal numbers. Then it's quite simple, because 32 bits is the same as 8 hexadecimal digits. Of course, 4 bits is 1 hexadecimal digit. So fixed 32 bits means fixed 8 hexadecimal numbers. So if this is the same, whatever comes after that, belongs to the same /32. Yeah, and that's why you see /32 is up to here, a /48 is up to here, because that's of course 12 hexadecimal digits. 12 times 4 is 48, and you can calculate the rest yourself, and then you know how long a prefix for different size IPv6 CIDR blocks are. And the important thing is you never go below this, because the last 64 bits are for the interface ID. That's important for auto configuration, and that's why we actually picked, well, we didn't, I didn't, that's for sure. But so I'm saying we, but basically that's why it was fixed as the 64 bits for the interface ID. Okay, something else with IPv6 addresses is devices will have quite a lot of different IPv6 addresses at the same time. That is also a feature. And here, so it might have a few of these these are different types of IPv6 addresses. Note that the most important one we talk about is the global unicast. So that is our public address. And you can see they start always with a 2. Actually, it's not true, because 2000 /3 means it starts with a 2 or a 3, actually. But we also have all kind of other address ranges, and we can go through these. And what I was saying, that device might have different IPv6 addresses from all these different types at the same time. So at the top, we have unspecified. That just means if you remember is 0, so that's an all 0 address. Straightforward. Loop back here in the sense of localhost would be all 0 and 1 at the end. And here you see at the right the scope. So the loopback is of course only valid for the host itself, and another host will have also the same local host address, but the scope is only for that host. And then we have IPv4 embedded. So basically you can embed IPv4 address in an IPv6 address. This is important for all kinds of translation mechanisms. And you can see the prefix there, obviously 96, so you can put in the 32 bits of IPv4 there. Discard only. Here you have basically it's a /64. Link local, this is very important in the architecture of IPv4. So basically link local is an address that is only used within the link, within the subnet. It doesn't go past the router. Sorry about that. So it doesn't go past the router. It is specific for the link, because the same address might be used in another link. And as I said, that's very important in the architecture of IPv4. Then you have unique local. That sort of corresponds to private addresses in IPv6, but is not as widely used. And then we have multicast. We had, so multicast in IPv6, and that is, well, you remember you have broadcast in IPv6, so one to all, and multicast means one to a specific group. And one of the groups is actually all devices, for example, in the link. So it can function in that way that it covers all devices. And that is the prefix for that. And as I said, each device can have addresses from all these ranges. And let's have a look at the scopes. And so we can have the first scope is where the address is only valid on the interface. Then we have the address is valid in the link, in the subnet. Then we have the addresses valid only on the site. And finally, you have the global. So for example, global unicast, that's valid for the entire site. And basically here we have a few examples, but I already mentioned these to you. These are just a few examples for example, multicast and link local. And of course, here we have the global unicast. And that's it. And at this point, I'm going to hand it over to my colleague Typhoon, and he'll carry over from here.
Yeah, thank you, Feras. Thank you, Feras. So, yeah, after this point, in section 3, we will talk about IPv6 protocol basics. I will try to stick to this one, okay. So, in IPv6, I would like to talk about two different concepts, actually. The first one is about address auto-configuration, which is supported by the second one in the slide. So, address auto-configuration has an importance, actually, in IPv6. It is a nice feature that we have. In IPv4, we don't have it. And thanks to neighbor discovery protocol that we use in IPv6, we can configure our hosts automatically with the IPv6 address. So it has two flavors, actually. The stateless one with the help of Slack procedure, and the stateful one, again, with the help of DHCP-v6. So if we are talking about stateless auto configuration, we need to talk about the Slack, which actually stands for stateless address auto configuration. And if we are talking about stateful, of course, we need to talk about the DHCP-v6. So there will be addresses on DHCP-v6 which are available for delivery, and then we will deliver them and we will keep the states of them in the DHCP-v6 like a binding table. And in the second concept, actually, this is we can say that it is the heart of the IPv6. It is a neighbor discovery protocol, and it replaces ARP. There are several functions actually in IPv6 that neighbor discovery handles, and one of the most important one is replacing ARP. So with the help of neighbor discovery protocol, we learn the layer 2 addresses of the nodes on the link. So we learn the MAC addresses, for example, for Ethernet. We learn the MAC addresses of the hosts on the link with the help of neighbor discovery protocol, and we will see that in the following slides. And it uses ICMP-v6 actually, and of course it uses again the multicast. We use a special multicast group, multicast address for this purpose, and it will be called as solicited node multicast address, and which we will also talk about it. And it also keeps the track of reachability. It finds the other IPv6 devices on the link. It keeps a table. So it's like an ARP table, maybe you can think of. And it is keeping the states of them. It actually checks whether they are still reachable or not. So let's start with the auto configuration process now. We have 4 different steps in auto configuration, and they are, the first one is make a link local address first. So this is the first step, and you need to configure your own link local address. Franz talked about the different types of IPv6 addresses on a single host, and one of them is link local address, which helps you to communicate with the hosts on your own link. So first of all, you need to configure your link local address, which is also mentioned in the name. It is local to the link. The scope is link. So you cannot communicate with this address with the internet nodes, but you can communicate them. You can communicate with the local hosts. And the second step, check for duplicates on the link, because you just configured it and nobody knows that you are using that address. If anybody is using that address, that same address with you, then it will be a conflict. So we don't want this, and we need to check for the duplicates. And we have a special procedure for this as well. And the third step, we search for a router in order to get more information from the router. So it is a little bit different than what we do in IPv4, because in IPv4 we will not communicating with the router on the link until we want to reach to the outside of the network. But here, first we need to communicate with the router to get more information from that device. And the third step, make a global unicast address. And finally, we configure our global unicast address, which we use to communicate over the internet. And as you can understand from the name as well, this time the scope is global. So you can communicate with each device. And let's check the first step now, making a link local address. How do we do it? So first of all, we have a spatial prefix, which is FE80 : and it's a 64 bits long prefix. So the half of the address is actually coming from the prefix, right? So we have already half of it. And the other half is called the interface ID. And for the interface ID, we have a special procedure, which is very straightforward, actually. It is really easy to understand, because what the procedure says us, we have the MAC address, which is actually 48 bits long, but we need 64 bits, right? So we just split MAC address into two, and on each side we have 24 bits, and in between we put the FFFE. So that's how we create the interface ID part of the link local address. Sorry, one more step, which is actually shown here with the red notation. Actually here, we flipped the bit, 7th bit, it's a part of the procedure. We flipped the 7th bit of MAC address from 0 to 1 or 1 to 0 to change the scope of it from global to local or local to global. So that's basically how we create the interface ID part of link local address, and we combine both of them. So finally we have the 128 bits long link local address, and it is strictly bind or tied to our MAC address. So that's how we create the link local address. Now we are with the second step. We need to check if it is a duplicate on the link, or are we the only one that is using that address. It is very unlikely, by the way, to configure actually a duplicate on the link, because it is the MAC addresses should be unique, but somehow anybody can be configuring some link local addresses manually, or maybe they are using some other types. So there can be some duplicates. So we need to check it. So how do we do it? With the help of neighbor discovery protocol again. So here we are seeing the two different messages, two different types of messages in neighbor discovery protocol. The first message, we send the neighbor solicitation. This is the first message. And we say, hello, is this IPv6 address in use? And can you, if it is in use, can you tell me the MAC address? And this second message here we see is the neighbor advertisement. So in neighbor advertisement, we see that if there is any host that is using the same address with us, then it is replying back with the neighbor advertisement. And it is saying that, yes, I'm using that IPv6 address, and that's my MAC address. So this is the procedure. And if we don't get any reply back, that's a good thing actually for duplicate address detection. It means that there's no duplicate on the link, and we can use that address. It's good to go. So that's how duplicate address detection procedure works. And in the previous slide, I said that we are sending neighbor solicitation message to the link. But which address do we use actually? Which address do we use to communicate to all the nodes on the link? Actually, the first rule in IPv6, we don't have any broadcast address. So for example, you may remember that while we are doing ARP in IPv4, we were sending a broadcast message to the link in order to learn the MAC addresses of the hosts. But here, we don't have broadcast address. So we use multicast addresses. And for this purpose, we have a special multicast address, which we call solicited node multicast address. Why we use this multicast address instead of a broadcast? Because we want to make the communication efficient. So when you use, for example, a broadcast address, you disturb or you wake up every node on the link in order to get a single reply from a single host. So it is really inefficient. And you can also create some broadcast storms on the link, which we all maybe faced or experienced earlier. So the designers of IPv6 actually came up with a new multicast address, which is a function of lower 24 bits of their unicast address. So I will go into the details of how we create it now, but I want you to understand that this is a way of making the communication over the link more efficient. So how we create actually the solo-sited node multicast address? First of all, again, we have a fixed prefix. It is FF02 : 1FF. So it is actually 104 bits long. So we need 24 bits more in order to create the multicast address, which is 128 bits long. So how we get that address? We get the last 24 bits of the any unicast address that we configure on the host, and then we get the solo-sited. We combine the prefix with the lower 24 bits, and we get the solo-sited node multicast address. And in IPv6, every host should listen to this multicast address according to their own unicast addresses. So for each unicast address, you will have one solo-sited node multicast address, and you should listen to that channel. So that is how we communicate actually with the other nodes on the link without making broadcasts, without sending broadcast messages to the link. Because let's think about the duplicate address detection procedure that we talked about in the previous slide. So we are checking exactly the device which is using the same IPv6 address with us, right? So if we send the message to the solo-sited node multicast address, that node, if it is using our IPv6 address, that node should be listening to this channel or to this multicast address. So that's how we guarantee that we will be succeeding with the duplicate address detection procedure without the broadcast messages. So that is the efficient way of communicating over the link. And as you can see here, if we send a message to the solo-sited node multicast address, hey, this message is for you, it says, with the prefix that we have seen earlier. Let's read it again, FF02 : 1 FF. And with the lower 24 bits of its unicast address, combined with this prefix, it is sending the message. And as you can see, just a single host is getting this message on the link. So the hosts around will not be disturbed or will not be waken up for this type of communication. And if there is a duplicate, it will send back a reply, and it will say, yes, that's me, and this is the MAC address I'm using. So maybe it's saying that you should be using some other address. And duplicate address detection procedure will fail, and you need to use another address. And we are with the third step now. So do you remember the steps for making the global unicast address, the auto address configuration? We checked, we first configured our link local address. That was the first step. The second step, duplicate address detection procedure. And now we are with the third step, searching for the routers to get more information from them. And here we see the third and fourth type of messages in NDP protocol. They are router solicitation, which we seek the router on the link. Actually, we say, hello, is there a router out there, with the neighbor solicitation message? And the fourth type of message is router advertisement, which we say, hello, I'm a router, and this is the information for you. And this is basically explaining the meaning of router advertisement, because router is advertising itself. So, and inside the router advertisement message, we have many kinds of information for the host to be configured on the host. So what kind of information we talk about? These are the non-exhausting list of information that we get from the router. So the first information, it is the router's link local address, the router's address, which is very important actually, because we use this address as the default gateway of the host. So the router announces itself to the link. It says that I am here, this is my address, and you can use it for the default gateway. So in IPv4, we were configuring it manually, or maybe we were getting it from DHCP, the default gateway, but in IPv6, this is not the case. We use routers, we use the default gateway from the router advertisement message, which we call array message. And the second information that we see here is 0 or more link prefixes. They can be more actually. One prefix or maybe more prefixes can be sent by the router to the link. So the hosts on the link will configure their addresses, their global unicast addresses, with the help of this information. So it is also important for the hosts on the link in order to configure their own global unicast addresses. And one more information, we have, this is actually a flag, which we say actually because it is just 1 bit long, and it says if slug is allowed or not. So yes or no. If it is 1, it's allowed. If it is 0, it is not allowed. And the fourth one in the queue, it is DHCP-v6 options. So it is again some kind of flags that we indicate the link actually. We say that DHCP-v6 is allowed, and you can get this kind of information from DHCP-v6. For example, we have 2 different flavors of DHCP-v6 usage in IPv6. One of them is stateless, and the other one is stateful. So for the stateless one, we use the another flag, which we call O flag, and for the stateful one, the router will send you M flag. So there are 2 different flags in order to indicate the usage of DHCP-v6. And one more optional information that can be sent over the link by the router is MTU size, and we use this information in order to learn the PAT MTU size. So that's basically the list, non-exhaustive list of information that we get from IPv6 routers on the link. And how we configure our global unicast IPv6 address, that is shown here in the slide, in the bottom of the slide, you can see it. We have the link prefix, which is sent by the router. And again, we have the interface ID, which is configured by us with some kind of special procedure that we will talk about in the future slides. So we combine both of them with the link prefix and interface ID. We get our global unicast IPv6 address. And in IPv6, we have several kinds of different types of actually IPv6 addresses. So first of all, we have unicast addresses, and on each interface, we may have more than one unicast address, and we may have more than one multicast address as well. So what kind of unicast addresses we have? So basically, we learned about that we have link local address first, right? We learned how to configure it, and they are all starting with the prefix FE80 : and that's what you see here. FE80 : and then it goes on with the interface identifier, and it is actually the link scope address that you use in order to communicate with the hosts on the link. And we have global unicast addresses, which we actually can have more than one. So for example, for incoming connections, your PC or your laptop will have one global unicast address, and for the outgoing connections, you will have one more. So it may be the case for you. And You may even have more addresses according to the prefixes that you receive from the routers, or according to the manual configurations that you do on your host, on your PC or laptop, whatever it is. And for the multicast addresses, we have at least 2 different addresses that we need to configure on our host. And the first one is all nodes, which is kind of broadcast address, but it is not. It has the scope of link. It is FF02::1. And the second one is solo-sited node multicast address, which we have seen earlier in order to make the communication efficient on the link. It is starting with FF02::1:FF. So that is the fixed prefix for this type of multicast addresses. And as you can see, all types of multicast addresses are starting with FF. So that is important to notice, because if you see some address starting with FF, you will understand that that is a multicast address in IPv6. And for the routers, we have one more address, which is representing all the routers on the link. The scope of this address is link, which is FF02::2. So again, starting with FF, and it's obvious that it is a multicast address. So let's continue with another function of neighbor discovery protocol here, which we say verifying reachability or keeping track of reachability. So in NDP, neighbor discovery protocol keeps a table in order to keep the track of the reachability of the hosts over the link. So we again use the same types of messages here, which is neighbor solicitation and neighbor advertisement. So periodically, the nodes will check the neighbor's state. If it is alive, still alive, and if it is using the same MAC address, or does it change? Or maybe the host itself will go offline. So that's how we actually check the reachability of the neighbors. And again, we use, as we said, the neighbor solicitation, and we say, hello, are you still out there? Is your MAC address still valid or not? And it will reply back, if it is alive, hello, yes, I'm online, still online, and my MAC address is this. And if the target does not reply to the neighbor solicitation, then the sender or the host which sends the neighbor solicitation will remove the MAC address from the cache. So that's how it works. And what about the redirect messages? So up to now, we talked about the 4 different types of message types of neighbor discovery protocol. We talked about the neighbor solicitation, neighbor advertisement, router solicitation, router advertisement, so 4. But in NDP, we have 5 types of messages, and this is the 5th type. So this is redirect messages. It is IPv6, there is an IPv6 packet which is coming to a router, and in this case, router knows a better exit point for that network that the host wants to reach. So let's think about that. I have a router A here, and I have a router B over here, and I am sending my packet to the network X, which is outside of my network, and I'm sending my packet to router A in order to handle it and to reach out to network X, which is outside of my network. So basically, I'm sending it to router A, but router A knows that the router B has a better path to network X. And it sends me back a redirect message over the link, and it says that, hey, you are trying to reach to network X, but I know a better exit point from your network, so you can use router B. So it redirects me to router B, and I'm now changing my routing table to router B, and I'm sending my message to router B in order to reach the network X. So that's how redirect messages work. And this is the 5th type. So let's count it again: neighbor solicitation, neighbor advertisement, router solicitation, router advertisement, and redirect messages. So 5 types of messages. And hosts can be redirected for a better first stop router, as we discussed, and they can also be informed that the destination is a neighbor on the link. So it will say that you are trying to reach, and this host, this router is still on your link, so you can reach out to that one. And we are coming to another section with this slide. In section 4, we will discuss the addressing plans, actually. And I would like to, first of all, why we need an IPv6 address plan. I hope that it is obvious because it's really complicated and we have huge amount of addresses in IPv6. So it is really difficult to manage them actually without a plan. So I would like to read out loud the first item here. Why we need IPv6 addressing plan? Because it works for your mental health. So if you are dealing with IPv6, you will definitely need a IPv6 addressing plan, and it will help you actually to configure everything in a good way and without losing your mental health. And also, it will make easy for you to implement your security policies. How will it make easier for you to implement your security policies? Because we have an advantage with IPv6, you know. With IPv4, we were using addresses like, let's say, whatever we have at that point, we will use that one for this host. And after some point, we will use another prefix and another IPv4 address for this host, and it will be spread around. But here in IPv6, we are starting from scratch. So we have the chance to configure actually each of the hosts from scratch and with a good plan. So you can group your devices in a single prefix, because we have lots of addresses in a single prefix. Let's say you get a /48 as a business customer, or even a /56 as being a residential customer. So you can get addresses. So you can group your devices. For example, I always give this example. You can group your DMZ devices in your data center in a single /48, and then you can just configure a single firewall rule in your firewall or in your security infrastructure and say that, okay, these are DMZ hosts, DMZ router, servers, whatever it is, and it will be just a single rule on the security infrastructure, and it will be very easy for you to configure all of them. And with efficient addressing plan, it is scalable actually. So you would have a scalable plan, and you will never want actually to configure or renumber your hosts, your devices in your network in a few years, because it is really hard. So with a scalable plan, with a good plan at the beginning, you will achieve this. So many more years without renumbering your devices, you will survive. And at last point, but not least, we have more efficient route aggregation with a good plan. So it is really important because we have lots of addresses, lots of prefixes, and your routing table will go huge. Will be thousands of entries maybe in your routing table, and it is really important for you to keep it simple, to keep it really organized and summarized. So it is really important for the efficiency of route aggregation and route table management. And we said that already you need an addressing plan, but how will you do it? Without an IPAM tool, it will be very hard for you because your spreadsheet will not be scaled, will not be scaling actually. So I don't want to read all of them here, but let's think about the last two of them. Let's think that you get, as being an LAR, the minimum number, the minimum prefix size that you will get from RIPE NCC is /32. So with a single /32, let's say that you are an ISP, which you are dealing with broadband customers, and for each of them, you would like to assign /56 for each residential gateway. And with a /32, you will have more than 16 million /56. And even it is even worse with /29, as you can imagine. With /29, and it is actually the number that is the prefix size that you can get without any justification from RIPE-NCC. So you can just request /29. And what about the size of this? You will have more than 134 million /56 with a single /29. So those are huge numbers, and you cannot manage them with your spreadsheet or with your Excel sheet or whatever it is. So you will definitely need a suitable IPAM solutions, and that's why we recommend always IPAM solutions in our courses, in our tutorials. And what about the addressing plans? What are the considerations that you need to take into account while you are making the addressing plans? For each subnet, you need to give a /64. So you need to understand that the number of the hosts on a single subnet is irrelevant now. It's not important, because with a single /64, you will have thousands of addresses that you can address your host in a single network, in a single subnet. So the host number on the link will not be important anymore. So what you will count in your network is the subnets. So you need to count subnets, and for each subnet, you need to assign a /64. And with the IPv6, we actually have a change in the paradigm, because with IPv4, we were thinking about more about the conservation side of IPv4 addresses, because we were trying to keep them as long as possible with us. But in IPv6, it is in the second priority. I don't want to say that it's not important. It is important, it's still important, but it's in the second priority. So conserving is our second priority, but making a scalable and future-proof plan is our first priority. So, and in this third line here, we have the per pop thinking of IPv6. So you need to define POPs in your network, and for each POP, you need to assign a /48. So what is a POP? As I said, you will define it. And for example, a data center can be a POP, or a area in geographical area may be a POP for you. And you can use multiples of /48s in POPs. And for the enterprise customers, if you are an enterprise customer, or if you are an ISP and you are trying to give or allocate IPv6 addresses for the customers, then you can we recommend to give them /48s. And if you would like to give more than /48, you can do it. It is allowed, but you need to document it, because in case you need more IPv6 allocations from RIPE-NCC, you need to justify it. You need to say that, okay, I used /44 for my enterprise customers because of this, and you need to document this, you need to justify this. So that's something related to the procedures as well. And for the loopbacks, you can use a single /64 per POP, and you can just give your loopbacks out of this single /64, because in its 64, it will be definitely enough for all of your hosts in that area, in that POP, to configure all the loopback addresses. And what about the 64 story? It's coming actually from the old RFC, which is RFC 4291. And it says that every interface ID must be a /64. And all the other RFCs, all the newer RFCs are following this one, because we are now using the stateless address auto-configuration procedure. And as we discussed earlier, this procedure needs 64 bits in order to configure the interface ID. So in the procedure itself, it is defined that we need the interface ID, which is 64 bits long, and the prefix side is also 64 bits long, so you need to combine them. And this is the story behind the /64. So each subnet will definitely need to have /64. And the only exception for this is point-to-point links. For the point-to-point links, we always recommend to spare a /64, but use 1/127 out of this 64. We will explain this later in the slides, I believe. So, and we are reaching to another section which I will hand into Ferenc. In section 5, we will talk about the IPv6 packets and the different structures of it. Thank you, Ferenc.
Yes, so IPv6 packets, how are they different? How are they similar to IPv4 packets? And the most important thing is what you see here. They are fixed length. So an IPv6 header now is 40 bytes. And the optional headers are daisy chained. So modularly, you have extension headers if you need them, otherwise not. So as you can see, an IPv6 header is twice as long, 40 bytes, as an IPv4 header without options. And here you see a comparison between an IPv4 header and an IPv6 header. What you notice is that the width of this diagram is, of course, 32 bits. Not of course, but it is 32 bits. And you see the different, I don't know if you can read it, but you can see the different parts of the header. And fields that are kept and are the same are gray. The red, fields in red, for example, header length, well, it's always 40, so there's no point keeping that one. Those are not used anymore. These IPv4 header fields are not used anymore in IPv6. The blue ones, they are used, but they have a different name. And so what's important, of course, you have the version IPv6, and then these two are actually interesting because the traffic class is more or less the type of service here. Flow label, this was thought for real-time applications, so you could keep the packets of the application together, so it would have a different flow label. But in fact, actually, these two fields are not really used much in IPv6. What's important is, of course, the payload length. And so that is just basically the data. And the next header, that's important for implementing this modular style daisy chaining of extension headers. We are going to see an example in a moment. Hop limit, well, that's the same as the time to live, so that just counts down. And you can see how this looks like. You have the IPv6 headers, and then this is called the IPv6 payload, and that will include extension headers, and that's variable depending on the situation, how many and which ones you need. And then you have the payload, which includes, for example, upper layer protocol data unit, PDU. And this is how the whole thing works. So normally what you would have without the extension headers, you would have the IPv6 header, the basic one, 40 bytes. And then you have the, let's say the next level would be the TCP header. So notice here in the next header field of the IPv6 header, you'd have the number that corresponds for TCP, and then you have the data. But if you are, for example, if you use one of the optional extension headers, the routing header in this example, then the next header field will have the number corresponding to the routing header, and the routing header will have the number corresponding to TCP, and then here, basically, modularly, the different extension headers can be added in. Important things that are different, there's no more fragmentation on the way in IPv6, so the routers don't fragment packets in between. Fragmentation happens at the endpoints, and it's done by the host. If a packet is too big for the next hop, then it will get an error message, And this is, you'll see the MTU discovery in a moment. So it's an ICMP version 6 message, and also IPv6 relies much more heavily on ICMP than IPv4 did. So actually filtering ICMP version 6 causes much bigger and immediate problems with IPv6 than in IPv4. And so this is the path MTU discovery I mentioned, the sender, and you can see that here you have basically the connections have different capacities, and here you will have the first packet will be sent out would be the size 1500, and you can see this is no way is going to go through here, because here this is already narrower as it were. And so what happens at this point, the packet cannot go through. A packet is too big, so you get an ICMP version 6 error message back, and also with the suggestion of the size, so it would say 1480. So basically what the host does before it actually starts sending the packets, it does this discovery, and it discovers the bottleneck and will send the size packets that correspond to that can go through. The ordering of the headers, that's important. So even though the headers are optional and you can use the ones you need or none, once you use headers, they have to go in a certain order. We'll see that in a moment. And depending on the type of headers, only the hop by hop header has to be processed by every node on the path. And the routing header has to be processed by every router. And as I said already, fragmentation happens at the end and the beginning. So it has to be, and it has to be processed before all the others at the destination. And this is the ordering of the headers. You can here also see then the different headers. So the first one is the basic IPv6 header. And then you have the hop by hop options. You have the destination option. This is the only one that appears twice. So here you have the destination options for the routing header. Then you have the routing header, fragment header, authentication header, ESP header, destination options. So you can see that the standard destination option, and then the upper layer PDU. So the data. And if you use any of these headers, it has to be in this order. Some peculiarities, we both mentioned this before. IPv6 has no broadcast. It has multicast, but there is an all nodes multicast group, and you can see the the address of that multicast group behind me. Well, why did they implement this? Well, the disadvantages of broadcast was that it wakes up all the nodes, even nodes that don't need to process the information, and it could create broadcast storms. Typhoon explained to you neighbor discovery, and it's important to realize that the neighbor discovery actually is used for many different purposes. So it's like a multi-use tool for address resolution, so what used to be ARP in IPv4, to finding neighboring routers, to track address changes, to check neighbor reachability, and before you start using an IPv6 address, you do duplicate address detection, and that's also done with neighbor discovery. And Typhoon already mentioned the 5 different neighbor discovery packets, the different ICMP version 6 packet types that neighbor discovery is using. So that was just a brief introduction to packets, and now I'd like to talk about deploying IPv6. Basically 2 or 3 basic services. First of all, the assigning of the addresses. You already saw that a device can have many different types of addresses at the same time. And also these addresses can be assigned in different ways. So there are several options. Of course, the most straightforward, but one which you actually want to avoid doing for all the devices is manual configuration. You just configure the device straightforward. Then you have the router advertisement, and Typhoon explained to you how that is done, how the stateless auto configuration is done. So with the router advertisement, it will hand out the prefix. So that is done with Slack. Then we have all kind of combination. We can have the router advertisement and DHCP on the side. So for example, from the router advertisement, you will get the, you could get the addresses, and from DHCP, you can also get the addresses. As I said, you can have different types of addresses at the same time. And the way it is done is in the routing advertisement, there's a flag, a bit, the M flag, and if that one is on, that stands for managed, and managed in that case means DHCP. So you get your addresses from DHCP, but you also have the router advertisement, so you can also get it via Slack. Then you have router advertisement with the DHCP with the O flag. That means other. That means you don't get your addresses from DHCP, but you get other information. For example, the address of the DNS server. And then finally, you can switch off auto configuration, and you do that with setting the A flag to 0, not to 1, and that's what you see here. So you have router advertisement with the A flag on, A flag off, sorry, no Slack, and DHCP with the M flag on, so the addresses only come from DHCP. And the gateway is always provided by the router advertisement. So again, as you've seen, the router advertisement gives you quite a lot of information. So it gives you the default gateway address, then which prefixes to use on the link. Is Slack allowed? So that is the 3 flags, the A, the M, and the O. Is DHCP available for address options, the M and the O flag? Only options. What is the preference of the router on the link? DNS servers and NTU size. This is optional. So you can have all this information in the router advertisement. Now for the configuration for the whoops, that was the screen. For the auto configuration, what we had originally is we had stateless auto configuration where you got the prefix from the router advertisement, and the host part, the 64 bits of the host parts were done using EUI based on the MAC address. Of course, the disadvantage of this is that even if you moved from one network to the other, the host part would be always the same, and it would be always based on your MAC address. So that was easy to follow. And that was actually, there were privacy concerns, and that's why they came up with something called stable semantically opaque addresses. And that basically works exactly the same way, except without the privacy issue, because we'll see that in the next slide how that works, because it cannot be linked anymore to your MAC address, but still it will be the same address every time, and each device will have its unique address. Then you can also have temporary address extensions, and that is basically every time you start the device, it will get a new address. It doesn't keep the address as it does with the first 2 options here in this slide. So let's have a look at this stable semantically opaque address. It's so the IID bits, so the 64 bits, the host bits, are opaque, meaning it doesn't have a value or a meaning. And how do you generate it? It is different for each interface. It is not related anymore to the interface identifier, so not related to the MAC address, but it stays always the same when the interface is connected to the network. So this is now widely used and standardized for stable addresses. For DHCP, you already saw how that works in connection with router advertisement. It's used to give additional information to like DNS servers, in addition, of course, to the prefix. And the router advertisement message can contain hints. I told you these three flags, the A, the M, and the O. If the managed flag is 1, this means use DHCP to get your address. Optionally, it can provide the address of the DNS server, so that will be then using the O flag, meaning other information other than the address. And you can also disable, you saw that with not using the A flag. So this is just a scheme how that works. That is when you get your addresses from the DHCP server. So it starts off at the left-hand side. You see the host, you see the DHCP relay on the router, and then here you see the DHCP server. So the hosts want addresses from, they want to use the DHCP server, so they will solicit the services of the server. This will be relayed as to the server solicitation. It will advertise the services, and then it will actually request the addresses and get the addresses in the reply. So that's the scheme of things. If you are using the other flag, then basically the other information, then it is information request, which is relayed, and then you have the reply, and basically the information gets to the hosts. And the question now, of course, is DNS in IPv6 difficult? And what we're trying to say, it's not difficult because it's not IP layer dependent, so it works the same for IPv4 and IPv6. Basically, it's just different records. You have A records for IPv4, quad A records for IPv6. You don't have different DNS for IPv6. And the important thing here is what we like to say is don't try to be too clever. So what can happen is you can have a request for a quad A record that comes in via IPv4, or the other way around, a request for an A record for IPv4 that comes in through an IPv6 connection. Don't say, oh, this is an IPv4 connection, so perhaps you are wrong in what you are asking. I'm going to give you the information for IPv4. Just accept they know what they are doing. So if you get such a request, just answer the request and don't try to answer based on the protocol. There's an only exception for this is translations, for example, NAT64 and proxies. So that was basically it. And now we'll go and talk about transition mechanisms, which is quite important.
Thank you, Ferenc. Yeah, in this section, we will talk about the transition mechanisms actually, which is actually quite important for the networks nowadays, because you need to transit your networks, you need to convert your network from IPv4 to IPv6, and you need some temporary solutions, just like the transition mechanisms we have. So with the transition mechanisms, actually, we are trying to solve two different problems. And one of them is coping with the scarcity of IPv4 addresses, because as you may already know, we don't have enough IPv4 addresses. So I'm just joking. But we have some workarounds that we are using right now. One of them is NAT, and you can call it like the other names are CGN or carrier grade NAT or LSN, large scale NAT. But basically, they are translating some private addresses, private IPv4 addresses, or even some public addresses into public addresses again, in order to make use of one public address for many hosts. So you are sharing a single IPv4 address with the hosts, with some hosts. And we have some challenges and we have some issues actually with net, because first of all, it's hard to maintain and you need to spend more and more as the time passes. And it's also hard to troubleshoot it. So it is also breaking the end-to-end paradigm of IP communication. So it is a challenge in our way. And also, when you have some investigation, for example, a lawful investigation for your hosts on the network, then you need to keep the logs of net in order to answer the questions about the past. So that is really hard, and we definitely need a better solution. And the second problem that we have here is providing an IPv6 connectivity to the IPv6 only networks that we see in the internet right now. So there are some networks that are only using IPv6, and we need to find a way to communicate with them. And that's why we created, or why we invented, these transition mechanisms. And we have actually 3 different types of transition mechanisms. The first one is tunneling transition mechanisms, which is actually encapsulating one protocol into another one. And the second one is translation type of transition mechanisms, which is translating one protocol into another one. And the third type is pretty straightforward. We use both of them natively. It is called dual stack. So under these types, we have different branches. Like in tunneling, we have V6 in V4, and under this we have 6 and 4 and 6RD types of transition mechanisms. We have V4 in V6, it's other way around, and we have DS Lite and MAP-E as the examples of this type of transition mechanisms. We have translation type of mechanisms like V6 to V4 and V4 to V6, but V4 to V6 is not used anymore, it's deprecated. So we have just V6 to V4. NAT64, 464 XLAT, and MAP-D are types of this kind of transition mechanisms. And for dual stack, we don't have any other branches because it's, as I said, it's pretty straightforward, and we use both protocols natively on a single host. So let's continue with the examples of transition mechanisms. The first one is a tunneling type transition mechanisms, which is 6 in 4. So in this step, we configure the tunnels manually, and we configure the tunnels to a broker device, which is tunnel broker. We call tunnel broker device, which is outside of the ISP network. So, for example, a Hurricane network, Hurricane Electric provides a solution for this, and they provided a tunnel broker device, and you can just configure your tunnels to their tunnel broker server. And since it is manual, it is not scalable, of course, because you need to create, if you are thinking about a real network, not a residential network or home network, a real enterprise network, an ISP network, you need to create hundreds or thousands of tunnels. It's not manageable, it's not maintainable, so it is not scalable, of course, but it is good to have it in order to try V6 over V4. So in this one, since we are encapsulating V6 packets inside the V4 packets, you don't need to, your ISP doesn't need to support IPv6 because it will not be aware of your IPv6 traffic because you will just encapsulate V6 into V4. And we will say this for each kind of tunneling transition mechanisms. MTU should be considered while we are making, adding another header into your packets. And that's what we do in tunneling transition mechanisms, because we encapsulate V4, in this one, V6 messages or packets inside the V4. So we add another packet header. So MTU should be considered. And that is the basic drawing of this. Actually, we have the home user, which would like to send some kind of IPv6 packets. So it encapsulates the messages or packets inside the V4, and it sends through the provider network to a tunnel server device, which is outside of the ISP network. And then the tunnel server device just gets these messages and decapsulates the packets and sends them to the IPv6 internet. That's the basic drawing of it. And with 6RD, it is another type of tunneling mechanisms, and it's again encapsulates actually the v6 packets inside the v4. But this time, this is automatic. And since it is automatic, as you can imagine, it should be supported by your CPE or the residential gateway device. So your CPE or residential gateway or modem, whatever you call it, it should support 6RD first. 6RD stands for 6 rapid deployment, but you can also read it, you can also remember it with the name of its inventor, Remy Desprez. But it's actually coming from rapid deployment because it is automatic, it is some kind of scalable, so it brings you some rapid deployment actually. And in this one, there's also another important difference other than the previous one. We said, first of all, the tunnels are configured automatically, and the second difference is in this one, the operator has the full control of the IPv6 device, IPv6 tunnel broker device. And since it has the control of the IPv6 tunnel broker device, it has the control of the IPv6 ranges that is being used. And also, the provider can offer some kind of quality of service in this one. So let's check the drawing of it. So we have again the home user, which is trying to send some IPv6 packets to the IPv6 internet, and it encapsulates the packets into the v4. The provider doesn't need to support the IPv6 anymore, the IPv6 for the connection facing to the customer, but it has the 6RD tunnel server. So you just automatically configure your tunnels to this server, and then they are decapsulated. The packets are decapsulated there, and you just send your packets, IPv6 packets, to the IPv6 internet. So that's basically how it works. And with this one, with this new technique, the S-Lite, we are reaching to another category of transition mechanisms. It's again tunneling transition mechanism, but it is different because this time we are encapsulating v4 messages, v4 packets inside the v6. So as you can imagine, this time your provider network should support IPv6 because you will be sending IPv6 traffic from now on. And since we are sending IPv4 inside the IPv6, this type of solutions known as IPv6 only solutions, or in another naming, we can say that IPv4 as a service solutions. So DS-Lite is one of them. And in DS-Lite, actually, it allows clients to use the private IPv4 ranges inside the residential networks and without doing NAT themselves. So the devices, the residential gateways, actually does not do NAT inside the residential gate, and residential network. So they just encapsulate the packets into, they just encapsulate the v4 packets into the v6 and send them to the locally or centrally located NAT device in the provider network. And let's check the diagram of it. So this time, as you can see, we have the v6 connection to the ISP network. And with this one, we are sending v4 packets inside the v6 packets. And NAT44 box, which is centrally located inside the ISP network, just actually decapsulates these IPv6 packets, gets the IPv4, and apply the NAT44 process over them and send them to the IPv4 internet. And there's a funny thing actually here. In this technique, we call the CPE device or the residential gateway device basic bridging broadband device. So basic bridging broadband v4. And the address translator, NAT44 box, is called address family translator, AFTR. So it is before and after. So in DS-Lite, maybe it will be easy to remember. In home device, we call it basic bridging broadband, which encapsulates the packets. And in centrally located NAT device, we call it address family translator. And as you can imagine, again, your residential gateway should support this type of technique because it needs to know the centrally located NAT44 box, and it should send the packets to them, and it is the process it needs to follow. So that is actually how we do DS Lite, and as we said, it is an IPv6 only technique. And with this one, we are reaching to another famous and mostly used technique, which is NAT64 and DNS64. It is actually, again, a single stack transition technique, and in this one also we use V6 connection. So our host will only support IPv6, and whenever we would like to reach to IPv4 network, we need to get the packets translated over a NAT64 device with the help of DNS64. And we say that it requires some kind of DNS magic, and I will explain it actually in the next slide. And the DNS will capture the responses and replace DNS A replies with the quad A replies, which is actually representing the IPv6 addresses. And it usually implies address sharing in IPv4 as well, because we will be using NAT in any way. And here, it is actually the drawing of it. We have home user, which is connected to the provider network with IPv6 only connection. So in this one, first of all, we need to send a DNS request to DNS64. We will say that, okay, I would like to reach to this site, let's say www.google.com, and then we will request the IPv4 or the IP address of that website. And DNS will ask it to the authoritative DNS, which is outside of this network, or maybe inside of this network as well. And it will get reply back as the A response for IPv4 only sites and the quad A response for the IPv6 only sites. But Google is not a good example here actually, because Google has IPv6 already supported. So for the IPv4 only sites, we will only get A response from the authoritative DNS. And then DNS64 will convert it for us to a quad A response, and it will send it to the residential gateway or the home user, and that conversion will be done according to a rule. So the rule is, it will be combining the prefix that is defined for the NAT64 box in the network. It will combine this prefix with the A response it receives, and then it will invent the quad A response for the host to be used, and then the host will reach to NAT64 box, because that prefix that DNS64 is using is routed always to NAT64 box in that provider network. So that's how it works, and I hope that you will understand it better in flow diagram. We also have a flow diagram for these messages. But we have some challenges actually for this type of communication, because we already assumed that we need to connect to DNS64, DNS service. But what if we do not actually use DNS? So let's think about that. We just write IPv4 literals to the browser, and we would like to reach to the website, or we would like to use an FTP service, which we don't use, for example, the DNS help. So in this case, we need to find another way to convert our IPv4 literals to the IPv6 addresses that can be used to reach to NAT64 box inside the network, and that is what we call, this extension is called 464XLAT. And in this technique, we have two different processes or two different nodes that are actually helping us. So the first one is CLAT, actually, and it is inside the residential gateway. So how it works, we have the mobile terminal. This is a mobile representation of it, but it can be also a residential network as well, so nothing different. In mobile terminal, let's think that we have the function CLAT, and CLAT knows the prefix to reach to PLAT box, which is actually doing the same function with the NAT64 box that we have in the NAT64 technique. So a CLAT process combines the prefix that it knows to reach to PLAT box with the IPv4 address that we have written to the browser. Let's think this scenario. And then this combined address will be the destination address of our message, and eventually it will be forwarded to the PLAT box inside the provider network. And the PLAT box will get this message, and it also knows the prefix, and it will strip it off, and then the last 32 bits will be converted back to the IPv4 address, and it will reach to IPv4 address after a translation, after a 6-to-4 translation. So that is basically how it works, but I would like to also make it more clear for you with the flow diagram. So you will see first how NAT64 works, and this in the second part you will see how 464 XLAT works. So let's check the first message of NAT64. So the computer will first send an A or quad A request to the DNS server, DNS64 servers. Then DNS will forward this message to the authoritative DNS, and it will get reply back with a single A request, because the site that you are trying to reach has no IPv6 support. So you will only get A response, not the quad A response. And DNS will do the magic here, and it will combine the pre-known or pre-configured prefix with the real A response, and it will send you as the quad A response. So you will assume that that site that you are trying to reach is supporting IPv6. And then you will send your message, your session, to this IPv6 address, and it will eventually be received by NAT box, NAT64 box, or we call it PLAT box in 464. So it will be converted back to IPv4 session, and you will reach to the application server. And then you will get the response to your NAT device again. Sorry, okay, I will go back. And eventually the message will be received by your computer or host. So that is how NAT64 works. And how 464 XLAT works, actually, we have again the IPv4 session request, but this time we do not use NAT64 because we don't need it. We just write the IPv4 literals. And this time CLAT gets into process, and it converts this session into it converts the destination address, this destination IPv4 address, into IPv6 destination address by combining the pre-known prefix with the IPv4 address that you have written to your browser. And then you will reach to the NAT box, and it will be forwarded. It will be first converted to the IPv4 again by stripping off the prefix, and then you will reach to the application server, and in return, the response will be sent to the NAT box again, and it will be reaching to your CLAT function, which is inside the residential gateway or user equipment, and then it will be converted back to the IPv4. So you will reach to that application server, and session will be established. As you can see here, in 464 XLAT technique, we are using two different translations, one to another. So that's basically how it works. I hope it is clear. We can discuss it later as well. And now we are new category of transition techniques, which we call it map techniques. Actually, it can be in both flavors. It can be either encapsulated or translated. So both kinds will be working, and both of them are IPv6 only techniques. They use, actually, both of them use map rules, which are quite complex rules in order to convert IPv4 addresses into IPv6 or encapsulate them into IPv6. And it also carries layer 4 information as well inside the IPv6 address. So you will use this technique with some help of the router that is delivering the rules to the network or the server. Both of them uses the stateless NAT44 function inside the operator network. So it allows you to have asymmetrical traffic routing, and also it allows you to expand your capacity easily. So it is easy to scale. And in MapE technique, what we do actually, our host has public IPv6 address and private IPv4 address, and we have the customer equipment. And in this one, first we need to have a stateful NAT44 and then encapsulate this packet into an IPv6 with the complex rules that I've just explained, which we call map rules. And then map border router receives this traffic and it converts it back to the IPv4 and sent to the IPv4 in order to reach to the IPv4 network. So here we use 3 different processes. Can you follow them? First, on the CE device, NAPT, and the second, encapsulation on the CE device again, and in the map border router, a stateless NAT 6-4. So it is the idea behind this technique. And what about the MapT technique? This one is a translation technique, actually. The previous one was a tunneling technique. And in this one, we use, again, on CE device, it is similar, it's starting as similar. So we use, again, a stateful. So it should keep the state, the device should keep the state. We use stateful NAT44, and then we translate this to 4 to 6, so double translation here. And in the border router, we translate it back from 6 to 4. So 3 different translations in this technique. But in each of them, if you can follow, map border router does the stateless translation. So that's why we say, actually, it allows you to have asymmetrical traffic, because you can just put another device inside your network and you can expand the capacity. And it is also scalable for your network. It is easily scalable. And what about the dual stack? This is the last transition technique that we call, and it is maybe in the past mostly promoted one. But nowadays, it has some challenges, because as we already have the IPv4 scarcity, it is difficult to use dual stack technique from now on, because you need to have enough IPv4 addresses in order to use this one, or you should keep using NAT functionality inside your network in order to be able to use this one. So if you would like to still use a dual stack, if you would like to have, for example, a gradual transition from IPv4 to IPv6, and if you have enough IPv4 addresses, go ahead, use it. It is easy to use, and it is very, very common and very popular. But we can say that as the IPv4 scarcity grows nowadays, IPv6 only techniques are gaining momentum. So you need to consider this while making a decision for your own network. So it is actually a decision for you to make for your own network according to your needs, according to your level of needs and level of IPv4 that you have inside your network. And in the last section, we would like to give you some tips about your transition. How to get started? How to get started to use IPv6? So first of all, you need to change your purchasing procedure. So for each procurement or new purchase, you need to consider IPv6 priorities. So you need to have, for example, you request some feature for IPv4, you need to request the same for IPv6 as well. That's important. And you need to check your current hardware and software as well, if they support IPv6 at the same level that it supports the IPv4. So you need to have the feature parity for that one as well. And you need to plan and test every step. And it is obvious that you will need a good lab environment in order to test everything. We recommend you to have a transition one service on one service at a time. For example, you can go first for the internet-facing services, like the servers that you have, application servers. You can make them dual stack, for example, and you can try to reach them over IPv6 first. And then you will go for core network. You will you will make a transition over your core network. And finally, maybe you will come to the customers and you will make a change for them. So each step will go after the previous one. So plan your steps and adopt a phased approach to IPv6 transition. And in order to make your purchases and RFP write processes easier for you, we have documents at ripe.net site, and one of the most useful one is RIPE 772, which is actually listing all kinds of RFCs that needs to be supported in order to properly support IPv6 in your network. So it has a very well structured or organized structure, we can say. It is divided according to the device type, and for each device type, you can have different kinds of RFCs listed there in order to be supported in your network. And it is coming from actually RIPE 554, and it was originated by the Slovenian government first. It is then adopted by various other governments like Germany or Sweden, and you can reach, I hope that you will be reaching to these slides over ripe86.ripe.net site. So you can just click the link here and go to that document directly, or you can just search RIPE 772 inside our website. And troubleshooting for the ISP help desk, this is very important because ISP help desk will have no information about IPv6. They are usually don't have much experience with IPv6 issues, and it is really important to help them. And we have a document, customizable document for it, which is RIPE 631. You can use it, you can customize it according to your needs, according to your network, and it will help you to help your help desks. A lot of helps. And what about the customers and their 48s? As we said, for your residential customers, we recommend to have /56, but your enterprise customers, we recommend you to have /48. So in a single /48, your enterprise customer will have more than 65,000 subnets or /64s. So you need to help them in order to manage their network, and you can provide this document to them in order to help them. It is called Preparing IPv6 Address Plan, and it will help them actually to configure or have a good addressing plan for their networks. And again, we have the link to this document. And finally, we have some don'ts for you. Please don't separate IPv6 features from IPv4. So from now on, even if you are not using IPv6 now, you need to request the same level of feature parity with IPv4 while you are making a new purchase. Don't do everything in one go. Adopt a phased approach. Don't appoint an IPv6 specialist. You don't need it. You will just learn IPv6, how it works, and then you will do it by yourself. And do you have any IPv4 specialist? I don't think so. don't see IPv6 as a product. The internet is the product, actually, and that is it. So in order to help you more, to learn more about IPv6, we have websites for you. The first one is academy.ripe.net. Actually, you can use this website. It is prepared by us. So we are putting a lot of effort for this, and it is very well structured. We have 2 different courses for IPv6 already. You can check IPv6 fundamentals first, and then maybe you can go even further with the IPv6 security. And if you would like to show your knowledge about IPv6, we have exams for you. We have certifications, which we call RIPE NCC Certified Professionals. You can reach to these certifications or the scheduling of the exams through the website getcertified.ripe.net. We have 4 different certifications now: IPv6 Fundamentals, RIPE Database, BGP Security, and IPv6 Security. So you can show your knowledge in your social media profile, maybe. So that's it. And if you have any questions, me and Ferenc would like to help you, or if you don't have them even here, we can also discuss them in the coffee break, whatever you like. So that's it. And thank you very much. Thank you for your participation. Thanks. Yeah. Any questions? Okay, then. Thank you very much. Thanks.
Hello? Hello, yes, you can hear me now. Welcome, everyone. We just wait maybe another minute to see if more people are coming in, but this is a very large room, so it looks like it's a little empty on one side, but I think we actually have a lot of people here. We have, I think, over 200 registrations from newcomers, and I don't know how many people have checked in by now, but I see more people are still coming in. So this is the newcomer session. If that's what you're here for, then it's the correct room. My name is Mirjam Kühne. I'm the vice chair, but I'll tell you a bit more about it in a second. Let's see, it looks like we can start. Yeah, I wanted to ask you first, I can't really see you very well, but I wanted to ask a few questions. So how many of you here are from the Netherlands? Fair share, that makes sense. How many of you are students? Oh, great, great. Yes, we want students, we want new people and young people. And how many of you have participated in the online session that was presented like 2 weeks ago? Oh, okay. So there will be a little bit of overlap, but it's not going to be too boring, I hope, for those who have participated in the other session already. And also we have remote participants. I don't see that from here, but I believe Neil, who I'm going to introduce you in a second, he will be there for you who are participating remotely. And I hope you also feel welcomed and included in this session. So let's get started. Welcome to RIPE 86. This is actually the second time we are in Rotterdam. We had a meeting here in the RIPE 79 just before the pandemic. That was the last meeting before we went all fully online. The first meeting took place in Amsterdam, so we can have a habit to come back to the Netherlands from time to time because that's where it all started, if you will, and that's also where the RIPE NCC is located, and they are doing, of course, a bulk of the organization here for the meeting. Yeah, as I said, my name is Mirjam Kühne. I'm from Germany originally, from Berlin. I studied computer science at the Technical University in Berlin, but I already live in Amsterdam for more than half of my life, I think, by now. And I've been selected the RIPE chair in 2020. So I kind of started right in the pandemic. We had a few online meetings, but now I've chaired like 2 physical meetings already since then. And we also have a vice. Is my microphone still on? Yes, good. Okay. Yeah, there was a bit of an echo, but I think it's good now. We also have a vice chair, Neil O'Reilly, who is sitting right there. He's been involved for even longer and has been involved in the RIPE community also for a long time. And he will also help you with questions that you have on Meet Echo for those of you who are remote. And yeah, there's his email address as well. It's a bit of a blast from the past here, just for a bit of a fun. I mean, some of you, I don't know if some of you had the machine on the left, but I didn't. I had an Atari when I started. Oh, this one, I had one of those. But what I found more interesting maybe is the one on the other side. This is actually the network diagram of the internet in Europe at that time in the early 90s when the RIPE community started. So at the time we would collect these maps, update these maps from time to time, and there was a new link. Everybody got excited. You link from one country to another, and that was how we kind of kept track of the network growing over time. You can't really read it here, but most of the networks at the time were academics and NREN networks, that were the community kind of almost got born out of the academic and the NREN community, and many of them are still involved. And also, it's great to see also a lot of students now here at the meeting. Neil, are we ready for a poll? We're not ready for a poll. Well, maybe I'll just do a call of hands then, show of hands. At least here, I don't know about the people on Meet Echo, maybe they can put something in the chat. I just wanted to ask you, yes or no, do you know the difference between RIPE and the RIPE NCC? Yes? And no? Good. So this is not all for nothing. So it's kind of half-half. So we're going to explain this to you. So I'll start a bit with a quick overview of the difference here. So the RIPE community, which is basically what this meeting is all about, it's a community meeting, it's open to anybody, was formed in 1989 by a bunch of scientists and researchers, as I just mentioned. It's still pretty much the same format, except it's a bit bigger now. We have more working groups, maybe more topics to discuss. But it's still a lot about information exchange and about coordination and collaboration, and specifically about coordinating certain technical aspects of the way networks connect, right? Because you have control over your network, and your competitor maybe have control over the other network, but how do you communicate with each other? So there are obviously some aspects and some parameters that need to be coordinated. And that's how it all started. And that's also where the policy development comes in, where we're doing policy about who gets how many IP addresses under which conditions. And that's all developed in the community in an open forum. Anybody can participate. You don't have to be a member. You can come to the meetings, but there are also mailing lists. I'll get back to that. And then we have the RIPE NCC, the RIPE, or maybe I should actually say what this all stands for. And RIPE stands for Réseau IP Européen, which is French for European IP Network. And then the RIPE NCC, as the RIPE Network Coordination Center, was founded in '92 by the RIPE community as the secretariat. So in the beginning, the community organized the meetings, and somebody volunteered to host the mailing lists, and somebody volunteered to write the first instance of the RIPE database. And then at some point it grew bigger, and the people felt, well, it would be nice to have some paid staff to handle all these logistics and the administrative support. And that's how the RIPE NCC was founded. In 1992, it then became a membership organization, and it still is today a membership organization. It has become, quite quickly after it was founded, also the IP registry for this service region. So because the RIPE NCC had already earned all the trust by the community, it was providing good services, community felt like, well, it's only natural to ask the RIPE NCC also to do the distribution of IP addresses here in this region, rather than having to go over to the US, for instance, at the time where the IP addresses were handed out by IANA. RIPE NCC has staff, paid staff, it has a board, they get elected by the members, and they're the ones who, then the NCC is the ones, and the NCC members are the ones who implement and follow the policies that are developed here by us, by the community in this open meeting. So it's quite an intricate, but really well thought through a relationship that's been worked for over 30 years now. And it's a bit confusing sometimes during the week, because there's also the members meeting on Wednesday, the general meeting. There's the managing director of the RIPE NCC who will speak here in a second, and the board members, they're all here. So we try to put those two entities, if you will, together here, that it's easier for everybody to participate. Coming back to the community here, to the meeting, there are a number of working groups that you will see also meeting during the week. I'm not going to go through all of them here. You can find information on the website, and hopefully you already had some time to prepare before the meeting, so you know what you want to attend, and what the scope is, and the charters, and the current work items, and who the chairs are. And there's some new chair selection also regularly in most of these working groups. But as I said earlier, you don't even have to be here at the meeting. All of the working groups have mailing lists, and even though discussions might take place here during the meeting, all the decisions, specifically when it comes to policy and consensus building and consensus decisions, they are all confirmed on the mailing lists, and most of the important information are on the mailing lists. So yeah, have a look, subscribe to some of the lists. And most of them have kind of, it goes in waves, quiet, and then a big topic happens, and then there's some discussion. So it's not too much traffic. And if you don't really know, which topics to follow, the RIPE list is a good place to start. It's usually where we make the general announcements, and where topics that are of interest for the entire community are discussed. And there's a link to that, but all the slides are online also, you can find that later. So to give you a bit more information about this meeting here, RIPE 86, We are already at 86. There is a meeting plan you can find on the badge, but also online. Online is usually most up to date. So sometimes there's some small changes. For instance, we changed the rooms for the bath on Tuesday. You know, just in case you want to participate in one, we have a look at the website. And the meeting plan on the website is also interactive. You can click on them, on the items there, and then you see the agendas of the sessions. And talking of BOFs, that stands for Birds of a Feather. That's basically a bit of an informal meeting. Birds of a Feather, what was it again? Flock together? Is that correct? Yes, thank you. I always get it, you know, just right, but then a bit wrong. Okay, anyway, that's a way of people to, it's not a working group, it's just a one-off meeting where people that have interest in one specific topic come together. Let me start with the ones on Tuesday, tomorrow, because they are these one-off meetings that I mentioned. One is about artificial intelligence and what impact might that have on our community as network operators. And then there's another Birds of a Feather meeting also organized by some participants from the IETF. It's kind of a bit of a partner organization. They built the standards that most of the operators are then using. And so they're going to talk a bit about what they do and how to participate. And then today, Monday, there is a session that's called the Best Current Operational Practices Task Force. And that takes place at the end of the plenary today. And they have some really interesting topics currently also to discuss, for instance, how we can learn from to keep your network resilient, and what experience people have made that they have to rebuild their networks, and how we can all learn from that. So there might be an interesting session to attend. Another session I want to draw your attention to is on Thursday. So you'll see on the agenda there's plenary sessions mostly today, tomorrow, and then Wednesday, Thursday there are working group sessions, and then on Thursday afternoon is a community plenary. Like a wider community plenary that is chaired by the chair team. And then after that, we have a session about diversity in tech. And this time we actually want to focus on age diversity, if you will, you know, how to get more young people into the community. What can we do, you know, to feel, to make you welcome, and to stay also involved, and for you to be more actively involved. So there's also more information on the website. There are a number of ways you can participate. Come to the you know, the microphone and speak up and ask questions. You can also everything kind of works on this Meet Echo app that you probably have seen when you registered. You received the link and how to participate there. You can join the audio queue. You can come then to the mic, or you can also ask questions in the Q&A. We're going to explain this a bit more tomorrow in the opening plenary, just so you can already have a bit of a preview and have a look at that Meet Echo app, because that might be new to you. There's also a chat in Meet Echo, so everything is kind of now coming together in this platform that you can use here on site, but also people remotely can interact with, hopefully be easier with those that are here in person. Click. What am I doing? Yes. Well, by participate, I mean, you're already here, so this comes a bit late, but what I hear from others, why this is useful, why it has been useful for people to participate. Obviously, especially for young people and people just started coming in this community, there are so many experts here and so much expertise on various topics related to networking. It's a really good source, you know, for you to tap into and to find out more about any projects that you're interested in. And don't be shy, and also, you know, don't be shy to, for instance, come to ask me. I mean, I know a lot of people in the community ask me if you're interested in a certain topic. I can try to find the right people to talk to. Then, of course, we also have WAP and CC staff here that Hans Peter is going to talk about. They can also help you. And it's, of course, a good way to build your career, also build, you know, networks with the people that you, you know, might use in the future, and thereby also help shape the internet. You know, but there are some important topics that we'll have to discuss also during this week. The program committee is mostly responsible for the plenary agenda, as I said, today, tomorrow, and a bit on Friday. There are some elections going on this week, so if you're already keen to join and work more actively, they're actually looking for 2 new members for the program committee, so you can nominate yourself or nominate someone else, and you can vote online during the week. This is the current program committee. See the faces, but you will see them also in the sessions. They're going to be very visible. And you can also rate the talks, which is a good way to provide feedback to the program committee. So they really like you to do that. And you can even win a prize. Obviously, we have a RIPE code of conduct, very important. You should have seen that when you registered and kind of checked that you've read it. It's basically, we're open and we're quite a diverse community in various aspects. Could be more diverse, but it's quite diverse in various aspects already. And we want you to be open, respectful to everybody, listen, to what others have to say, show tolerance and respect. Now, if you don't, there's a lot more. This is just a snippet. It's not the full code of conduct, but this is the main point. But if you experience anything that you don't like or you think violates the code of conduct, there's a team now. Actually, I'm super happy to announce this because it's the first actual real code of conduct team that we have here in the RIPE community. Most of them are here. Randy Bush, unfortunately, is only participating online, but he's also following, and they have a mailing list. You can reach them, and there's a form on the website. So don't be shy. If there's anything that bothers you, you can contact them and report. As I said earlier, all the features are basically on the Meet Echo app. You can schedule meetings through that and find other attendees. And of course, there's also an attendees list on the website that you can find the other attendees. Now, I skipped the most important part, the social events. We have quite a number of socials. The RIPE meetings are famous for their lively social events. And there's, of course, a lot of coffee breaks and lunchtime where you can meet others. But there are some specific social events tonight. There's a welcome reception here in the venue. Tomorrow, there is like a networking event, like a party, if you will, in the silo, in the Maas silo. It's an old grain silo here at the not so far, I believe, north from here. And then on Thursday, we have a RIPE dinner on a boat that you can participate if you have tickets. So you need a special ticket for that one. And on Wednesday, it's a DIY social evening, so you can hang out, relax, and rest, or you can also, of course, meet with others and find something else. Yeah, last but not least, there's also, especially for you who are students or come from an academic background, there's a session tomorrow evening, I think just before the social starts, that you might be interested in participating in. There's a feedback form. Maybe you can, collect your thoughts during the week and give us some feedback later. I think that would be really helpful for us. And of course, if you need any other support, there's a meeting team. This is Alexandra Voss. She's always there, running around. You'll see her. She's our main contact. And there's an email address you can reach, meeting@ripe.net. And these are the people in the red shirts. Do we have any meet and greet people here in the rooms? There are people with red shirts, but they're not the meet and greet staff. But they have hoodies, red hoodies, and they're walking around. And there's also a meet and greet desk. And you can ask them anything. They know at least how to find the answer if they don't know by themselves. So. And that's all from me. And there is also a section here from the RIPE NCC. As I said, they have a lot of staff here this time because the office is in Amsterdam, so it was a good opportunity for the RIPE NCC staff to come and meet the community. So you will meet many of them here in the hallways, and they're always there to help. And they have some great staff and great expertise. And then I would like to hand it over to the managing director of the RIPE NCC, Hans-Peter Holen, who's going to tell you more about the RIPE NCC.
So thank you, Mirjam. So I'm Hans-Peter Holen, and I'm the managing director for the RIPE NCC, and I've been so for 3 years now. Mirjam already told you about the RIPE community and how RIPE NCC was set up in 1992 as a membership organization and to support the RIPE community. We're also the regional internet registry for Europe, Middle East, and Central Asia. And we're doing other interesting services like Atlas, RIS, and so on that are important for all of you and everybody who operates an internet, not only in our service region, but across the whole globe, in order to measure the quality of their service and also see how their routes can be viewed in other parts of the world. The community sets policy, we implement them. So you're part of the community, you can participate in the policy discussions. We're here to implement them. The RIPE NCC has a strategic plan. First and foremost, we're here to support an open, inclusive, and engaged RIPE community. Then, secondly, operate a trusted, efficient, accurate, and resilient registry. And then the third part is to enable our members and community to operate one secure, stable, and resilient global internet. And then, of course, for any organization, we need to have a robust governance system. We need to have financial control. We need to have a good board elected by the members and so on. We need to interact with the government so that we stay within laws and regulations. And none of this is possible unless we attract engaged and competent and diverse staff in order to run our business. Among the 180-something staff that we have now, I think we're from 40 different nationalities, so we're truly international team. The registry maintains the RIPE database, so anybody can look into the registry and see who has been allocated and assigned different internet number resources, be it IPv4 addresses, IPv6 addresses, or ASN numbers. We allocate and manage internet number resources through an LIR portal. So as a member and with a local internet registry, you can manage your resources there directly online. We investigate hijacks and policy violations. And we support and facilitate the policy development process with the community, and our policy development officer, Angela, will talk a bit more about that later. And then one of the most important projects from a security point of view is the RPKI project and service that we've been running for quite some years now. We also have information services. We maintain the world's largest internet measurement system, Atlas, with more than 10,000 probes where you can run your own measurements. We have a routing collector that collects BGP routes from multiple places in the world, so you can see how your routing is there. We have an interactive IP map that you can use to visualize things on the map. And you can use RIPE-Stat as an interface to look into all of this. In addition, we operate one of the root name servers, KRoot, which is one of the 13 root name servers. And I think now the latest stats, it's more than 1,700 different instances of root servers around the world. So while it is 13 different instances operated by 12 different organizations, it's a hugely redundant system. The RIPE NCC operates a bit more than 100 instances, but in total it's more than 1,700. And we do also delegate reverse DNS zones for the address space that we allocate, and we run some secondary servers, secondary DNS for members. I mentioned RPKI. So if you know your BGP routing, you set up your router to announce to your neighbors which addresses you have in your network so that they can send traffic to you. Now, RPKI is a framework on top of that where you make a statement that ASNX, your ASN, is authorized to announce your prefix. And then we apply a digital signature to that so that you sign that with your private key so that everybody else can validate that your routing announcement is valid. And this is really important to increase security in the internet. It's not enough to secure everything, but it's one very important step there. So if you're interested in that, routing working group, or talk to us in the corridors. Community and engagement. So as any organization providing services, we need to interact with our members or our customers. We organize RIPE meeting, regional meetings, and other events. So this is our biggest event, the RIPE meeting. Maybe more than 800 people will turn up. But we also do regional events. So to bring all of our members into a central location may not always be possible. So we have regional events in the Middle East, in Central Europe, in Central Asia, and so on. And we do even more local events in order to reach out to all of our members. We offer training courses, e-learning, and professional certifications. We contribute to public policy and internet governance discussions. We publish and curate articles on RIPE Labs. So if you have something interesting you want to share, you can publish that on RIPE Labs. And we run the RIPE NCC Community Project Fund. So if you have an interesting project that can benefit internet at large, then you can apply for funding from that fund. It's a community committee that makes the selections. I have a team managing the RIPE NCC with me. You will see many of them here on stage. Felipe will present in the services working group. He's the new Chief Technology Officer. We're looking for a new Chief Registry Officer. Hisham is at our Dubai office. He's unfortunately not here, but he's participating online. Eleonora, our Chief Information Security Officer, she started last year. She's here. Simon Jan Heiting, our CFO, is managing all aspects of our finances and sends out the invoices. So if you haven't paid your invoice, then please do so. Caroline Voss is our Chief HR Officer, and Athena Fraguli, our Chief Legal Officer. And last but not least, Daniela, my Executive Assistant, is keeping track on us all to make sure that we do our work. We have an executive board that oversees the work, approves the strategy, approves the activity plan and budget. You can see a picture of them here. If you are a member, you may have registered for the general meeting this Wednesday, and you can then vote at the election. 3 of the board members are up for election this year. We do have a service desk here, a help desk, where you can meet my colleagues who are able to help you with any business with the RIPE NCC. We really mean, please get in touch with us if you have any questions or need any help. I mentioned the general meeting. It's a separate meeting on Wednesday. You need to be registered for that. You can do that as a member. And there is a separate registration, which I believe this time opens tomorrow, so you don't have to rush on Wednesday to do that. Members can vote online, so the vote starts at the end of the meeting and goes on until Friday. So we really expect votes in the thousands here, which is really good for the accountability of the organization. And then I'll hand over to Angela to talk more about the policy development process. So Angela, stage is yours.
Thank you, Hans-Petter, and good morning, everybody, and welcome also from my side to all the newcomers. I've heard that we have many this time, so it's always a pleasure to have new colleagues joining us. So I'm Angela Dallara. I joined RIPE NCC in 2014 as Internet Resource Analyst, and for the last 3 years, I'm Policy Development Process Officer or Policy Development Officer. There are still various definitions of my position. What do I do? I'm acting actually as a bridge between the RIPE community and the RIPE NCC for what is concerning the policy development process. As you heard, is everything about participation. So you heard already about the working groups, mailing list, and discussions of policy proposals. So what happens is you can always have a good idea. You can always see something that is not making you totally happy with the policies as they are. You can contact the working group chairs. with your ideas, or you can also contact me if you're not sure to which working group your proposal could go. So first of all, I'm here to tell you, please don't be shy, don't hesitate to contact me if you want more information about how the policy development process works. If your request would be in compliance with a certain policy, if there is something that you would like to do in terms of policies and you don't know how to start. Also, what I would like to tell you, don't think that you need to be a writer, don't think that you need to be super expert in how to write a policy. We have wonderful colleagues in our comms department that are going to help you. So it is something that we can help you with and we can support you with. What is important, again, is that whenever you have an opinion, whenever you see something that needs to be or corrected or enriched with more details in a discussion, please post it. Please let the community know which is your idea, which is your opinion, because a rich discussion is always helpful to have a good decision at the end for what is concerning the consensus about the policy proposal. Each working group has working group chairs that are tasked with deciding if a policy proposal has consensus from the community, and if you do not manifest your opinion, this task becomes very difficult for them. So I'm here to encourage you to participate. And talking about policy proposals, we have 3 policy proposals at the moment active in our region. 2 are under discussion in the Address Policy Working Group, and 1 is under discussion in the NCC Services Working Group. The first 2 are regarding 2 reserved pools of IPv4 addresses, 1 for the IXPs and 1 for the temporary assignments. So the first policy is proposing to, the first proposal is suggesting to reduce the IXP assignments from /24 to /26 in order to prolong the lifetime of the reserved pool. And the second policy proposal is about temporary assignments. In this case, they would like to offer the possibility to receive a routable subnet, even if the, so /24 at least, even when the utilization is not sufficient in compliance with the current policy. So if you have an opinion, please join the working group, the Address Policy Working Group on Wednesday morning, and state your opinion, and especially state it on the mailing list. The third policy is about a voluntary transfer lock that would offer the option to all the resource holders to temporarily prevent the transfer of their resources, specifying which resources in order of allocations and PI assignments. All these policies are open for discussion until after the RIPE meeting. So if you're not subscribed to the mailing list, please do so. And you can check the previous posts and the discussions in the archives, and state your opinion and help reach consensus or not, depending on which are the opinion stated. If you have any questions about policy development process, how to participate, how the process is also internally after you present a policy proposal or something like that, please approach me here at the RIPE meeting, or you can send me an email at pdo@ripe.net, and I will be very happy to help you. And with this one, I hope I convinced you to participate, and I leave again the word to Mirjam. Thank you.
Thank you, Angela. And this is a lot of information, I understand, to take in at the very first day of your RIPE meeting. But you don't have to remember all this. The main point also is here for you to see, some of the faces, and that you then can approach us during the week if you have any questions. Do you have any questions now? I don't know if anybody is, I don't see the Meet Echo questions here. I don't know if there's anybody who has any questions online. I don't see anyone in the room. Now, if there are no questions for us, we do actually have questions for you. I believe there is something. There's a quiz. It's happening. Oh, I need to move to the next slide. Questions? No. Ta-da! Sorry. And if all goes well, our Kahoot master, Gerardo Vivier, will be heard from the off somehow.
Yeah, somehow. Can you hear me?
Yeah, there you go. Yes, we can.
It's really tight here between the screen and the projector. So let's get this party started. Welcome everybody to IPv6 Newcomers Kahoot Quiz. Get your engines started. My name is Gerardo Vivier and I am your quiz master. We are broadcasting today from the edge of the RIPE NCC network. I can see so many ASs from here. So when you sign up, remember to put your number in your nickname, and we can find you to give you any prizes that we might have in store for you. So as you can see, there's a game pin 4938105. All you have to do is go to kahoot.it or use the Kahoot app and just put in the game pin. Put in a really funny nickname if you want to, because then you'll see how much fun we can all have. So the goal of the quiz is to let you check your knowledge. Let's see how much you remember from everything that was said. That's right, Mr. Crow, everything that was said. I'm going to show you about 12 questions with 4 possible answers. And the person who answers the fastest to the right answer gets the most points in that round. At the end, we're going to have a bit of...
Oh, here comes trouble.
No trouble. We're going to have a winner. The person with the most points and all the rounds gets to win the game, of course. So let me repeat how we play the game. I'm going to show you about 12 questions about what has just been presented, and you have to choose one of the possible answers. The person who gets the right answer the fastest is not a turkey, but gets the most points. I see people are still signing up. Let's give it a few more times, and let's start counting down.
5, 4, 3, 2, 1.
Yes, I'm going to allow you all to sign up because it is really fun to play. I see we have around 112 people. Amazing. Okay, I think we should get this party started. We're going to kick the game in 3, 2, 1. Let's go. So let's start this game. Welcome to the IPv6 Newcomers Quiz. The first question will appear in a couple of seconds. And first question is multi-select. Multiple answers are possible. Where can you find the RIPE NCC support desk? On Facebook, on Spatial Chat, Coffee Break Area, and or Snapchat. Where can you find the RIPE NCC support desk?
Are you crazy?
Not at all. If I had a problem, I would go and find a support desk right away. RIPE NCC support desk, where are you? And the right answer is on Spatial Chat and in the Coffee Break Area, mostly in the Coffee Break Area, of course. On to the scoreboard. We have people at the top: Joe 6, RSC 305, David 381, and Eva 715. Next question. Who makes RIPE policies? We just heard Angela talk all about it. And possible answers are, why should I care? The RIPE NCC, the IETF, or RIPE? Trick question here, huh? So the possible answers are IETF, RIPE NCC, RIPE, or why should I care? I hope to see no answer. Nobody saying why should I care, because ooh, we got one person here who should be talked about. The right answer is, of course, RIPE, and Joe 6 is at the top, RSC 305, Eva 715, not Bob, and David 381. Next question. Does RIPE have a secret working group? So the possible answers are, what is a working group? Now the quizmaster has to die, of course. There are no secrets. There is no such working group. And if it's a secret, we would never tell. Which of these is the right answer to the question about, does RIPE have a secret working group? And the right answer is, if it's a secret, we would never tell. So on to the next. First, the scoreboard of RSC 305, F5, David 381, WT 260, Res P36, and on to the next question. Who is the RIPE chair? Is it the RIPE chair team? Is it Hans-Peter Holen? Is it Niall O'Reilly? Or is it Mirjam Kühne? Now, this is a trick question. Remember, you should have put attention to what Mirjam said. Who is the RIPE chair? The RIPE chair team, Hans-Peter Holen, Niall O'Reilly, or Mirjam Kühne. And the right answer is, boom, Mirjam Kühne. Now O'Reilly is the vice chair, and together they form the RIPE chair team. RSC still at the lead. David 381, WT 260, Resp, and Kerr. On to the next question. What does NCC stand for? Is it Network Carbon Copy? Is it Network Coordination Center? Is it Nordic Construction Company? Or is it Nerds Computer Club? Yeah, one of these is the right meaning for NCC. Network Carbon Copy, Network Coordination Center, Nordic Construction Company, or Nerds Computer Club. So one person thinks it's the Nerds Computer Club. Very, very funny. But no, the right name is Network Coordination Center. Ouch. Yep. NCC stands for Network Coordination Center. So the scoreboard says David 381, RSC 305, WT 260, Resp, and Kerr. On to the next question. You need to become a member to join the RIPE meeting, the RIPE community, my fan club, or the RIPE NCC. And we have a special promotion for my fan club. Buy 10 mugs, get one free. But you need to become a member to join the RIPE community, the RIPE meeting, the RIPE NCC, or my fan club.
Whatever.
No. 3 people would love to join my fan club, and I love that. But the right answer is the RIPE NCC. You don't need to become a member of the RIPE community, and you don't become a member to join the RIPE meeting. Anybody can join those. But you do have to become a member of the RIPE NCC. Scoreboard says RSC 305, Resp 36, WT 260, David 381, and Kerr. On to the next question. Yes, kitty cat. Which of these came first? The fall of the Berlin Wall, the first working World Wide Web browser, Voyager 2 closest to Neptune, or RIPE 1? Which of these happened first? And this is really, really, really interesting because all of these happened in the same year, just a couple of days or weeks apart from each other. So which of these came first? And yes, surprise, surprise, RIPE 1 happened before any of these other historical things. So a lot of historical things happening at the same time in the same year, 1989. So the scoreboard says RSC 305, Resp 36, WT 260, Rinsekluk, and KR. Kerr. Question number 8. Which organization was the first regional internet registry? Was it Internet? Was it ARIN? Was it ICANN? Or was it RIPE NCC? So of these 4 organizations that you can see here on the screen, which of them was the first regional internet registry? RIPE NCC, Internet, ARIN, or ICANN? It was, of course, the RIPE NCC. The RIPE NCC was the first regional internet registry ever. On to the scoreboard. RSC 305, WT 260, Rinsekluk, no, and Weghorst. I love those nicknames. Question number 9. Who implements RIPE policies? Everybody. The RIPE chair, RIPE, or the RIPE NCC. So once a RIPE policy has been made, written, discussed, approved, and etc., who will implement it? Will it be the RIPE chair, everybody, RIPE, or the RIPE NCC?
Why not?
Yes, why not? And the right answer is, of course, the RIPE NCC. Everybody should participate in the discussions. The RIPE chair will help with helping people getting things done. And RIPE, of course, makes the policies, but then it's the RIPE NCC who has to implement them for you. Scoreboard says RSC 305, W260, Rinsekluk, no, and Eva 215, no, 715. On to the next question. Number 10, of course. What does the RIPE PC do? Does it ensure that there are parties and celebrations at each RIPE meeting? Does it choose the presentations for the working group sessions? Does it select the working group chairs? Or does it choose the presentations for the RIPE meeting plenary sessions? So much work. But what does the RIPE PC do? It chooses the presentations for the RIPE meeting plenary sessions. So if you wanted to present at the plenary session, to talk program committee. So donkey, shut up. RSC 305, Rinsekluk, WT 260, EVA 715, and RESP 36. On to the question number 11. We only have 2 more questions, so you better hurry up. Which of these is not a RIPE working group? Is it the DNS working group? Is it the big data working group? Is it the open source working group? Or is it the IoT working group? So one of these is the right answer. It does not actually exist.
Good luck.
Good luck figuring it out. Big data, open source, IoT, or DNS. And that is right. We have a DNS working group. We have an IoT working group. We have an open source working group, but we have no working group. And probably that's fine. On to the scoreboard. RSC 305 still at the top. Rinsekluk, WT260, EVA 715, and RESP 36. Last question, last chance. True or false? Working groups discuss RIPE policies on mailing lists. Oh no! Is it true or is it false? Working groups discuss RIPE policies on mailing lists. Surprise! You'll be surprised.
Are you crazy?
Not yet. And the right answer is true. The working group will discuss the RIPE policy on mailing lists. Of course, you can also discuss them at the RIPE meetings, but the question was, working groups discuss RIPE policies on mailing lists, true or false? And the answer is true. So let's check the total scores of everybody. In place number 3, we have WT260, Rinsekluk, number 2, and number 1, we have RSC 305. Congratulations. Yes. So thank you everybody for playing. We hope you had fun and learned something new. Enjoy RIPE 86, and remember, a day where you did not learn something is a day that was lost.
Thank you, Quizmaster. Did I forget to mention we're also here to have some fun? So this was first good moment of fun. I hope you'll have some more fun during the week. Next on the agenda is lunch. We're a little early, so you have some time to find the lunchroom, which is outside there. You'll see it. It's the main room from the coffee break area. There are some tables marked with newcomers, so that you can find space there. But you don't have to. The idea is, of course, you meet each other. You also meet the not newcomers. But if you want, you can find space at the newcomers and tables there. And I hope you'll have a good week. Don't hesitate to approach any of us if you have any questions during the week. And I wish you a great and successful week.
Yeah. Yeah.
Ja, eentje is genoeg. Voor nu is één klaar. Top. It's all.
I mean, Mirjam is starting anyway, but when we use them,
Normally it's one that they should.
okay, so we kind of wave and they will unmute. Okay.
Complain dat hij maar in gegeven.
Yeah, because now
Deze nog even.
done afterwards, when we're done, we can have keep an eye on it.
Chat line.
Yeah. Hello, hello. Yes, it works. Hey, welcome everyone. There's still people coming in, so I'm waiting one more minute. I don't hear a bell, but I think there's staff running around getting people into the room. I hope you can all find space. Can't believe we're filling this conference center. We're getting bigger and bigger every year. I'll show you some numbers, quite impressive. All right, let's get started. I think most people have found a seat. Well, my name is Mirjam Kühne. I'm the RIPE chair of I'm the chair of the RIPE community. And we had Neil here, but now he's disappeared again. And now don't fall. Neil O'Reilly is the vice chair of the RIPE community. We've been in office since September 2020, and we're basically here to help you run this meeting or facilitate the meeting. And so if there's anything, find us.
You know who we are.
Now you know who we are, exactly. You may leave again, thank you. Now Neil's actually going to help monitor the MeetEcho chat also, and doing things in the background. So yeah, this is the 86th meeting already, 86th RIPE meeting. We were in Rotterdam here in RIPE 79, just before the pandemic was the last meeting before we went fully online. So it's great to be back in a bigger venue now, brand new venue. We have actually now participants both online and offline, not offline, online and here on site from 67 countries, which is quite amazing. We have people from 25 countries here at the meeting physically at the moment. These are kind of statistics I just got before the session, so I'm sure people will still coming in during the week. We have in total 1,150 registrations, both here on site and online, and of whom are 350 newcomers. And we had a great newcomer session earlier today. Many new people, many students, lots of people from the country, of course, but also, as I say, from many other countries. 466 have already checked in at the moment. I still see people coming in, and there will be, more people coming during the week, I'm sure. Now, coincidentally, today also marks the 50th year of Ethernet, I was told, and I was looking that up. It was actually really the 22nd of May, 50 years ago, that it was first mentioned in a nota by Robert Metcalfe somewhere. And so I just thought a piece of history here, relevant to this community. Back to the present. This is the meeting plan for this week. The most up-to-date meeting plan is always online. You have a meeting plan also here on your badge. Some things might still change. For instance, we swapped the rooms for the baths, so in case you're confused. But yeah, just always double-check the one on the website. But in general, you know the drill. Monday, Tuesdays, usually plenary sessions. Wednesday, Thursdays are working group sessions. And then in the afternoon, Thursday, we have a community plenary and a diversity session, which I'll come back to. And then on Friday, we have more plenary sessions. So it's a packed agenda again, and lots of interesting topics. Just to make sure you're all aware of this, I think you should have seen and registered, checked when you registered. We have a RIPE code of conduct in place for some time already. Remember to treat each other with respect. It's quite a diverse community. We have very different people from different countries, backgrounds, genders, religions, everything. And so please listen to each other, be tolerant, respect each other. And I'm super happy to announce this very first RIPE Code of Conduct team we ever had. You remember we had trusted contacts before that were available for you to go to in case something went wrong or you felt like the Code of Conduct was breached. But now we have actually a Code of Conduct team. These are the people there. All here except for Randy, who's online. So, but the team has had training. They have communication set up. There's a mailing list. There's a form you can use. So don't hesitate to contact them either here during the meeting or use some of the online channels where you can reach them. And I would like to really thank you also the trusted contacts that have served us so long for so many years while we were getting this the documentation in place for the RIPE Code of Conduct reporting and the RIPE Code of Conduct teams. And I would also like to thank the Trusted Contact Task Force who have actually helped us to get through this, through the community. And so we have all relevant documentation now published as RIPE documents, and I've sent them to the list before the meeting. Now, more faces here. These are the current working group chairs that you will see later during the week in the various working group sessions. Some working groups will also hold, are looking for new co-chairs and will hold, selection during the working group sessions. And so it's still your chance, if you're interested in some of the working groups, to maybe become a working group chair and contribute more actively to the community. Now, there's one working group I'm not allowed to talk about, and I tried to at the last RIPE meeting to tip the veil a little bit. I know, I'm not looking at anybody in particular, and gave a bit of a presentation and tried to demystify that secret working group a bit at the last meeting. But now I thought I'd do something different at the beginning of the week. Now is the time for you to think about if you might want to contribute something, because this is really the way for us as a community to also self-reflect, look at ourselves, see if there's something funny going on, and be creative during the week. We've set up this email address that you could contribute your input to, and magically the secret working group will form and react and handle the input. And so this is a call for you to think and be creative during the week and observe the meeting. Now, apart from this, I just wanted to put some highlights here on the screen of topics. I mean, we have the usual topics, obviously, that the RIPE community is dealing with. But I noticed there's also some topics, that maybe that'll be reoccurring. For instance, more on public policy, more EU regulations that are, that'll come back during the plenary, but also during the working group sessions. And I think that's a topic that will stay with us. And we as a community, we need to be alert and we need to be aware of the increasing number of regulations and proposed legislations that are coming our way that might affect our community and the internet infrastructure at large. So I'm very I'm glad that there's a lot of activities going on in the RIPE community to monitor these developments, and you will see that coming back on the agenda. And yeah, you see some other topics here that that you will see back on the agenda during the week. One of which will come back in the diversity session on Thursday, right after the community session, community plenary. There's a diversity in tech session. This time we want to focus actually on age diversity, so different aspect of diversity, and encouraging youth and young people to come to our meetings. I was very pleased to see so many young people in the Newcomers tutorial, and so we're going to have a discussion about that, how we can include you more and what we can maybe do better or different, in the future to get more new people on board. Well, that's not a new person. This was our first chair. As you on the slide, Rob Loxwell, the first RIPE chair. And there's, for those of you who don't know, he's passed away a few years ago. And there's a foundation set up to hand out an award in the name of Rob Loxwell. And the foundation board, they're putting together a committee now for the next award. There will be an announcement in the community plenary about the awards committee, and you can find more information on the website and also talk to the board members here if you're interested. Now, something more fun, maybe the socials. Always important for the RIPE meetings. We have lots of space to do also social engineering and talk to each other. Tonight we're going to have a welcome reception, like usually on a Monday evening, on the afternoon after the sessions here at the venue. On Tuesday, tomorrow, we'll have our networking party event in the Maas silo in an old industrial building. You can find more information on the website where that is and what's happening there. And then on Thursday, we have our traditional RIPE dinner on the boat. I believe it's not actually moving, that boat, so you don't have to be afraid that you can't get off. So it's just there to be on. We'll have a nice view over the water in the city. I would really like to thank our sponsors because we couldn't do it without the sponsors. So you see here lots of names: gold sponsors, silver sponsors, connectivity sponsors, bronze coffee breaks are also sponsored. So thank you very much. We have a big applause to the sponsors. There's no host this time on the slide because the RIPE NCC is the host. Hans-Peter is going to talk a bit more about this in a second from the local host perspective. So normally you would also see a local host here on this slide. Now, if you want to be one of the next local hosts, this is your chance. We've just issued a call for hosts for not the next 2 meetings. They're already pretty much settled, but the RIPE 89, 90, and 91. We're looking for hosts. If you're here, if you think you would like to host a RIPE meeting in your city or in your country, your company or organization can contribute to that. Please come talk to me, come talk to the meeting team here during the week, and we can provide you more information. And I think that was all from my side. And now Franziska Lichtblau, the chair of the program committee, is going to talk, introduce you to the program committee.
So welcome everyone to Rotterdam again. I'm Franziska Lichtblau, as Mirjam already said. I am the chair of the RIPE 86 program committee, and I would like to give you a little bit of an overview on what the program committee actually is, what we do, how we operate, and maybe interest you in our work. So these are all the lovely people I had the great pleasure to work with in order to get the program done. They have all the nice RIPE PC program committee. Jan keeps gesturing at me and confusing me. Thank you very much. He's very fun to work with. So if you meet any one of us, please approach us. If you have questions to the program committee, if you're a speaker, if you want to submit something, just talk to us. So, but what do we actually do? Because we are doing this for a long time, but apparently we are not as good as getting across what we actually do and what we are responsible for. So if you look at the meeting plan that Mirjam showed you earlier on, you have plenary sessions, you have BOF sessions, you have tutorial sessions, you have working group sessions. And the program committee is responsible to compile everything that says plenary, BOF, or tutorial. So basically what we do, we fire out a call for presentations to the internet, and then you lovely people send us a bunch of presentation submissions, and we usually take 2 or 3 sessions to evaluate all of them and compile a nice engaging program. Our general idea for the plenary is it should be interesting for all the people in the room, like have rather widely spread interest that everyone can somehow relate to, real world content like what our operations community works with on their day-to-day basis, new technical interesting developments, things like that. If you have something that is very specific, that is a deep dive in technology, policy, all the other things we do, find an appropriate working group, talk to them. They are also very nice people and will happily accommodate you. The other thing that we do is that you will see us doing on Monday, Tuesday, and Friday. We actually chair plenary sessions. So what does that mean? We actually make sure that these things run smoothly. So we make sure that you orderly queue at the microphone, that our speakers don't overrun our allotted time slots. We tell you who our speakers are, and in general, make sure that everything runs smoothly. So if you want to know more, you can talk to all of us. And of course, we have a charter. It is all written down in RIPE 600. If you want to know what the program committee does in detail, what are like the term limits, things like that, have a look. It is a quite nice read. Why am I telling you this? Yes, there are 2 seats up for election this year, this round, and you can nominate yourself or somebody else. Maybe ask them before you do that. That would be nice. Until Tuesday, 3:30, I guess. Just send us a mail to pc@ripe.net, provide a short bio, maybe a picture that we could put on the website, and then every one of you, please go check out the voting link and vote for the program committee until Thursday, and then we can announce the results for the new elected PC members on Friday. And to give you a small idea on the amount of interesting stuff we get, this time we received 42 full presentations, so those are the longer 30-minute presentations that you see during the plenary time. We were able to accept 16 of them, so usually what we do, we have a look how much time we have, and then we allot the respective slots. We get a lot of lightning talks, and they are still coming because lightning talks submissions are still open, because right now we are allotting the ones for Friday, so please keep submitting. We will let you know probably by Wednesday or Thursday what we will accept. We got until now 28, we were able to accept 6. And you can see there were not that many tutorial or WAF submissions, so we accepted most of them. If you have something to tell us that is in that realm, your chances to be accepted are very, very high. So please vote for the program committee, nominate yourself. We would really, really like to work with a new interesting bunch of people for the next meeting. Thank you.
Many thanks, Franziska, and the program committee is doing a great job. And I would also, like to say that we actually received a really good selection of talks this time, which made the life a bit more difficult for the PC. But it was great to see so many submissions, which has tremendously increased since the pandemic, which was really good to see. I see the next speaker there. So Hans-Peter Holen, the managing director of the RIPE NCC, he's going to speak as the local host here of this meeting, and we'll also give you some more specific information how to interact at the meeting. Thank you.
So thank you, Mirjam. Usually I'm up here just to give some practical information, but this time RIPE NCC is actually the local host of the meeting. Our office is in Amsterdam. Rotterdam is close by. Here we are. Welcome to Amsterdam. Not Amsterdam. Welcome to Rotterdam. You know, they have also assigned me a handicap room at the hotel, so I guess I get the hints here that, yeah. Anyway, you may know that the Dutch weather is unpredictable. One thing I've learned from living here for 3 years is that there is an app telling me what the weather is going to be. Well, everybody has that, but the resolution on the Dutch app is kind of in the next 10 minutes. So it will tell you whether it will rain and then when it actually stops to rain. So I can, you know, time walking to work in 10-minute slots, not to get wet. But the meeting time has done their best to arrange some sunshine for you, so fingers crossed, and let's hope the connections with the weather masters are as good as we are on the network side. So first, some few words on RIPE and RIPE NCC for those of you who haven't attended the newcomer sessions for a while. RIPE is a community, that's all of you from 1989, but after a few years, we figured out, well, it's actually before my time, that we needed a secretariat. So RIPE NCC was set up as a membership organization to be the secretariat of the RIPE community. It's run by staff, overseen by executive board, elected by the membership. We provide services. One of the services is to be a regional internet registry for Europe, Middle East, and Central Asia. But we also provide measurement services. We do community building, we do outreach. We try to bring as many as possible to these meetings here, but we also hold meetings in other parts of our service region where it's not so easy to travel to the big meetings. And as you know, the community sets policy. You can participate in the address policy working group on Wednesday. And when there is consensus on the policy, then they're implemented by the RIPE NCC. Since RIPE NT5, a lot has happened. We've had a regional meeting, the first Central Asia Peering Forum in Kazakhstan in November. We had a Quantum Internet Hackathon in December. We had a MINOG meeting, the 22nd in a row in Bahrain, and an SCE meeting, the 11th in a row in Split in Croatia. And we had a DNS hackathon yesterday, and I've been told that there is some interesting output from that coming in the DNS working group later this week. The RPKI publication service is live. So before you had the choice of having your ROAS signed by the RIPE NCC, now you can actually sign it by your own certificate, but use our publication service to publish it. You don't have to set up your own publication point. We have published Nordic country reports, and it's always pleasing to see that Norway has more IPv6 deployed than Sweden. Unfortunately, we're behind both Finland, Denmark, and Sweden on RPKI deployment, so there is still work to be done even in Norway. Sanctions research has been published. We have funded some research, and there is a report coming out there. A new security, BGP security e-learning course is out, and an associated exam is launched. We also have micro-learning, so if the big courses are too much to you, you can do a micro-learning on RPKI. And we have a new season of RIPE Labs podcasts coming out. RPKI certificates, we're almost at 20,000. In the presentation I reviewed this morning, it said 19,888. No, it's 19,995. So 5 more, please, during the week, so we can celebrate 20,000 certificates issued. And why is this important? Well, we want to secure the routing infrastructure so that you can sign a statement saying that please only accept addresses from my AS. At RIPE 86, we will have a lot of my colleagues presenting here. I think at this meeting we have more than 100 RIPE NCC staff dropping by. Since it's so close, we have encouraged everybody that hasn't been to a RIPE meeting before to turn up for at least one day to get the feeling and experience. Normally we would be roughly half of that, but I think it's important that everybody working at the RIPE NCC understands what the community is all about and what we're doing here. So later today, Vesna will talk about environmental impacts of the internet. Olena is in the BCOP task force. Daniel is organizing a BOF tomorrow on AI. Angela is talking about doing a policy update in address policy. Gerardo is talking about training that we're doing in the abuse space. And Theo also talking about the interactions we're doing with law enforcement agencies. Then we have the regular updates in RIPE NCC services. And for those of you who have been following the discussions about where does all the money go for in the RIPE NCC, that's going to be the main topic of my talk there. So I'm not going to be giving the regular slide deck that I'm giving, but more talking about, you know, what's happened since 2013 when it comes to financials and where we're spending the money. And I will continue that into the GM in more details, not because we're going to do the budget at this meeting, but it's an introduction to the activity plan and budget process that we normally do in the autumn meeting. And we really want your feedback on this because we're depending on your trust and your support for what we're doing and where we're spending the money. Emil is talking in the MAT working group about measurement services that we're doing. Anna is giving a report in the DNS working group. And Ed is giving the database update in the database working group. And Maria is then talking about different use cases for the RIPE database from the legal side. So there is quite a lot on the agenda. And now I'm just giving advertising from the RIPE NCC as the local host, right? So you know where to see us and what we're actually doing for you, because this is not something that we're doing for our own sake. This is something we're doing for the members and for the community. You can meet staff here. There is a services desk. Learning and development has a desk. The meeting team is here to help you. There is a tech team here that makes sure that this meeting works flawlessly. Before I took this position, I used to say that the RIPE meetings is kind of the best technical infrastructure at meetings that I've ever attended. I hope that's still true, but that's not my credit. That's for the tech team. And we're here to talk to you. So please contact us. MeetEcho is the main platform for both online and on-site attendees. I guess if you're offline, you're not really participating, so you may not be an attendee then, but anyway. You need meeting registration, then you get an email with the link in. please bookmark that or store it for some other, whatever is convenient to you. There is also live transcription active, so there are stenographers here that you can see if you can't understand what I'm saying, they understand what I'm saying or what I should be saying, so that's up there. And then everything is recorded and archived later on, so if you miss a session, you can always watch it later. Yeah, you can ask to ask questions. You can click the buttons here to get in the audio or video queue. If you don't want to be speaking directly, you can ask and add your questions in the Q&A functionality in Meet Echo. And you can chat with others in the chat group. But if you ask questions in the chat, well, then they may not be read by the session share. So please use the Q&A button for that. And you can also see the stenography in Meet Echo. COVID measures. I dream that this is past us, but it's still a concern. We have self-tests and face marks available at the registration desk. Please test yourself if you experience any symptoms, and then please then stay in your hotel room so you don't infect others. And there are also triangles on your badges here. Red, please keep distance. Yellow square for elbow bumps only, and green circle. I don't know why the green one is actually yellow on this monitor and green there, but that's just to confuse me. Anyway. Fine with handshakes and hugs. I still don't think we have accommodated for Julf's request to have a black one for please keep 5 meters distance, but he always asks for that. So, Julf is from Finland, by the way. So that was it for me, and I guess there are no questions on this stage, but if there are, should. If not, I'll hand back to the chair.
Thank you, Hans-Peter. Are there any questions at this stage for any of the speakers that you've seen so far? 1, 2, 3, thank you. I see some thumbs up, that's very sweet, thanks. Well, in this case, I'll hand over to Franziska, who will, she and the pre-C will take it on from here, and you won't see as much from me anymore, so enjoy. No, it's okay.
Can I? Yes, I have a microphone. Thank you. So, our first speaker is going to be Rudolf, and as Mirjam already pointed out in our word cloud, we are very much concerned with EU regulations these days. So Rudolf will give us a nice overview on the whole EU Gigabit Act. Enjoy.
Yes, hi, good afternoon. My first RIPE meeting was RIPE Prague in 2001. It was RIPE 40, so that's quite a long time ago. It brought me into contact with this community and told me that I actually liked policy of the internet way more than my graduation thesis at the Dutch tax service. So I ended up way more in the internet world, and that was good for many reasons, because of all the scandals with the Dutch tax service in the last couple of years. I never wanted to have been part of that. But anyways, it also cured me of public speaking and any jitters I had, because I was supposed to present a Dutch-German internet exchange in the east of the Netherlands to the European Internet Exchange Working Group, which then still existed. And I had made a calculation that, well, there are about 20, 30 internet exchange points. So if all of them send like 2 or 3 people, then it's a room of 60, maybe 90 people. I can do that. I have stood in front of groups like that. And then it turned out it was the main room, and there were 400 people sitting in front of me, and I was 25 and I was jittering. But, you know, that went well and it was fun. And well, years later, here I am. I still like the internet. I still like public policy. I love the EU, just not this particular thing that they did. The EU is working on a gigabit internet package, and last week somebody from Deutsche Telekom really tweeted it the best what the EU wants to do, and the region with the best connectivity will be the region with the best innovation. That's basically the background behind what the EU is trying to do with its gigabit package, and I think that's a very good description. So the EU has a bunch of digital decade goals, stuff that they want to achieve by 2030. They basically want better connectivity for better lives, which is a paraphrasing of the slogan of the OECD, where I used to work for a couple of years, which says better policies for better lives. And I think that's still one of the best slogans I've worked on. When I was at the OECD, I, for example, also organized the Berg OECD meetings on IP interconnection in 2011 and 2012 to bring regulators in the IP world together because, well, regulators hadn't ever regulated peering and transit, so they didn't actually know who the people were doing the peering and transit, which was fun to bring them together. And many of, well, at least some of you who I saw here today were there then as well. The Digital Decade Policy Program of the Commission has a goal that all end users should be able to use gigabit services by 2030. And all market actors benefiting from the transformation should assume their social responsibilities and make a fair and proportionate contribution to goods, services, and infrastructures for the benefit of the Union. And our 4 targets: a skilled population, digital transformation of business, digitalization of public services, but the most important one for us probably here is a secure, resilient, performant, and sustainable digital infrastructure. All end users at a fixed location should be able to get a gigabit. And mobile networks should be 5G or better. And, you know, who can be against this, basically? This is what we all want, and preferably better. And if you then look at which countries are leading in innovation, or at least building the infrastructure, well, I took the OECD's data, which has a bit more countries than just the EU, but I like the people and they do good work. So Spain, Sweden, Portugal, France, they're ahead. Since there's a bit of Scandinavian rivalry going on, Sweden is ahead of Iceland and of Norway, and Norway is ahead of Finland. So, oh, and Denmark. Oh yeah, Denmark is a bit further behind, so you guys can have fun during drinks about that. The way it was explained to me at the OECD once by our Danish chair was, in Denmark, when we look at OECD reports, we always look, are we in the top 10? Yes, awesome. But he said, we always then have to look, where are Sweden and Norway? Because if we are behind Sweden and Norway, then it doesn't matter. Then we could have just as well have been last. There will be parliamentary questions and we will have to explain why we failed. So the European Commission is worried because 10% of Europeans may not get a gigabit. And, you know, that's 45 million people. That's quite a lot. So they did 3 initiatives, 2 really proposals and 1 questionnaire. And at first sight, they look logical. Oh yeah, I have to also give you some disclaimers because I'm a consultant for Stratix. So I consult for the Dutch Association of Municipalities on the Gigabit Infrastructure Act. And I've consulted for Google on the questionnaire. And I've also consulted with a regulatory agency in Europe on the questionnaire. And I discuss stuff like the recommendation with my clients as well. So I'm probably biased one way or another. Just know that I've been basically saying the same thing for the last 15 years, and you can find stuff about it. But just so you know. So the Gigabit Infrastructure Act basically says, let's make it easier to roll out networks, which sounds like we can't be against. It's a successor to the Broadband Cost Reduction Directive, which tried to do the same, but it's an act, so you don't have national implementations. You just have to follow what Brussels says. So countries can't muck it up themselves, they just have to follow. And one of the things they want is a single permit for, a single portal for permits if you want to roll out fiber. and mandatory access to public infrastructure. So, from a distance, it sounded interesting. The Gigabit recommendation basically said who needs to give access to networks and who and under what conditions, and the Commission wants to give guidance so that the rules are done uniformly. And the questionnaire then is, how do you see the future of the connectivity infrastructure? What are the technological and market developments? What's fair for consumers? What are barriers to the single market? So what are barriers to do business? And how can we get everybody to make a fair contribution? Which on paper all sounds logical to ask. But I'm a bit more critical because it seems that it's mostly built around how to make an incumbent's life easier. And if you wonder what an incumbent is, if the telecom firm used to have a country name in front of the word telecom, that's an incumbent. Royal Dutch KPN, Koninklijke PTT Nederland, yeah, KPN. So the Gigabit Infrastructure Act, and now I say this also with my municipal hat on, wants a magic single information portal where you can do all your permit applications, which sounds nice, but municipalities do a lot more permits than just fiber rollout. Fiber rollout is basically a one-off, maybe 2 times, but it doesn't happen that regularly. And many countries are already kind of done. As you could see, Spain, great that you build a single information portal for fiber rollout, but they're 90% done. How much extra fiber do you think it will deliver? The Netherlands will be done in 2028. Quite a few other countries as well. So you invest in a portal that doesn't actually deliver fiber. And there are weird things in there, like a 3-month standstill after you apply for permitting so that other firms can join you. But that is a tactic used by, well, mostly incumbents, but also sometimes by others, to stall whatever a competitor is doing. So you say, I'm going to roll out and ask for a permit. And then another guy says, like, after 3 months, hey, I want to do it too. Could we have a meeting? So instead of you digging already for 3 months, you're now spending the next 3 months talking to them in a room whether you can cooperate or not. So Berg is not too happy with it. Municipalities aren't too happy with it. Countries aren't too happy with it. The Dutch government actually put a position paper out together with the Danes and the Swedes saying, yeah, don't do this. The Gigabit recommendation tells regulators how they can regulate. But it has these minor little thingies in there, like there's no regulation to give access to competitors if there is a prospect of infrastructure competition. Now, a prospect is not well defined, but it might just well be if somebody applied for a permit or says that he might roll out somewhere here in the near future, then you can't have access regulations, which means that if you're an alternative provider and want to get access, you might not get access because, well, there's a prospect. And, this one is actually, I think, the one that the incumbents are really after, because, if you get 1, 2, 3, 4, 5 euro more per line, per month, per customer, that's quite a lot of money after a year, per line, per million, that's 12 million. You can do the math. And then there's the consultation. And, great, a questionnaire, but it appears to be aimed to point to big tech as a source for money and to make big telco basically bigger in the name of a single market. And if you don't trust me on this, you can just read Berg, the group of European regulators, their responses to this. They've been pretty scathing of the proposals. And if you then look at the questionnaire that the Commission sent out, well, it doesn't seem to want answers. It's not clear on what infrastructure. It mixes blockchain with 5G. It thinks basically only Netnod, which is the incumbent telco group, members invest, but when you look at the Etno statistics that they themselves publish each year, it actually shows alternative networks have invested more in fiber to the home than Etno members. So, you know, it wants a single market with pan-European firms. But we already have a pan-European market. You are allowed to operate in any country, but somehow the pricing isn't the same, even though it's often the same firm. And we've seen that for 15 years already. And for some reason, it doesn't ask for hard data, but only relative percentages, but not relative to what, so it makes it incomparable. And if you wonder if the questionnaire can be this bad, well, question 40 asks how much networks invest to handle traffic growth. And then question 42 asks how much this exceeded the planned investments. But you can't have a negative value. So your investments in traffic can only have exceeded what you already planned. So if you've actually saved because you overestimated, yeah, it's not on the list. And what do the EU telcos say? Well, the incumbents say they can't handle traffic anymore. And as a result, they need to get rid of transit and as a result, peering and move to the telephony model of sending party network pays. That's what they want. And, you know, they're very serious that they can't handle traffic anymore. It costs them 40 billion a year, they say, to handle traffic and traffic growth at the moment. And they want about 35 billion a year from big tech, they say. Their math is quite simple. Their capex is 55, a bit more. 60% of the bytes are from big tech. So 60% of the cost should go to big tech, which is interesting, of course, because it's a fixed infrastructure that has a 30% lifespan. And if you can get somebody else to pay 60%, but not get 60% of the shares, you know, it's like building a house and somebody else pays 60% of your house and you get full ownership. Yes, please, if anybody is willing to do that with my mortgage, come by after. So they use statistics from the likes of Zandfine, which actually show that the percentage of big tech has decreased, but, you know, BT came out with a statement that every terabyte, well, the Guardian didn't get it right. It's sometimes known as the Graniot in the UK because of the many spelling errors. This was one of them. But, you know, every terabit per second of data consumed over and above current levels costs about 50 million, their CEO said, which is interesting because that means the KPN in the Netherlands are charging too little, but I'll show that later. Of course, to their investors, they said, gigabytes don't matter, gigabits do, but really we can handle this easily, investors. And I sometimes think that it's legally allowed to lie to regulators, or at least to politicians, I mean, but not to regulators and shareholders. So that will play a role. Vodafone also was really nice in their investor presentation. Yeah, 50% traffic growth. So CEO said, no, mate. Over 2-3 years, it was 70% on mobile, 30% on fixed, so year on year, it's a lot less. But CapEx was stable and costs are down. It's cost per gigabyte, which makes you wonder who did the calculations there, because of course we build networks around gigabits capacity, but still, it gives you a bit of an idea that it works different. Or KPN, who last year did a regulated offer in the Dutch market and said, well, 6 megabits per customer and 21% growth is what we need. And we charge access seekers 139 for it, which is about a quarter of what BT said the terabit would cost. So either KPN in the Netherlands is really efficient, or, you know, they're doing a loss-leading offer on this. But given that KPN is really good at finance, I don't think they are. So anyways, the telcos also hired a whole bunch of economists who basically say peering and transit is stupid. Bruno Julien is from the Toulouse School of Economics, and he didn't get hired, I think, for what he knew of peering and transit, but because he's of the Toulouse School of Economics, or as somebody from Etno said, well, they won a Nobel Prize To which I responded, no, he didn't win the Nobel Prize, that was his colleague. But, you know, that's how the game is played. We have an Austrian guy saying that net neutrality and high-speed broadband don't go together. And I asked for a retraction of that article. Of course, that didn't happen either. But it gives you a bit of an idea of how the game is played. And in the last week, we saw like multiple papers coming out quoting the TSE paper saying, you see, the economists say that we need to do this and everybody needs to pay for incoming traffic. How much? Well, we don't know the numbers yet, but GSMA and Netnod last week published everybody who does more than 5% of peak traffic should pay. So I assume that's roughly more than 1 to 3 terabits on incumbents, and those should pay. Whether that also means then that those who are smaller, who currently do pay, and we have many examples of smaller networks being forced to pay by big telcos, who then shouldn't pay anymore, I don't know, but well, I've put the question out, you know, be careful what you wish for. But this does give a bit of an idea, and this doesn't talk about caches, this doesn't talk about anything. So this is basically an internet traffic tax, and I'm worried about this because this has been proposed ever since 1996, and every 5 years it comes up. A friend of mine, a professor of law, calls it the zombie debate. Every time you think you put it in the grave, it comes back again. I've studied sending party network pays quite a bit when I was at the OECD, and it's a mess. It's used for telephone interconnection. You pay whatever the network at the end wants to have. And when Orange started in the Netherlands with a mobile network and it lost money, it just increased its termination rate by 25% to 25 cents a minute. So anybody on another network who called one of its customers would have to pay 25 cents a minute, which is just brilliant, you know. If you lose money, you just make somebody else's customer pay. But this was what was supposed to be used for ISDN and 3G and all the digital services we were using over it. And it's a monopoly. It's known as a termination monopoly, which also means that regulators have to regulate it, and they do. And in general, you can say high rates is low usage and fraud. International calling to African and other countries, and there's a lot of fraud on it, termination rates. And under SPNP, your choice of transit provider becomes irrelevant because the terminating network determines routes and costs. So there's also no reason to optimize costs like we have with transit. So everybody will end up paying more. And the telcos are saying, well, it's not for broadcasters, not for newspapers, not for sports associations, governments, and everybody else. It's just American big tech. But of course, if you take 5%, that's also all the sports streamers and gaming. And well, if you use Alphabet, Akamai, Amazon, Apple, Meta, Microsoft, TikTok, etc., then you probably end up paying as well because they will put that in their pricing. So of course, maybe you don't use any of these, but CDNs are also a way to bypass this. Their proposal says, no, they're not included, except if they are used by heavy users of traffic. So now the CDNs will have to publicly tell anybody who their customers is and how much traffic they're doing so that we can at least do the math. Streaming is a problem, except of course, when you do it through the telco's own IPTV platform. And let's be honest, small networks are just too small to peer, so they will have to pay anyways. So we end up with everybody paying. These are a bunch of slides I won't go into now because that's just who I am and you know who we are, but you can figure that out later. Any questions?
Yes, this works. Thank you, Rudolf. Scary stuff. You always talk about scary stuff.
Yeah, you know, nobody ever invites you to talk over a fun proposal that actually is going to deliver what is going to work. Then it's like...
Thank you. Please, questions.
In the back?
I thought there would be people running to the mics after this. Yeah, I thought so. Rolina, if there is some questions in the Q&A on
Not
Tico,
even the internet wants to talk to us, so.
do we have the queue somewhere? Again,
No,
it's
the queue is empty.
disappeared somewhere. Okay. Oh, it's there. Okay, nobody in the queue.
So we
Please.
have Carsten Schiefner who says, no question, but a big thanks for pointing out this so eloquently. I agree.
Yes. In the back and then Remco.
It would have been nice if you could actually show the break, Alistair Woodman. It would be nice if you could show down the breakdown of cost. I think there's a lot of special pleading in your argument. You're talking, essentially, you admitted that you're representing Google and other folks, and it does sound like you're trying to diminish the load that they put on the network and not actually talk about the cost transfer that's coming from those hyperscalers. And it looks like you're trying to protect the small and the access middle guys, but it doesn't actually think that it looks like that. So economics would have showed the picture as opposed to the legal pleading.
Oh, I can actually do the numbers, and I've done presentations at Links and other places, but the figure here was, time-wise a bit more constrained. But
you wanted to keep that information from people and
no. And look, if you really want to know here, so KPN says that on its network, its wholesale customers are charged 139 for 6 megabits. But that's basically what the customers themselves already pay. So that comes with the line. BT said every terabit extra would cost them 50 million. Now, if you do 6 megabits at 139 and then calculate it through to a terabit, you end up like over 5 years at 12 million. So BT is 4 times more expensive. Maybe you're off a bit, but let somebody do the math quickly. If we then look at what the traffic really is, official statistics from ARCEP in France was that in 2021, all of France was doing 43 terabits, including from CDNs. A Nokia router does 230 terabits. So the 4 big operators did 43 terabits, and you can do 230 on one router. You shouldn't do it on one router, but still. Normally, you build a network that distributes it over 10, 12 locations, and you do local interconnection also with the Netflixes, et cetera, of this world, so you don't have to backhaul all that traffic. So if you then look at what the costs are for a network of actually handling this traffic, and the complaint of the Dutch ISPs was that KPN was already charging way too much at that 139, then we are literally talking at, less than €1 that the customer already pays should be able to carry this traffic. If we then look at the wholesale price of this, transit is here in Amsterdam 5 cents. Deutsche Telekom seems to charge 80 cents, but even at 6, we're talking about 30 cents to €4.80. So no, we don't have a problem. If we then look at the terrestrial network of Deutsche Telekom, it was designed for 40 megabit per household in 2013. So current traffic is 6 megabits. If you design a network in 2013, Mr. Lofberg did that, and current traffic levels is 6, you should be able to handle it. So yes, I know my numbers. I didn't put them in this presentation, but if you want, we can go over the regulatory models for wholesale access that regulators have put up and what level the traffic is in there. We can also discuss the yearly reports of the telcos and how that is allocated with traffic, because they don't mention traffic in there. So yes, I know what I'm talking about, and I really try to get my numbers straight. If you have better numbers, please come up to me.
I think you have your numbers right. I think you're obfuscating the issue of where the profit goes and whose motive is there and hiding behind this discussion. So we'll take that offline. Thank you.
Thank you. Remco.
Hi, my name is Remco van Mook. I'm a long-time sufferer of telco debates, let's say. I was there with Rudolf at his first RIPE meeting when he was doing a presentation talking about building a transnational internet exchange, and to poor Rudolf's that problem, the first comment was from a lovely gentleman from Deutsche Telekom. I won't go back into that. You can read the minutes of RIPE 40 in 2001 if you're really interested. This really takes you back to 2011, which is I may have ignored one round of debate, but where we were at this point. And I think the point that that is worth making, and kind of surprised it's not in your presentation, is it's not big tech, whatever that means, trying to illegally stuff bits down someone's network. You actually have telcos who have like big advertisements at bus stops and so on, saying, hey, we have this fantastic internet package you can buy, where we sell you a gigabit, asterisk, of internet access, asterisk, for $49.95 a month. Well, 35, that's in France. Those are lucky people, right? If you show these kind of prices in the US, where the market is somewhat differently organized, people start crying, literally. I think the point worth making is those customers who are paying for the advertised services of these telecoms, so they are already being paid for, are simply consuming the product that was sold to them, and they're consuming it in the form of watching cat videos on YouTube, binging series on Netflix, doing other streaming things that we don't want to talk about. I mean, I'd be very interested to see how the what kind of pricing or arrangement a company like Pornhub would end up having with Deutsche Telekom. Super interesting to see that. So, how do you think that if this plays out as the European Commissioner wants, what kind of structure would that look like? I'm somewhat intrigued.
Just a second. We have 2 minutes left of Q&A, one more, so we need to wrap it up in 2 minutes. And the queue is closed now.
No, the other question, maybe I can combine them.
All right. Hi, Giovanni, SIDN Labs and TO Delta here in Holland. Just summarize, whose failure is that? Is it a market failure? Is a regulator failures, or is the company being evil, or they missed the boat on the internet because they're doing, phone switching back in the day? Whose failure is that?
Well, so I think the internet came up with a brilliant way of allocating costs, because there's 75K networks, autonomous systems active at the moment. I don't know how many are routed, but but the way the internet is built was around the idea: you build the network, you pay your own costs. If you want to interconnect with everybody else, you get transit, and if you think transit is too expensive, then try to lower it by peering or building your network out or doing whatever. And that model has worked really, really well, and it has resulted in competition. In Korea, they've now tried the other model where you pay for traffic you terminate, and as a result, services stop in Korea, or people go to interconnect in Japan instead of doing it locally. And that model I like, because any party network pays always requires lots of economists, lots of regulators. And I've never understood why, if we have a model that works so well, we want to break it. And I'm fine with telcos not wanting to peer. You're absolutely fine if you want to run everything through one place. It's your network. You're allowed to break it in any way you want it. It's your customers. As long as there's a competitive market, do what you want. Maybe you're smarter than me, and maybe you're better at it. But that's the great thing of how the internet currently works. It's your network, you pay for it. You need to get transit, that's your cost. It's your customers. If they don't pay enough, your problem. So, yeah.
Thank you, Rudolf, very much. It was a very informative talk, and I hope that the whole thing will. Sorry, Dmitry. Vesna, we would like to hear about the environmental impact of the internet, basically.
Okay. Yeah. We are in a climate emergency. We have to stop using fossil fuels in order to preserve the life on the planet. Before I go on, I want to cover some logistics. My name is Vesna. I work for RIPE NCC as a community builder. However, today I'm speaking for myself as an engineer, as an activist, and as a mother, and as a part of the RIPE community. My time slot is short and my slides are long. So please download the PDF version that is also on there with a lot of references and details. And here I'm just going to try to focus on the highest possible abstraction level. So that is, some people call political and some people call it cultural perpetuity. So bear with me, there won't be many numbers in here. We are living in a polycrisis. That means there are multiple overlapping catastrophic events going on at the same time, and they are reinforcing each other. To name just a few, it's an economic crisis, geopolitical crisis, environmental crisis. All of them can be life-threatening for some people. And in these kind of existential crises, people often rethink what is important to them. So for me, that is sharing, justice, and livable planet. And also in these kind of situation, there are a lot of strong feelings. I feel them now, but I have to contain them because this is a professional setup, and I'm also nervous. But mainly, what the pictures that I didn't want to show you, but that you can imagine and see, like from the news and stuff, about this polycrisis invoking me is grief and love and rage. I really get angry. And what do we do when we feel strong feelings? Well, we call for immediate discussion. So this is a bit of a comedic relief because, yeah, these feelings can get overwhelming. And it's also a quote from my favorite Monty Python movie. But it's also like what happens. So we all know that we have these polycrises and still we keep on talking about it. And this has been going on for a long time. So the scientists have known the connection between greenhouse gases emissions and the increase of the temperatures for centuries. The researchers have been measuring the temperatures and the CO2 emission numbers for decennia. And the UN has been on it. The governments have been getting together to come up with plans, and they had made agreements. There was a Kyoto Protocol, there was a Copenhagen Accord, there is a Paris Agreement, and you can see them all on this graph. And while all of this is going on, the emissions keep on growing and the temperatures keep on growing. And that kind of graph of like up and to the right is also very familiar to the people on the internet, but we have to focus on a different graph, which is this one that kind of goes down. here, and it shows what kind of reductions in emissions we need. Which ones did we need from the beginning? So from the 2015 Paris Agreement, we were supposed to cut down emissions per year with 7.6%. This is one of the numbers I will mention. It will keep on coming back. If we started decreasing emissions in 2020, that could have been 4% per year. But we have wasted so much time, and now we should go like 50% per year. That is really like unimaginable. What's even worse is to imagine what will happen if we don't do it. So this is a newest graph from a report with a lot of acronyms, IPCC, assessment report number 6 from March this year. And so they're saying that if we cut down emissions right now, we are locked in the 1.5-degree warming by the end of the century. If we go on with business as usual, the warming can go up to 8 degrees or 10 degrees globally. So that means in other places it will be even hotter by the end of the century. So what shall we do? Well, there is a lot of space in between, and we really have to take immediate actions to make as much reduction as possible, as soon as possible. Otherwise, if we continue with business as usual, we are condemning future generations of humans, and more than humans, to the unimaginable suffering and a lot of extinction, not only of humans, but also plants and animals and squirrels. And we don't want that. At least I don't want that. So the actual workshop that Internet Architecture Board organized in December with the topic of the environmental impact of the internet made me very happy. I thought, yes, finally, people who care, we will all get together. So there was a lot of researchers and engineers, some civil society representatives and activists getting together, submitting papers, having discussions, immediate discussions. And it is going to go on at the next IETF meetings and at future RIPE meetings. So the general goals were to bring some understanding of what is the impact of the internet and to come up with recommendations of what should we do. For me personally, it was a task to bring these kind of subjects to the RIPE community, and I'm happy that the PC has accepted this talk. Oh yeah, going back, there is a mailing list discussion here if you want to join. So what were the recommendations? Well, we couldn't really come up to the like one specific agreement. So there is a very pretty picture of what not to do. And from my side, I would say all the companies, corporations, communities have to reduce everything by 7.5% per year for the next 100 years. And that is emissions, energy usage, material usage, water usage. All the companies busy with ITF and with RIPE. Then further, as a community, we could have the net zero emissions working group. And like the smallest thing we can do is add sustainability considerations to every internet draft, RFC, or best current practices document. What else can we do? Well, we can learn from other movements. One of them is called degrowth. Degrowth is political, economic, and social theory or movement based on environmental, anti-consumerist, and anti-capitalist principles. Some of those principles are listed here, and some of them are actually familiar and overlapping with RIPE. For example, cooperation. We have a cooperation working group. Joyful living. We are very good at partying. And the next one that we could pick up is sustainability. We could create a sustainability task force. However, degrowth is a very pluralistic movement. So this is a subset of books that I have used to research while preparing for this talk. And degrowth as a concept is very old. Well, in the kind of Western science, it started in the 70s with small is beautiful and limits to growth, a report from Club of Rome. But in other cultures, it is actually just a way of living in balance with our more than human neighbors. And so they don't have a word for it. And now trying to translate that into language is actually a hard process. So the degrowth is overlapping with a lot of other movements. For example, ecofeminism or decolonial environmentalism. Yeah, others too. There is a whole literature about it. Well, with ICT, we like to talk about a life cycle. So we start with the equipment, which has to be produced, then it has to be shipped to the other end of the world, then it needs to be operated using the energy and storing the data, and then disposing of it at the end of the life cycle. But all of them, all of these processes are actually based on extractivism, exploitation, fossil fuels, pollution, and injustice. So that to me sounds more like a death cycle. What can we do to minimize the impact that the internet has on the environment? The least we can do is just reverse all of those for every component. So when producing, we can have the more sustainable practices for getting the materials. We can resource them more locally so that we reduce the shipping. We can reuse some of the existing materials. And very important, stop using fossil fuels for all of the processes. Move towards renewable energy. But that's not a perfect solution. We also have to reduce the amount of energy used for running the networks, for producing equipment, for shipping the equipment. And finally, at the end of the life cycle, we can prolong the use of the equipment by repairing, repurposing, recycling, and also by removing the way of thinking, which is planned obsolescence. And there is also a movement in Europe for the right to repair. So there are ways that we can do this in small incremental ways. However, we are not doing it. Why aren't we doing it? Well, there is listed here in this research paper the 12 reasons for delay. Delay is the new denial. And from these 12 reasons, I see 3 that are kind of prevalent in technical communities, which is whataboutism, perfectionism, and techno-optimism. So how to counter them? So whataboutism is, oh, why should we do it? They are worse, they should do it first. Well, we all have to do it, including the car industry, the aviation industry, the building industry, but we within internet industry also have to do our part. And this is where we have the power, this is where we have the agency. So we have to do it too. And we could also be examples to other industries. Perfectionism. Oh, let's measure some more. Let's find the best way that we can tackle this so that we actually target the best possible way of dealing with it. We don't have time for this. That time is over. We have to do everything right now, all at the same time. And finally, the techno-optimism, that's the hardest one because yes, we do believe that the technology can solve a lot of problems. But if you look historically on those graphs that I showed before, the tech did not save us until now. So we have to do something else. I'm suggesting degrowth, which is a problem because the tech industry is addicted to growth. Everything is growing. The number of users is growing. The wealth is growing, and the energy consumption is growing. About the wealth, among the top 5 richest companies in the world, 4 are big tech, the 5th is big oil, not the greatest company to be in. So we, as an internet industry, we have great power, and we also have great responsibility to do something to decrease the environmental impact of our industry on the planet. There's a choice again. We can do it by self-regulation, or we might get regulated by national, regional, and international treaties that are already in place. So there are standards, there are agreements, ISPs have to follow them, data centers have to follow them. EU just had a big conference called Beyond Growth. So this is happening, people are doing it. We have to speed up the way that we are doing good for the planet. In simple pictures, this is the graph. We have to reverse the graph that goes like this, and it has to start going like this. So again, the magic number used to be 7.6%, but now I'm asking you to go better. Choose 10%, put it in all of your metrics and all of your OKRs, that every year the energy consumption of your company, of your industry, of your country has to go down 10%. Or if you appreciate my graphic design skills, then you can see the more detailed picture, which shows multi-solving. So you can choose one action that is actually going to solve multiple problems. And you have to do it on all kinds of axes. So whether you do something on a personal level that is going to do the more local impact or the more global impact. But whatever you do, it's going to have to be a lot, because we have big problems and we have to find very good, powerful solutions for them. So for RIPE, just to repeat, the suggestions are, the recommendations are: use the 7.6% decrease, create a sustainability task force, and for anybody in the position of power who can make decisions, demand that there is sustainability considerations section in every presentation, every paper submitted, every funding proposal, every solution that you implement at your work. That's the least you can do. Because until now, we have been kind of playing by the rules, but now it's time to move away from that and towards civil disobedience. And then it also becomes personal. So this is a picture of my daughter, Alisa, at her first RIPE meeting, there in my hands. And below is her at Amsterdam airport at the protest against private jets. She got arrested. It was not the first time. It won't be the last time. And yeah, she's very brave. I'm very proud of her. Thank you for the applause. And I'm also sad and angry that she has to do this. How did it come to that the new generations that joined the RIPE meeting in 2004 now have to go and protest against us, against the governments who did not do their job to provide the future for these young generations. But she's not alone. There is many more people that are going to the streets and using the civil disobedience as a tool, in addition to degrowth, to ask for big changes. So I'm inviting you to join the Scientist Rebellion. And to conclude, I want you to be alarmed. We are in a polycrisis. Do the degrowth, join the existing movements, join other communities, and also take responsibility for the global impact of what we do locally. Stop using fossil fuels and imagine a different world. Imagine a world with climate justice, a world without fossil fuels, a world that we can leave to the future generations. We can do it together.
Thank you, Vesna. Thanks for standing up. So I think we already have questions in the online queue. Jan will take care of them, and everyone else, please align yourself at the microphones.
Yes, we do.
We have a couple of minutes left. So let's take one online question first. Can we get the...
Can you get this one to work?
Or we start first with Jovan.
All right. Some other people refer.
No, it works, yes. You look who is in the queues, not look at me.
Me?
Okay, let's go to the first question. Karsten Schiffner. Is Karsten here? No. Okay, that's why he's writing here. So what could be ideas of delabeling the internet as a green lifestyle per default? Yeah, is regulating the smartphone industry an approach in such way that renewing one's smartphone every 2 years might not be the best idea ever? What about innovation then? And an honest question, what is better, were the ESG, attending a RIPE meeting on site or online? Has this been examined? If not, will it?
Wow, great suggestions. Yes to all of them. And the question, is it better to do this or that? This is again going back to this kind of measuring, like what is my personal impact going to be, and how can I avoid to have the negative impact myself? That is important to consider. However, it's even more important to put our energy and innovation in finding more systemic solutions that are going to work for more people than just us who have a choice of attending the meeting one way or the other. We don't have time for those kind of questions anymore. We have to consider the bigger picture, basically, and other people who are in more dangerous situation already.
Okay, we have 6 minutes for Q&A. I'm closing the online Q&A, and I think we should close the
Yes, we
the mics.
also closed the microphone queues right now, so I would say Blake, Giovanni, and then Benedict.
Can we maybe just hear the questions without me giving the answers? And then if there is 1 minute, then I can say, because I already spoke a lot. So it's your turn.
If you will remember what.
Yeah.
So let's see.
Blake Wizeo, thank you for putting this together, Vesna. I kind of wanted to do something a bit similar, but I ran out of time for a lightning talk. Freely admit this is a comment, not a question. There is a €4 million European Union fund called SDK4ED, a software development kit for energy and debt. Technical debt correlates directly with energy consumption very, very often, which is a really good way to get your boss to recognize that you need to spend money to get some of this 15-year-old garbage out of your network. Anyway, it's SDK4ED.EU, I believe, but you can, I put some of that in the social network feed as well. Thanks.
All right, thanks, Vesna, for putting this presentation together. Giovanni, SID Labs, and Tio Delph. This is a talk to really spits crowd. I'm on your side, so to be sure here. I recycle my garbage. I don't own a car. I have a buck fits, so I'm on your side. I'm just gonna throw home something here. I would like to hear what you think about it. So I agree you have a problem. I'm on board with that. Maybe I just don't agree the way you want to solve that with the growth movement. I'm ignorant in the topic, so I'm gonna repeat what other people have said. So there's this professor in Harvard, Steven Pinker, and he argues that the growth is something like more negative, and they should be doing more engineering. So like reducing like energy consumption only makes sense for the current situation we have. If you can come up 100% clean energy, you don't need to reduce anything. That's him saying. So the solution is more engineering and less pessimism.
Okay, he's wrong.
As I said, I'm ignorant. So.
That was a solid answer. Okay, please try to phrase your question short. We will run into the break a little bit because we think it's an interesting one. Go ahead.
Benedict Stockerbrand, Stepladder IT. There's something we should be aware of as an industry, actually. Saving energy at any cost is a simple, straightforward solution that makes things worse if people start to commute again. With the impact of COVID, it's bad enough that we had to have a COVID pandemic to get us there. We have started to move less, to commute less for work, and the net benefit is quite significant. So there's no simple solution for discussions like this. But whatever we do, we have to keep in mind that if we reduce what we do, other things might have to ramp up again, and the net effect will be bad. On the other hand, think about what Bitcoin is and how it works, and how burning resources is turned into some kind of currency. That's plain sick, as far as I'm concerned. Thank you.
Completely agree. However, see whataboutism.
Rudolf.
Yes, I'm also quite interested in this topic, and on the mailing list we've discussed a bit, but I was quite critical of some telcos in Europe, but they do quite a bit already. KPN has set itself a target to reduce, I think it's energy use by 40 or 50% over 10 years, and has delivered on it in the last decade. Deutsche Telekom last year announced that it had saved 90 gigawatt hours, which is about as much as you need for a mobile network in the Netherlands, by switching to direct current in Germany in its locations. Basically, European telcos have a flat energy use of the last decade. What can this industry do more to deliver more savings on energy?
The measurements disagree. There is the International Energy Agency published these numbers, global trends. All of them are increased at least 10% over the last 6 years in global. So maybe some specific companies are doing good on their commitments. That is great. They should continue doing that. Everybody should follow them, but in general, the energy consumption is growing.
I see you wanted to reply. We don't have the time for a back and forth right now, so maybe take it to the mailing list and then we can all participate. Right
Thank
side.
you. Stephen Plugger. So my question is, if we all know that servers and network equipment all burn through energy like there's no tomorrow, that is true. But on the other hand, the internet also enables all of us to share information, not only us in this industry, but also the other industries, presumably making everything more efficient, also more green, I would hope. So basically the question is, if you could go back in time, is the internet on the whole a good thing or not for the environment? Because it could also like make other industries more green. So if you could go back in time, would you say no to the internet, or would you still go on with this project and this experiment we're all still participating in?
That's very hypothetical, but we can go back in time from the future to right now. So saying no to unnecessary, luxurious internet. And I'm going to name technologies that I dislike, which is 5G, VR, crypto mining, video calls. We could like reduce our usage while still enabling communication between ourselves.
Thank you. Would remind everyone who's getting up right now, the queue is closed because we are already running over time, and please go ahead.
Jarja Eriksson, also one of the co-organizers of this workshop that got mentioned here. So thank you for this. Just 2 quick points. I wanted to advertise a BOF tomorrow, tomorrow evening on IETF, what's hot at the IETF, and one of the topics is what can standards organizations do to help some of these issues. And they don't solve all problems. You also know that, but sometimes they can help, like enable standards that allow implementations to be sleeping and powered off at times when that's possible. And there's actually cases where that's had a significant effect. You mentioned 5G, by the way. 4G and 5G, the power difference is like 10x less power usage per bit in 5G, and that was in part because we can sleep more. So that's one thing. The other thing that I want to mention is that there's some reason for optimism in the sense that this isn't just an activist thing. This is a business thing. Like everybody that I talk to is very keen on reducing their power bills. And so I think we're, maybe the stars are aligned for some good things here. Thank you.
Thank you. So, Dimitri?
Yeah, thanks. Dimitri Kochmaniuk, Hostmaster UA. I think I spoke to the company today, which claimed their data centers are all powered by the green energy. I don't want to give them the free ad, but I personally employ one of such other hosters that also use only clean Swiss energy, and they also support V6. Anyway, so maybe we should praise in our community those who do use clean power, and by the way, nuclear is perfectly green power, as accepted by European Union. Likewise, the ARM CPUs are much better than Intel, and hey, running video call on your phone with a low power CPU may be better. So some behaviors can be more power efficient. So maybe we should kind of be conscious of those and maybe have a gallery of green companies in our region. Thanks for the presentation and bringing awareness to the environmental issues.
So last question.
Thank you, Fahad Al-Sharawi. I don't own a single Bitcoin and never owned one. And I just wanted to say, from somebody who's been to prison twice, thank you for raising your daughter to stand up for what she believes. It's not a question, it's just a thank you.
Thank you. Thank you, Vesna, very, very much. And with that, I would like to remind you that you can rate the presentations you have seen until now. You can also rate all of the other one. We appreciate your feedback and enjoy your coffee break.
Let's get started. Welcome to the second plenary of today. I'm Wolfgang, and I'm going to chair this plenary session together with my colleague Moin here. We are both from the program committee, and a reminder, if you want to join us in the program committee, there is an election. So if you would like to join the program committee, put your name forward, send an email to pc@ripe.net, and yeah, perhaps you can chair a session next Ripe. So the first speaker today is Karin from Netnod. And where's my notes? Karin Ahl from Netnod, and she's going to talk about how Sweden built a world-leading time network. Karin, the stage is yours.
Thank you. Very happy to be here. It's my first conference. I hope to come and visit more of them. I had a good first impression. My name is Karin Ahl. I'm the interim CEO of Netnod since a couple of weeks now. I'm here in another capacity, and that is that I'm also in charge of the technology area for time and frequency at the company. And I'm going to talk a little bit about how we in Sweden built a world-leading time distribution infrastructure. I'm going to start to look at the reasons and the requirements we had for a national time distribution network, and going to outline a little bit around the infrastructure we use to ensure the security, accuracy, and redundancy of the services. We work a lot with time as a service. We're going to look into the services we deliver. Time has both profits and non-for-profit services, and we are going to focus on the NTS. It's a very nice adding to the NTP that most of you probably know. And the main players throughout the presentations is not only us at Netnod, it's also the Telecom Authority, PTS, and RISE, which is the research institute in Sweden, formerly known as SP. For those of you who don't know much about Netnod, just short, we're an industry, or we're an organization with more than 25 years working at the very core of the internet. We operate the largest internet exchange in the Nordics, and we also manage this iRoute, one of the world's 13 route name DNS servers. We also provide DNS services to enterprise and some of the largest top-level domains in the world. And also, of course, my area, we develop time services with the highest levels of accuracy and security. And that's also our youngest child in the family. We're a neutral organization formed and fully owned by the non-for-profit organization Stiftelsen för telematikens utveckling. Try to say that in Swedish. TU-stiftelsen. We are focused on contributing to the development of the internet out of three perspectives. We are providing rock-solid, best-in-class services at the very core of the internet. We are ensuring full redundancy and the highest level of service availability in all three business areas that we are running. And we're also playing a role in standards and governance activities, policy discussions, not only for ourselves and the services we deliver, but also for customers who are interested in it and might not be able to do it themselves. And all these three targets are actually combined in time and frequency. So let's look a little bit about the background for time and frequency in Sweden. It started actually already back in 1997, where we started to deliver the first NTP service based on rubidium clocks. But it wasn't until 2014 that we got the big project at Netnod to start to develop a national distribution network. Between all those years, there were lots of things going on. It was pre-studies, discussions, needs were growing from the operators, and a lot of analysis were done from the government, from the operators, and also from the Telecom Authority. And some of the conclusions were that citizens and critical community services were in need and dependent on the availability of electronic communications. And the electronic communication as such had a big dependency on correct time and frequency. And time and frequency distributed by GNSS was also very easily spoofed or interrupted. That was also part of the analysis. So they wanted to do something different. And given all those factors, there were a clear identified public need, but it was also very clear that the market was not interested in deploying this kind of distribution network at the time. Just a short sidetrack, GNSS, we talk a lot about it, we use it, it's a great technology when it works, but I'm sure that many of you also know that it's easily interrupted and compromised. I'm sure you've heard of examples from your home countries, the borderlines, the customs are talking about it, airports, energy sectors, everybody. But when it works and it's good. So the national time distribution system. A system without GNSS from a national perspective could guarantee a more robust and secure distribution network. That was a given result from the studies, and the system had to be robust and available throughout the country. That was also one of the requirements. The services delivered from the system were also, it had to be on a price level so that all the operators could actually use the services. So the price was not, it couldn't be a barrier for use. Then it would have been a failure. And as we are also financed by public funding, and the network had to be placed and operated within Sweden, and the government needs to have some insight to what we do, and they need to be able to make an audit or anything like that. And the funding, we have a very robust funding and financing, and as I said in the beginning, it's not only us at Netnod who are involved in this, we also have PTS, the authority, and RISE, who is monitoring the whole system. And it's really a tight cooperation. It's a success factor that we use a lot and talk a lot about. The public-private cooperation is a form that is not given all the time, but in this case it really works. And we are funded from the financing for electronic communication. And that is a fund put together from 1 ppm of the yearly turnover from the operators, and it's matched with as much funding from the government. And from that fund, they spread it over, for example, redundancy, new fiber paths, emergency power, backups, sync and time, which is us. And on a yearly basis, we can work on developing the infrastructure, doing better and smarter things for the network, move closer out in the country and establish more nodes. It's an important cooperation, and it means also that we have a long-term view on what we do with the public financing and the public planning. It's not on a yearly basis. It's not a market economy in that case. So let's move over to the infrastructure and have a look at it. You could see the map before. On all these sites, we have dual nodes. As you can see, they are duplicated on each side. It's all the critical equipment is actually doubled. So you could have a redundancy. For example, you can see in the bottom, you have the white boxes with the red digits on it, the cesium clocks. And all the parts above it is actually off-the-shelf products from different vendors, which also makes it easier for us to replace if something happens. But it works. It's really off-the-shelf products. The only part that might not be off-the-shelf is the NTP and NTS servers on the very top of the rack, which is custom-built FPGA-based hardware implementations. And we will look into that later on. On all these sites, the 6 time nodes placed in 5 different cities. We have it in secure bunkers. We have time traceable to UTC, which is monitored as well and produced by SP and RISE. We both have free and commercial services with different SLA and accuracy. And it's operated by us, monitored by RISE, and financed by PTS. And we're looking into more nodes and spread it out in the country. I'm not sure that we will take that step, though. There are new technologies coming, and we're all the time looking into new technology to be able to transport time on a longer distance, because it's quite a heavy investment to establish those nodes. Time as a service is something not very often spoken about, but we have different services that we both sell and not sell, actually. It's both for-profit and non-for-profit. NTP service and the NTS service are examples of the services we supply without profit. So if you are interested in any of those services, you can just go online and find it on our website and start using it. If we look on the commercial side, we have Netnod PTP, which is our premium product on a dedicated fiber, highest accuracy, security, etc. But we also have Netnod Time Direct and Netnod Time Remote. Both those services are not the same high accuracy, but it's redundant with high SLAs, and you really know the exact time for your industry. If we look at Netnod Time Direct, it's actually something that is very easy to start to use. If you are in any of our data centers, or if you have an IX port, you can automatically upgrade your account and start using time. This is a service that is very often used by fintech companies or banking. Also some of the energy companies in Sweden, they are usually fairly small companies on the spread out over the country. They use it a lot, and it's a good primary source for them. Netnod Time Remote is the first adding we did alongside PTP, and it's time over a VPN channel out to the countryside. And this is a way for us to move even further out in the country, away from our sites. And it's a CPE, and the CPE's clock is set by Netnod's clock, so it's between those 2 points that we have a VPN connection. And this is also something that the energy company and the national energy power plant is looking into right now to use for their extended POPs. Looking a bit deeper into NTS. I'm sure many of you know NTP, and NTP is a vulnerable protocol with no security. We can see a lot of attacks, and it's often something that we hear about, and customers contacting us saying they have an issue. They're usually put into a very hard attack. It's also difficult to scale the security. And we started to look into this quite early, actually, but it took some time for us to take the step forward. And we looked into adding security to NTP in different ways, but we ended up looking into this algorithm that adds authentication and encryption to it. So it's NTP with an S. And it scales in a number that we can't do with any of the other products. And Netnod got involved as co-authors to the IETF working group during 2018, and 2 years later, we had an adapted RFC, but it took already as much as 3 years for us to get it implemented on all our sites. So it's not that easy to just get an exception and start rolling it out. But we're very proud of it, and it's used and it's taken up by the industry as well. We have it in all the 6 sites and all the servers, as I mentioned, so you can decide from what server you would like to go and get it from. We can see most customers go to our Stockholm sites, because those are the ones that you know most of, but you can also go to Luleå, Sundsvall, Gothenburg, and Malmö, of course. As I mentioned earlier on, the hardware NTP is the one that we have built on our own, but it's not something that we try to hide or have as a secret. So everything is put on GitHub, of course, and it's an open source. It's actually quite different in a way that it's put on and kept on this circuit. So we know much more about our NTP than if you go to take the NTP from, for example, NTP pool, because you can get any source available from anybody. So if you take our NTP, you know it's actually more secure than if you go to the pool. But it's an open source FPGA code, and we are very happy to share it with you. I think you are familiar to the cards and you can work on them. We don't think it's such a big cost, but that card is around 5,000 euro today. The hardware NTP with NTS is something that we put into a commercial vendor box. It's a white box. We just wanted to try it out and it worked really well, so we won't change it. There are many other variants possible, but for now this really works well for the need we have. There might be a case that we will upgrade it when the traffic increases even more. To show you some examples on how to connect to it, I'm sure you can find it online on our website. You are fairly digital, all of you. But we can look at the references. It's more easy to get an overview of it. We have the white papers, of course, and we have the how-to. And in the how-to, there are a few examples on how to do it, but also contacts if you need some support when you try to set it up. We also have a list of Netnod time services, but the one that I would like to push forward is actually Access Communication. I'm not sure if you know about them, but they build video systems, hardware supply and software supply. They rolled out the NTS support around Christmas time, and we could see an increase in traffic quite heavily at the time. It was actually quite astonishing to follow. We have white papers, how it works and why it's important to you and your network, how we developed the world first hardware for it, and also the implementation of network time security. A few conclusions. Well, developing this kind of national time distribution network, even though Sweden is a fairly small country, but stretched, demands definitely a lot of expertise, and expertise and knowledge in time is not easy to find today. We work hard on recruiting those people to our business, but they are really hard to find. You need investments, and you also need cooperation. And the private-public cooperation has been a huge success factor, and it's critical to us to keep that going, because we need long terms in this. It's nothing that you do in a year or 2 or 3. You need like a 10-year period to have an overview of it. And also, I want to say that the customer doesn't always know what's right, because we can see a lot of time when we talk about time and frequency, and the customers say they don't see any need of it. And then something happens, they come back to us and say, do you have a service for me? And we do, of course. And lots of countries and economies talking about this today and how to find the motivation, how to roll it out. They need to understand that the need and the insight, it's not there yet, but it's coming. So keep on talking about it. We also need to be aware that distribution and the model today, technologies today need to change. They need to keep develop, because we see IoT and sensors being a big thing right now. We can't really supply them with anything that is RFC level. We have ideas and we have some tests, but it's nothing that is accepted yet. But we need to continue the development of new protocols and algorithms all the time. And I would like to conclude by showing you a small video clip. We'll see if it works. And this is to show you how the traffic actually started to roll out. We started the service in Stockholm in February 2022. And at the time we had 1,000 to 2,000 hits per hour, only enthusiasts in the very beginning. Nothing happened for 8 months, and then we attended a hackathon in Berlin, talked about this, discussed about it, and the traffic took off. And during November, we could see a rise from 10,000 to 100,000 hits per hour in just a few days. And then our people in charge said over Christmas, nothing is happening, I'm taking a few days off. He was wrong. So mid-January, we had 1 million hits per hour, end of January, 2 million hits per hour. So this is spreading. It's not a huge amount of traffic, but it's exciting to see how something just can take off in a few weeks. And you can see this film. We have a longer version as well if you're interested in it. And it's really, yeah, I'm really happy to share it with you today. Thank you.
Thank you, Karin. I have 2 online questions. Well, actually 3, but 2. And I'm reading the first online questions, then we take the mic, then the last online question. So first online question is from Alex Band. Very nice presentation. Speaking of security in software, are you aware of Project Pendulum, an open source effort to provide modern NTP and PTP implementations in Rust, the programming languages that guarantees memory safety? It would be awesome if Netnod and other parties could support this work in some shape or form.
Yes, we're aware of it, and I know that we've been discussing it.
Okay.
Yeah.
Hi. My name is Daniel Karenberg. I'm one of the co-founders of RIPE. I'm first and current employee of the RIPE NCC, and I'm speaking only for myself. Thank you very much, Karin. We have a very long tradition of Swedes talking about time. Peter Löfberg started it, talking about his clocks on Reimersholm. Here's my question. Do you always talk, of course, because of the funding and so on, about a national time service? And you did say between the lines that you don't mind that people from outside Sweden use your NTS service. Can you be a bit more explicit about that? Because people might have missed that. And also, if I'm here in the Netherlands somewhere and I want to use NTS, what's the best strategy? Should I use yours? Are there others?
There are others, not many. I think there are 2 or 3 suppliers or producers of NTS today. I think there is a local in the Netherlands actually, so you should check. I can have a look at that. I'm not the expert, but yes, if you're not situated in Sweden, you can also use our services, of course. We try to support other initiatives internationally to have a local supplier of time, but we will try to supply you with time if you need it. Yeah.
Yeah. Hi. Hi, Giovanni, SIDN Labs and TutorialThis here in Holland. This is great work you guys done that. We are trying to build something similar to what you guys are doing, but you're much more far ahead. You have much more money. I want to just point to something. If you wish to serve more clients within Sweden, like your IoT base, you should connect your server to the NTP pool.
We are connected.
Oh, you're connected?
Yes. Okay. Many years. Yeah.
So the traffic that is shown, like you get 2 million queries, what's the current numbers that you get? You should get way more than that if you're connected to the pool.
Yeah, we're more than doubled from this. And it's quite stable since a few months back, actually. So it's something happening. We think there is some sort of hardware implementation somewhere. We don't know who or where or why. So we are really trying to find out to stimulate more take-up of it. So we are following it closely.
All right, thanks.
Okay, next question is online again. That's from Carsten Schiefner, no affiliation. Actually has 2 questions and I'm asking the second one first. Will Netnod be feeding pool.ntp.org one way or the other? That would be possibly be a great addition to your service.
It's the same as we heard earlier. So we are delivering to people. Yeah.
Since I didn't pay attention and I'm asking the other question as well. Question 1 was, given the kind of service, but also your notion of governmental audits, is this considered a critical service according to NIS2?
Not yet, no.
Okay, thank you.
Bill. Neil O'Reilly, and although I'm vice chair of RIPE, I'm putting that hat aside. I'm just, your map makes a great impression on me, and I can see that there's demand from all over the world. but one part of the world stands out as a hotspot of demand, and I'm curious about it, and I wonder if you'd like to say anything about it.
Yeah, the only thing I can say is we don't know why it's actually looking like that. We're trying to find, we have a few different reasons, but we don't really know. Yeah.
Thank you.
Last online question from Hendrik Krammelsund. He wanted to know if you know how much a rack of your weights.
Weights?
The weight.
No.
Okay, I guessed so.
I'm sorry.
Okay, I think there are no more questions. Thank you, Karin.
Thank you.
In the previous session, we have seen a nice presentation from Vesna about the environmental impact of internet, but let's see some practical numbers to check if we can really do it. Please welcome Peter Ehiwe from Streibelt, presenting about techniques to reduce network power consumption. Thank you.
Okay. Hi, my name is Peter Ehiwe. I'll be talking to you today about techniques to reduce network power consumption. So a survey was conducted by the Uptime Institute, and over 500 IT and data center operators were surveyed in that survey. And one of the areas that they really care about in terms of being able to, sustainability metrics that they really care about is IT and data center power consumption. They care a lot about PUE, server utilization, water usage, carbon emissions, e-waste, and so on and so forth. But one area they really care about is IT and data center power consumption. So my talk will focus on some strategies that you can use on your network today to reduce the amount of power that it takes to run your network infrastructure. It's not an exhaustive list of things, but it's one that I feel would appeal to a wide variety of the people in the audience. So my focus of my talk will be on that highlighted sustainability metric. Hopefully we can drive that down with some of these techniques. So if you look at the research around reducing network power consumption, there are two main buckets or two main research areas. First, you have sleep mode, which is about turning off network components to save power. And then you have rate adaptation, which borrows some ideas from microprocessors and dynamic voltage and frequency scaling and tries to apply that to networking. But that would not be my main focus because it's still not having wide commercial adoption. But a lot of the things I'll be talking about will fall under the sleep mode bucket. And as I said, it's not an exhaustive list, but hopefully, people here can relate to some of these things. So the first is IEEE standard 802.3az that effectively replaces continuous idle on Ethernet with low power idle, and that allows you to save power by turning off parts of your transmit circuitry when there's little or no traffic. So it works for 100 Ethernet over copper transmission, so 100 base T, 1 gig and 10 gig base T. And for this to work, both ends of the link need to support IEEE 802.az. And in terms of its effectiveness, I have, I just took an image from a research paper, and there's an interesting study around the effectiveness of 802.3az as the load on the link increases. And what you find out is at 24% load, you reach diminishing returns, and effectively the link behaves like an always-on Ethernet link. However, at 0% load, the amount of energy consumed to keep that link up is about 10%, so you have about 90% potential savings there. And as you increase the load, the energy consumed increases, so the amount of energy you can save over time reduces. But even at 8% load, you still have 50% power savings potential. There are techniques to actually make this more efficient by using buffering, but basically to keep the link idle for much longer. But you need to think about your application and the impact of the increased latency would have on your specific environment. So there are other enhancements which I think is pretty cool, the ability to determine the length of a cable and then adjust TX power accordingly to send the data from point A to point B. So the second thing I want to talk about in terms of sleep mode techniques is wireless access points. So I think there are key questions as, if you operate an enterprise network or a network with a lot of access points, we need to ask ourselves, do we need to run all the APs at the same time? At all times, enough peak hours? Do we need to run those APs after 7 when no one's in the office or on weekends? I think that even today's world of hybrid working, these are questions that we need to ask ourselves, and the answer will vary from business to business. And also, can we develop an algorithm that dynamically powers up APs to meet user load? So there was an interesting research on the last question conducted by a group of researchers in conjunction with Intel, Enterprise Networking, and Dartmouth University. And they developed this green clustering algorithm that effectively groups APs in clusters based on spatial distance and elect like a cluster lead AP that serves that cluster. And you have like surrogate APs that are powered up as the user load increases. There's a lot of details in the research paper I linked off here, but the interesting thing is in Dartmouth College, they were able to save 20 to 50% in terms of the power required to operate their wireless network. And in Intel, they were able to save 50 to 80. And then they also had an additional 10% at certain 1 hour intervals power saving, so up to 90%. And the reason for that additional power saving was due to specific nuances of their network architecture, where they had the access points connected to the dedicated switches, no other workloads connected. So they were able to power off the switches as well, in addition to powering off some of the access points. And then the disparity between the savings from Dartmouth College and the Intel wireless LAN is basically due to business requirements. And so Dartmouth required basic connectivity. Intel is all about high bandwidth, high throughput applications, video, and so on and so forth. So they deploy a much densely populated Wi-Fi network, while Dartmouth is more sparsely populated. So port LEDs, if you're a hyperscaler, you're probably interested in this. I think another question I think we need to ask ourselves if we operate, really, really large networks. I'm talking about, 50K, 100K switches. Do we need all the link LEDs flashing all the time with no one looking at them? Most of the time, you look at LEDs when you're trying to fix a problem with a link. So what if we could turn off LEDs by default and turn them on when maintenance needs to be done? So I did a simple maths here to calculate the energy savings that a hypothetical hyperscaler with 100K switches, and there's very few of them, but even telcos, they have lots of networking gear, networking footprint as well. But with an average of 20 cables per switch, and basically if you assume an LED indicator uses about 10 to 15 milliwatts of power, you would use about 525,600 kilowatt hour for a year, right, to just power those LEDs. And if you think about the cost savings, if you use the world average price for per kilowatt hour is 0.165, you save at 6,400 per year, which is cool, but not really, exciting to me. I think the exciting one is the ability to, power, divert that energy and use that to power, 130 Irish homes for a year. So finally, I'll talk about rate adaptation. This is more kind of theoretical at this point. And it basically, as I said, takes DVFS and tries to apply it to networking. There are not many commercial implementations, so I won't spend too much time on it. But if you're interested in reading more about this, I can see I have 12 seconds left. So you can check out the research paper. And if you have any questions, let me know, or we could talk more later. And I'd like to know what green initiatives you're actually working on your end as well. Thank you.
Thank you. I think we have time for 1 or 2 questions, if there is anything. Okay, thank you very much. The next one is Olena Kushnir, and she's going to talk about regional success stories in the conditions of war. Olena, the stage is yours.
I will be a little bit faster because I have limits in time. Good day, ladies and gentlemen. I will share some great regional success stories in the condition of war. For those who don't know me, how to use this? For those who don't know me, my name is Olena Kushnir. I am the co-founder and director of WebPro company, Ukrainian telecommunication operator and integrator IT solutions. Additionally, I am an active member of several specialized associations, including the Internet Association of Ukraine and Ukrainian Union of Industrials. As Ukrainian LIR, my company also is a member of RIPE NCC. 10 years ago, I sat like you at the conference, and could I even imagine that Ukraine will be bombed or that we have the full-scale war? But life gives us new challenges that make us stronger, and every challenge gives us a new experience. Today, Ukraine specialists overcome huge obstacles and bring telecommunication, telecommunication networks to a new level to stable operation, despite all the destructive conditions. Here are some of the challenges we face it every day. For example, blackouts, constant missile attacks, destroyed infrastructure, constant cyber attacks, dangerous working conditions of our employees, mobilization of employees for military services, and theft of Ukrainian resources. Let's start from the blackouts. 80% of the energy infrastructure was destroyed by massive attacks. The operators made a number of correct management decisions. Home providers have actively switched to PON technology, but business providers have more difficult because it was necessary to equip technical sites with serious uninterrupted power supply systems and generators. Also, providers used Starlinks, especially in cities freed from the occupations. In the photo, you can see the Kherson city immediately after the liberation. People went to the central square of the city to charge their mobile phones and to get the opportunity to call their relatives and tell them that I'm alive. This is there is an incredible touching photo. Another know-how became shelters of unbreakability. There are rush heating shelter where you can find free tea and a comfortable place for work. Of course, unlimited high-speed internet. Our company, for example, has connected the free internet in 3 cities in Ukraine in such shelters. You can even imagine what could be seen there. Many offices, students passed exams, while mom is working online, her child is watching cartoons next to her. And even beauty salons, because somebody did not have time to finish her manicures. It was crazy, but it shows that the Ukrainians are really unbreakable. This is Mykola Kucheruk, director and owner of the elite line provider from Kramatorsk, Donetsk region, only 50 kilometers from Bakhmut, where heavy fighting continues. Mykola became an example of unbreakable of all Ukrainian telecom sphere. During blackouts, due to the lack of employees, he personally spent not one night at the technical site to control the work of generator. Ukraine is still subjected to a large number of missile attacks and drone strikes every day. And the telecommunication infrastructure in various regions suffered serious damage. The enemy is very active in attacking civilian and critical infrastructure. We lack equipment and engineers. On 9th of March this year, when Russia launched 81 missiles in a different region of Ukraine, some missiles hit energy infrastructure object, which led to momentary blackout. You can see on this drawing how the traffic flowed. The huge Kharkiv region remained almost without communication. I will say from my experience of my company, how to change 5 different routes from Kyiv to Lviv within 1 day. Next one is the dangerous working conditions. At the QR code of the slide, you can see a link to the Google folder where you will find many photos from the life of the telecommunication industry of Ukraine during the war. This is a sad story from this photo from one of the biggest Ukrainian telecom operator, Ukrtelecom. The driver died and others were seriously injured. And this is the trunk operator Atracom. The photo was taken in Kherson and Vovchansk, Kharkiv region. The employees were injured, and these pieces of metal were removed from the bodies of the engineers. We risk our life every day so that the Ukrainian segment of internet will not fragmented from the world network, and our people stayed connected. Next is the cyber attacks. I received this official statistic from a computer emergency response team of Ukraine at the State Service of Special Communication and Information Protection of Ukraine. Almost 3 times more cyber incidents were registered in the year 2022 than 2021. More than a quarter of all cyber incidents and cyber attacks were directed against the government, local authorities, and other sector of critical infrastructure. Russian cyber attacks in Ukraine are often synchronized with ground and air strikes on civilian and critical infrastructure. And in the world, Russia's cyber attacks have become part of their information and propaganda machine. Since the beginning of the war, attackers supported by the Russian government have aggressively attacked not only Ukrainian, but NATO's member states too. I saw 2 excellent articles that highlight the real situation in Ukraine with IP resources. As of February 2022, AS number 2197 were assigned to networks in Ukraine. In the last 12 months, more than 100 network registrations have moved out of Ukraine. More than 40 of these are now registered in Russia. This is in the biggest line. Some networks disappeared from the global routing table. For example, on March 2022, AS number 6712 format TV, based in Mariupol, disappeared from the global routing table. It returned after a month, but with only half of the address space that it was using. Other large networks from the same region, such as AS number 57864 megabit and AS number 35714 info services, also disappeared around the same time, but did not return it. Here's another great article. Internet services in Russia-controlled part of eastern Ukraine have been provided through Russia transit providers for many years. But last year, internet resources in Russia temporarily occupied Donetsk and Lugansk changed in front of the world as if it were actually Russian. And this region have received a type of Russification as a simulation where the Ukrainian residents of the region have been forced to accept all things: Russian language, currency, telephone numbers, and of course, internet. And of course, another problem, traffic switching is one of the biggest problem in occupied territories. Occupiers first of all turn off mobile communication from Ukraine operators and also switch fixed communication channels to the Crimea operator Miranda. Everybody knows that Miranda Media is daughter of Rostelecom. And the Ukrainian telecom sphere is really unbreakable because we also have our guardian angels. It is a voluntary from NOC Alliance. If you have not yet had time to join the guardian angel to Ukraine telecom sphere, I urge you to do it. Now Ukrainian delegation here, because we are part of the international professional community and we have a unique experience that we are ready to share with you. Ukraine is strong, brave, unbreakable, and we are ready to open it for you. Thank you so much.
Thank you, Olena. We have time for questions, 1 or 2.
No question.
Okay.
Please keep Ukraine connected. Thank you.
Thank you very much. So the next one should be a remote presentation. So I'm setting him role speaker. And the next one will be Florian Streibelt. Florian, are you with us? Florian?
Yes, I'm lost in the permission.
All right.
Just a second. I have to
Can
share.
you share your screen?
I'm about to do that. This should work now.
Cool.
And my camera
Fantastic technology. And Florian will be talking about DNS, IPv6, and how broken is everything. Florian, the stage is yours.
Yes. Hi, my name is Florian, and I'm addicted to DNS. So in today's lightning talk, I'm talking about two very light topics, IPv6 and DNS, of course. So let's see how bad it can be. And actually, when your client and recursive resolver are both only able to use IPv6, and there is no IPv4 involved anywhere, that's what I call IPv6 only in this talk, the experience can be quite underwhelming. So what you see here is what you get when you point your browser at the website of Wikipedia. However, when you are checking with some IPv6 testing page, you get a green check mark. And when you do a DNS lookup from another machine, you get IPv6 addresses, and you can ping them, and they even would serve the website. So where does it actually break? What's wrong there? It seems working, right? Everything you do to debug is actually working. So of course, it's DNS and not IPv6. So again, we prove it's DNS and never the network. But on a more serious note, the issue here, of course, is that the name servers have no IPv6 addresses. And the interesting fact here is that the underlying issue was already described as early as 2004. So what better to do as an academic to write some software, start a measurement campaign, and crunch some numbers, right? But first, let's talk about DNS and refresh our DNS knowledge a little bit. So here you see the well-known DNS tree that we all know from our textbooks with the root zone at the top. And what you have to know is for a domain, or better a zone to work, it has to be known and configured in its parent zone. For the .NET top-level domain, this would be the root zone. There it has to be configured so we can find it when we are looking for it. And to resolve a hostname, for example, mail example.com, one has to start at the root and then follow along the edges of the tree, walking from node to node. This works because the name servers of a zone will reply with the DNS records of its child zone when the name requested is in or below the respective child zone. So each zone will hold all information about itself, but only a minimum about its child zones. This allows scaling and makes each zone a single source of truth, but also requires some cooperation. However, there are some caveats. First of all, it's clear that each zone depends on the parent zone. It's a tree after all, and that's where the delegation has to happen. Note that this data has to match the information in the child zone, so you have to make sure that parent and child actually have the same information for the name server delegations. And additional, you see when using external name servers, you add additional dependencies. Here, example.net on the right will depend on the availability of example.com, and example.com will depend on .com. So example.net actually will depend on the .com TLD. Also, a common configuration is to use name servers whose names are in bailiwick of their own zone. This means that, like you see for NS1 and 2 example.com here, their fully qualified domain name ends in the name of the zone itself. This leads to the problem that to obtain the addresses of these name servers, one would have to connect to those servers first, which you can't do because you have no addresses to talk to. So we have a circular dependency, and this is resolved by putting the IP addresses into the parent zone using usual AN quad A records. But forgetting these glue records is a very common misconfiguration, and we will see later how this then looks. After all, we identified 5 root causes for failing IPv6 only resolution. They include completely missing the quad A records for the name servers, but also mismatch between parent and child. But please see the paper for more details on these five issues. All of these misconfigurations are not mutually exclusive, and they are not specific to IPv6, but as long as resolution via IPv4 is working, these issues will have no practical impact. So this makes them very hard to spot, as the full resolution chain has to be verified. using only IPv6 if you want to check for these issues. And note that one single misconfigured zone will of course break all its child zones below it in the tree. So let me give one quick example how indirect dependencies can make this even harder to spot. Here we look at a perfectly configured example.com zone that has 2 external name servers in some DNS.tld. The delegation from the parent zone.com is set up correctly as well. And also the name servers have quad A records configured in their zone. However, the zone of the name servers some DNS.tld uses name servers in yet another zone, and this zone apparently cannot be resolved using IPv6. So this breaks IPv6 resolution, as the IPv6 addresses of the name servers cannot be retrieved from this indirect dependency. Now, to check how the situation looks in the internet, we looked at passive DNS data provided by Farsight, and I just glance over this very quickly here. It's all in the paper. And last October, I sent 56 million DNS requests to the internet. So please check the paper for more details on that. And there's also a link to a longer recording of this, of a longer version of this talk that are linked at the end of this presentation. So what did we see besides a lot of broken name server implementations and a very convoluted DNS topology? Let me highlight 2 key findings from the zones that show some form of IPv6 affinity. That means we see some quad A records for the name servers or some web servers that have quad A records. So we think they might be interested in having working IPv6. So from these in last August, almost 45% could not be resolved using only IPv6. So they are not working if you have only IPv6 connectivity from the root to the zone. When now zooming in on these and looking at the reasons why they are not working, this is what we find here in the plot. For the majority of zones, the parent zones are already broken. So even if these zones would have been configured perfectly correct and have quad A records, you would never be able to resolve them because the parent or one of the parents isn't working with IPv6 only. So why is this form of misconfiguration often overlooked? For example, the mill TLD had no glue records for quite some time for IPv6, where we don't know if this is on purpose or was on purpose or not. So the problem here is, at the moment, there is no real operational impact if IPv6 resolution is not working. All of the resolvers usually have IPv4, and DNS is specifically designed to be robust and failure tolerant. As long as at least one authoritative name server of the zone can still be reached and you have something in the cache somewhere, name resolution will actually work. But this also means that monitoring solutions have to take this into account, not just for DNS, by the way. So as we have seen, this example here is obviously not sufficient to monitor DNS availability, but it seems that many solutions out there currently in use just look more sophisticated than this script, but they are in reality not really. So let me already summarize. What we did was we conducted a long-time passive measurement study over the dataset of several years and verified with active measurements as well. We did the root cause analysis for broken IPv6 delegation in an IPv6 only setting, so only IPv6 for everything, and confirmed our findings with the active measurements. In August 22, around 45 of the zones that we considered IPv6 affinite are not resolvable using only IPv6. Most commonly, the zone names of or the parent zone name servers were not able to resolve. So what we recommend is when you are monitoring DNS to check for IPv6 across the entire delegation chain. And we also want to point out that the IPv6 readiness of websites or of the web may be impaired by non-IPv6 resolvable domains, making web assets unretrievable. That means some parts of a website might be missing, like JavaScript or fonts, which is really hard to spot. So take note, happy eyeballs can trick you. And I was pretty fast. With that, I'm at the end of this talk. Happy to talk questions. Also, please don't hesitate to send me a mail for questions. And yeah, there are links to the paper and the longer recording. Thank you.
Thank you. Thank you, Florian. Are there any questions? we're a bit early. Okay, and with that, reminder, please rate the talks. Go to the website ripe86.ripe.net, plenary agenda, click the rate button and give your rating. We are looking at that. Also, if you want to join the PC program committee, please put your name forward. Florian, thank you very much for the remote presentation. And I hope that we see you in person perhaps next time again.
Of course. So happy to be back.
All right. And with that, reminder, there is another BOF today. So there is a BOF about best current operational practices. And after that, there are drinks. And hope to see you all there. And with that, thank you.
Okay. Everybody, welcome to the BCOP Task Force meeting. Today we have very interesting topics. I'm Jan, this is Benno.
Hi. Hello. My voice is a little bit hoarse, I understand.
There is water.
Okay,
let me
just try to get
water.
everybody from the lobby into this room. We're lacking an old-fashioned bell. Formerly, we had a real bell, ringing the bell, and everybody would then go to the next session. But I tried to do it with clapping my hands and shouting around. So thank you for joining the BCOP session. Small reminder. Thank you. Thanks a lot. So the BCOP, we call ourselves still a task force, but normally task force will end in 2-3 years. But we still have new work to do. So we still exist as a task force. And the idea of the task force, the BCOP, the Best Current Operational Practices Task Force, is to pitch, people have an opportunity to pitch their idea. Is that a good idea to document a current best practice? Have a discussion in the room. If there's expertise in one of the working groups, definitely the document should be brought to that working group. And at the very end, can be spin back in this working group, given kind of an end of presentation. Or all the work can be done here. And we have seen some successful documents now being published as RIPE documents. So that's kind of the origination of the setting of this working group. But we also want to give a platform of ongoing activities. And I think for today we have a very interesting agenda. So the first one is by Shane Kerr, is on the DNS Resolver task force. We'll give an update and later, give us an update of the task force. And the second presentation, I think, we reserve 40 minutes. It will be a presentation and definitely a discussion with the group, with you here in the room, about how we can contribute to such a document to help think about the best practices for running networks in natural disasters, social unrest.
So this is more of a relaxed session. So please come forward. This is like it's not like presentation out. It's like more of a discussion in the group. And we would like to ask you, when Olena says about her idea, to create a discussion how everybody can help in documenting the experience where currently the Ukrainians have how to run and maintain networks during the war. So it's also available for people if the social unrest or natural disaster happens in the country. So we have some basic documentation on best practices, how to run and maintain the networks during unfortunate times. So with that, what? Yeah, Shane is sitting on the edge of the chair.
Shane, please come.
Shane will tell us what all the great work they've been doing in their task force. Come on.
So you can use this. Okay, excellent.
I'll try the microphone here. All right. Is this timer doing something, or should I just ignore it? There's a timer here.
Jan is the expert.
I will set the timer, don't worry.
I don't know how long this is going to take. We'll see how it goes.
How much you want?
Well,
you got 15 minutes. So.
I was given 10 and now I have 15. I'm sure it's enough time. We'll see how it goes. Hello, everyone. My name is Shane Kerr. I'm one of the chairs of the DNS Resolver Task Force. And this is just going to be hopefully a pretty brief update explaining what the task force is and where we're at. So, all right, my slides here are not updating, so I'll look at the ones down there. So this is the charter of the DNS Resolver Task Force, and I won't read it out, but basically the idea is to come up with a set of recommendations about what we think are good ways to run a DNS resolver. And we had a discussion initially about who the target audience of this was. We'll talk a little bit more about the origin of this effort in a second, but we decided that we kind of want to have maybe two styles of recommendations. The first audience is people running public DNS resolvers. So these are DNS resolvers that are meant for anyone on the internet to use, or people without a specific relationship with the operator. But then we also want to make recommendations for people running any sort of resolver. So for a university or a business or things like that. So we expect that most of the recommendations that we have will be universally useful, but there will be some which will be more useful in the context of people running a resolver that's more open. So what is the status? The task force was kind of agreed on at the last RIPE meeting. We had a sort of slow booting up period, as you can imagine. And to be honest, we had some initial discussions and a bit of work done generating some, well, we'll talk about what we've done. And after that initial burst of activity, we haven't been super active. So we need to kind of pick that work up. We were supposed to have a draft in time for this meeting. We don't have that. We do have a fairly comprehensive list of topics that we are going to include in our recommendations, and we have great dreams and hopes for the future. So going backwards from the status to how we got here, basically the idea is that there are public resolvers, and many years ago, it used to be that people would run a DNS resolver for their local network, an ISP or a company or things like that. At some point, people realized you could just query these on the internet, and it was bad because then people could use reflection attacks and hide what they're doing and things and overwhelm your resources. So we decided that open resolvers were bad. And that's true. However, at some point a little bit later, some people decided that actually running a resolver intentionally open to the internet, the whole point was to make it sort of a public service or some sort of business, was a good idea. And so that started. And like OpenDNS is one of the I'm having a little bit of technical difficulties up here today. It's not making me nervous at all, I promise you. So at some point, big companies like, for example, everyone here knows that Google runs a public DNS resolver, which gets tons of traffic. Now, there's not a million of these. There probably are a million of these, but there's not that many that people actually use. So they tend to be quite centralized. You could probably name most of them yourself. And so they're centralized, and they're centralized outside of Europe. So this is a problem for the European Union, because while I think the European Union is not super excited about businesses being centralized and pseudo monopolies forming and things like that, they're even less excited if that happens outside of their control. So the European Commission has serious concerns about the centralization and use of these public resolvers outside of Europe. So they did what you would expect the European Commission to do. They decided to get together and ask people to how they're going to solve this, decide to spend some money and things like that. So the RIPE community heard about all this activity. There's people at the RIPE NCC who follow what's going on in the European Commission regarding internet activity and things like that. And they and other people brought it to the attention of the RIPE community. And as expected, the RIPE community has serious concerns about any time the European Commission wants to start mucking around with the internet, with the expectation they're probably going to get it wrong and not do great things. So there's discussion about what to do about this. So one proposal could be, for example, do we want to run a public resolver for the European Commission or things like that? That's not really the right way. That's not really what people are excited about. So we don't actually want to do that. What we do want to do is what this task force is intended to do, which is make recommendations about if you're going to run a public resolver, or like I said earlier, any resolver, here's how you would do it in a way that makes sense to us. So, like I said, we started up a task force for this, and we had some initial meetings. And I'm going to talk very briefly about how we're going to be doing this work. We don't want to do a whole bunch of invention. There's no need for us to describe ways to manage keys, for example. There's a whole bunch of processes and best practices for this. So our intention is to, in a similar way to the BCOP document from RIPE about IPv6 equipment, they didn't decide to like tell you how to run an IPv6. They collected a whole bunch of RFCs and a whole bunch of other recommendations and said, these are good ways to do things. And maybe, so that's the intention, is we're going to reuse all that existing work and not just sort of have a list of work, but we also want to explain, put it into context and explain why we think it makes sense and what it actually means to someone running a public resolver. So that's the idea. That doesn't mean we're not going to write any text. If we see gaps and things like that, we're happy to add that. Another philosophy that I'm pushing myself is that I think it's okay for us to have opinions about things. I've been involved with earlier task force in the REP community, and we tried very hard to be, say, neutral and not push specific agendas and things like that. I think in this case, it's okay for us to have opinions about things, and I'll talk a little bit about what that means in the next slide. Yeah, so examples of what such an opinion might look like. One of the people on the task force, Vesna, is very interested in centralization of the internet and companies and resources, and basically saying this is bad and we should try to avoid that. And here's the reasons it's bad in the context of DNS resolvers, and here's what you can do about it and how we're going to help. Another example of a way that we can be opinionated is we're going to be happy to say that open source is better than proprietary, and here's why we think that is. So these are the examples of ways that we're going to try not to shy away from having opinions about things, even which may make some people upset and may be controversial. Now, this is going to be presented in a draft form and discussed with the REP community. So if there's a lot of pushback, we'll probably, I'm sure we'll be willing to change the text and things like that. But that's what I mean with that. So those were a couple of topics of special interest. These are the high-level bullet points of all the areas in a sort of unsorted list of the things that we want to look at and that we're going to go into. A lot of these are, it's not an even level, so some of these are going to have a lot more text around them than others. So for example, on the left-hand side, you see this knobs to tweak in the DNS. I'm a DNS person, so this section has like 40 different entries or something like that. They're not all going to be like that. But I think these are all important things that people running a public DNS server should at least consider. And I'm sure that current public DNS operators have considered them. And even if they haven't done anything about it, at least they've made a conscious decision to decide that this is something that they're not worried about. I'm not going to go through all of these, but this is all available on our GitHub page. So because I'm a programmer, I find the GitHub workflow very easy for me to use. So the idea is, how are we going to do this joint work? There's plenty of ways to do it. You can do a shared Google Doc. You can email Word documents around like the old-fashioned way. But I thought GitHub might be nice. The one advantage of doing things on GitHub is that it's all the draft and all the work is already available. You can download my slides from the REP meeting site and click on the link and see where it is there. Or you can find it's also on the mailing list. If you Google for the REP DNS Resolver Task Force, it'll be on the mailing list archives as well. So you can't really read this. That is not by design. It's just because there's a lot of stuff there, and you can go and see the kind of things that we're going to be considering. We also have some links to like RFCs and other documents and things like that that's going to go in there. Yeah. So that's kind of where we're at. So the next steps are, of course, we need to add text. We need to take this sort of list of things that we're going to be addressing and actually flesh it out. And then once that's done, we're going to publish a draft REP document, and that will go. We'll do that on our list. We'll be seeking feedback at that time. So because the list of topics is quite long, I'm sure that everyone in this room will have at least one of these areas that is something that they know and care about, right? So if you're on the infrastructure side, you're going to be more interested in the capacity and resilience side of this. If you're a software person, you're going to be interested in that software consideration, those knobs. If you're someone who's, yeah, so you can look at the list and think some of this applies to everyone. If you're a business person and interested in sales, then like help us try to figure out how to finance these things in a way. So For me, that's going to be one of the big tricks is how are these done in a sustainable way? Where does the money come from for this stuff? Anyway, and then that's it. That's the end of the work. And then we'll have a document which the RIPE community will have its stamp on about what recommendations we think make sense for resolvers. Now, what the next steps are beyond that is outside of the scope of the task force. Our work will be done at that point. My hope is that we can approach people who are running public resolvers or are planning on it, like the European Commission's effort, and say, by the way, here's a set of documents that might make sense. And I don't know if this would be something that RIPE would be interested in helping audit or anything like that, but that's for future discussions after the recommendations already exist. And that's it.
Thank you.
Thank you.
Shane, I have a question.
Yes.
Is this task force set and done, or you would like to ask more people to join your task force if they want to?
Task force are not the same as working groups or BCOP task force, in that the task force is blessed by the RIPE chair, and the members of the task force are set based on whatever criteria the RIPE chair has. So basically at this point we have a fixed set of members. Now, because progress has been so bad, the RIPE chair may want to replace the task force chair or ask for new members, kick people off. I don't know what the status of that, but we're not really asking for more participation at this time. But if you can convince us, then we're happy to be convinced. If you think it's important that you join this effort and have a lot of energy.
Thank you. So are there any questions?
Yes, please, people, go to
Please.
the mics.
And
we have 4 functioning microphones that you can use.
Yeah, please go ahead.
Yeah, that's a functioning one. Tema Gavrichenkov, servers.com speaking for myself. Just a provocative question. So how much of that work would the task force be happy to offload to GPT-4? Because I just tried to feed one of the section and the output is pretty sound.
That makes me have feelings. Yeah, I don't know. I'm willing to try it. Interesting.
Right,
I'm happy to be replaced by a computer. I got things to do.
It will be reviewed. It will be reviewed by the RIPE community. So yeah.
No, that's yeah.
Let's talk about it later.
Yeah, cool.
Yeah. So over there, please go ahead.
Thank you for the effort. I have one question. Maybe it's already too much into implementation detail, but will this also address a question of how to prevent people from using your resolver to DDoS other people, or, well, amplification attacks and so on? Because currently when I accidentally run an open resolver on the internet, I will get an email from the BSI who scan the internet space for open resolvers, and then people, please don't do that.
Definitely, there is a security section, I think.
Okay, thank you.
Somewhere. I promise you security is not forgotten. I guess it didn't put it on this bullet list. But no, that is definitely a very important question.
Yeah. So we asked Shane to give the presentation at the start of the week so that you have a full week opportunity to talk with Shane or some of the other task force members to share your thoughts. Maybe you can, task force is set, but you can contribute in many ways via GitHub or giving feedback. In the hallway, I had a discussion with, Mr. Jim Reed, about. No, we had a briefly discussion on managed or filtered DNS services becoming more and more common, and also how to deal with that. So there's a lot of policy, and also is that part of your document? So it's so there is a technical stuff.
There is a filtering section. There is a filtering section, and I think there's several different aspects of that we're going to have to consider. Yeah. So one is that there's a lot of legal constraints for filtering, especially within Europe. Different countries have different laws and regulations about filtering requirements. I don't know how current operators do it. My guess is that they're playing fast and loose with laws and not worrying too much about it, and Europe's not coming down hard on people because they don't like to get angry at big tech. But I can't say that for sure. But when I talk to European operators of DNS resolvers within an ISP or some in a university, they have requirements for filtering. They get lists from the government, which they're not allowed to pass on to other people, and things like that, which we're going to have to consider. Then there's the other filtering aspect of like keeping out, keeping people safe, opt-in versus opt-out and things like that. They're very closely related, but they are separate issues. And I think we have to address both of them. Thanks.
I think Will has something to add, and then we will have to wrap up so that Olena can have.
So, Will, Swiss ISP, the question of legal aspect is really interesting because obviously we have a funny way to work, and every ISP in Switzerland is supposed to be filtering on DNS because some law about gaming and so on and so on. So I suspect that we will, my thinking is I will go and contribute to that document because I think as you said, every country has its small tricks and we should find the way. Maybe everybody should contribute with the tricks of their country on what are the legal risks and so on, so we can make that document more usable and useful for everyone.
So do you, maybe this is inappropriate to ask, do you know if like the big public resolvers like Cloudflare and Google and Quad9, presumably they have peering within Switzerland. Do they follow the Swiss filtering laws that you know of? Maybe
that's a really good question. I know that I host on one of my IXP Quad9, and I don't think there is any of the filtering applying there. But on the other hand, Quad9 also has a legal entity in Switzerland, which
maybe there's something in the law which says about eyeballs or something. But,
I think the mic queue is closed.
Yeah, sorry. I'm happy to talk with all of you guys about this over drinks soon. So, yeah.
Nice save, Will.
Thank you. Thank you. There will be another opportunity at the DNS working group on Thursday morning.
Correct.
Yes. Olena, it's time. It's time, Olena. So Olena will talk about things that I mentioned before, how to document the current practices of running the networks in a very difficult environments. So Olena, thank you. The floor is yours.
Thank you, Jan. Hi, everyone. So actually, I was hoping for a bit more cozy setting because I don't want you to see this talk as a presentation, but merely as a dialogue with you. And the only reason why I'm standing here on the stage is because for the cameras, for people who are following us remotely. But I'm happy to see you here in this room. And as Jan mentioned, my topic today will be about identifying and documenting best practices to survive natural disaster or war. And this is a call for action. And I'm happy that Shane wasn't scouting for new volunteers for his task force, because I will do. So I'll have less competition, but I'll come to that later. Thanks, Shane. So what do we have as a reality? So what actually was a background of all of this? So as you know, the Ukrainian community is currently in an unprecedented situation and dealing with all possible kind of threats. This means that they are building really unique experience, and you might have heard Olena's presentation today. They're also willing to share this experience with you. Unfortunately, those who are in possession of the most of this experience, they are also have other urgent priorities. And most of you here are engineers, and you know that documenting what you do, even if it's a best practice, it's never a priority of an engineer. Even if an engineer is under some threats or missile attacks. So you all know the pain of documenting things. And so do engineers in Ukraine, and they are willing to share this experience, but they need someone's help, your help, to do that. So basically, this idea was slowly growing over the time, because since the beginning of the war, we at the RIPE-NCC, and I believe I forgot to introduce myself that I'm working for the RIPE-NCC, been working closely with Ukrainian community to see how we can support our technical community there. So one of the things we did, we organized an open house at the beginning of March. The Ukrainian operators shared some of their experience, and they were able to talk to broad RIPE community. So here you see a quote from the presentation of Maxim Smolenets. He is a technical director of the company that provided services on the occupied territories. Part of the territory is currently free. So he said that they really learned a lot. They learned how to make decisions quickly. They learned how to respond to threats, and even how to use completely new technologies that they didn't have in their possession before. So that helped them to keep Ukraine connected, but it also can help someone else. So why this task force, and why now? So if experience is not documented, it easily gets lost and forgotten. But if it can be made available now for a broader community, it can not only save time, but sometimes even lives. And you can speak about all kinds of threats and disasters. Like we recently had a big flood in Italy, which was horrible. For whom could it be useful? Of course, for those who have to restore damaged networks, but also for those of you who are only thinking about building something new, and maybe you can build a bit of more resilience in your future network using the technology which will help you to make this technology running. So why I think this is an appropriate place for such work? So again, you see a quote from their RIPE-NCC website that describes the main interest of this task force is that current operational practices are captured and documented, are published. So I can't find a better place to do this work than this task force. So what kind of best practices you can think about? That could be, how to rebuild completely destroyed network, or how to restore your network, or how to build networks that are resilient in the future. So this is an idea how I see this work can be done. Volunteers from this task force can work on a brain dump for the best operational practices document. And we from the RIPE-NCC are, as a secretariat for the community, are here to provide support that the community needs. To give you a few ideas to make it like more tangible, but here you see examples of topics that could be a part of the document. However, I'm not giving you like a document set up. It's more for you to say, okay, I'm interested in that topic. I want to volunteer because this is my interest. So you can pick it, and this is also based on the what we have heard from the Ukrainian community. But that could be, of course, any other community. Basically, I based this list on the presentation of, again, Maxim Smolenets, whom I already mentioned today. So he was just going one by one, explaining, how network and equipment loss affected their operations, how power outages affected operations, and what technology is actually can be better used in such situations. About network security. In Ukraine, people have a lot of experience how to use Starlinks. You will be surprised how creative they are in doing that. Also, how do you organize help logistics? And this is also something that is important to document. One last part that could also be interesting, but maybe for later, is how you manage your staff, how you manage this quick decision making, and how do you sustain your business model, how do you survive, etc., etc. So I pause here for a bit just to give you a bit of time of thinking. And basically here comes my call for action for volunteers to take part in this best current operational practices task force. And today we have plenty of time. We can discuss, for example, what do you think would be useful to have on this document? How did you see the work going forward, etc., etc. So again, this is not like a comprehensive list of the feedback or questions I want to hear from you, just to give you an idea what we can discuss today. And I'm available here for the whole week as Jan and Benno. So if you want to have, some ideas will come later, please approach us and we will discuss that task force. So that's it, and now the floor is yours.
Can you move one slide back? There we go. All right. Please, Jim.
Thanks very much. A very interesting and very thought-provoking presentation. I think this is something that's very important, obviously. The more we can do here to improve the resilience of our infrastructure and be seen to be doing that is a very, very good thing. So I would strongly support those efforts as possible. I think we have to be careful, though, that we don't get too focused on the extreme events that are happening in Ukraine. Serious as they are and a major concern for everybody, it's hard to see that those kind of circumstances are going to be replicated in other countries. So let's hope not. But those specific circumstances perhaps might cloud our judgment in terms of looking for the longer term or more generic considerations that might be more appropriate in much more civilized circumstances. So I would ask us to take a little bit of a step back about this. It's very important to learn the lessons that we've had from the experiences that have happened in Ukraine. But these are not the only ones, and these are not the only other things to consider. I do know that one or two other internet organizations that are operating internet important infrastructure have developed things like disaster recovery plans and business continuity plans. And if we can get hold of those organizations and ask them either to contribute or to willingly share some of the documentation of what their findings, I think that'd be a very, very useful thing to do for a start on that line. And I'm going to say something now which is perhaps a little bit controversial, but I'm going to say it anyway, is that the ISO, or certainly the British Standards Institute, have got a couple of standards documents on things to do with business continuity and things like disaster recovery. And surprisingly, these documents are rather good, unlike most of the documents that come from those organizations. So if you can get hold of those documents, that might help us in terms of shaping what this new task force might work on here. I think one of the key things that will be part of this effort is trying to explain why things like a risk register is important and why that risk register needs to be getting updated regularly. So I think these are things that are worth considering, and if you can get ahead with that, I will certainly try to support it as best I can.
Thank you, Jim. Just you mentioned two important things. Of course, the focus is on this events in Ukraine is only because it was so broad and it touched every aspect of network operators' business. Like we can, of course, not to mention what could be the reason of a network being damaged or destroyed, but the consequences are the same for every situation. So that could be anything. That's why, but the scale and of this experience that they have could be applied, and hopefully there won't be need to apply, but in much smaller like situations that we hope will never happen. And the second point you mentioned about examples of already like of good documents that already exist, that I think like for whoever will be taking a part of this, hopefully task force, it will be very useful as a starting point. and we can combine like the real experience, like life experience that we can capture now with that knowledge. That would be really very useful. And it will also make it also documents like recognizable if you use the same structure by other readers.
Yeah, I mean, I wasn't suggesting you would actually get copies of documents from organizations who have undertaken those exercises, because clearly those documents are specific to an organization and they will contain highly sensitive, confidential information that nobody in their right mind is ever going to share. But as you say, the structure of those documents could certainly be helped, and certainly looking at some of those standards documents I made passing reference to. I can't remember the standards document numbers, but if anyone really wants to know, I'll go and dig them out for you. But they would help trying to shape some of these kind of things, like how you'd actually try and shape things like a risk register and all the rest of it. And I think that'd be a valuable part of the exercise. And maybe some of the consultants that helped in the production of those documents might be able to offer some kind of advice to us, but of course those guys will probably want to get paid, so maybe not.
Yeah.
So I think that this task force is looking initially for a set of volunteers that are willing to talk to the Ukrainian counter-peers now, because the Ukrainians on the other side of the border may be not available tomorrow or next week or next month. We never know. It's a war. We look for the set of people that would have a discussion and document what they learn, and then bring it back as a sort of a brain dump, so this task force can make it into a proper neutral document that could be used for other purposes also.
Yeah, well, count me in. I'm volunteering for that.
Amazing.
Yeah,
thank you.
I would also say that I once worked in a mission critical environment. It was a long time ago, and I'll deny all knowledge of ever having worked there if anyone puts me on the spot. But part of their disaster recovery plan, one of their doomsday scenarios was a jumbo jet lands in the machine room and everybody in the building is killed. Now get the service running again. Now that's an extreme environment which probably would never happen, but given the events we're seeing in Ukraine, that's maybe not such an extreme environment anymore. And we need to start thinking about these horrible, unthinkable consequences.
Exactly.
So if I briefly may interrupt, so what Jan said, so we're asking for volunteers here in the room and the RIPE community to help with, well, creating a brain dump, but also to lower the barrier. Any text is fine, can be bullet points, etc. So you're not supposed, as you contribute, to you're not supposed to write full text, etc. Just so that's something we would like to take care of as well, at least the three of us and maybe other people who are used to write English text, etc. So it's really engineers talking to engineers. That's the most important. And these engineers, yeah, and maybe we can, and that's up to you also. Maybe we should have a questionnaire or some interview so that we all ask the same questions to the Ukraine engineers. So we have some consistent set of input, so we can work in the document. So we have all kind of ideas already, but we're asking also for your ideas, and we really, really want to lower the barrier for you to contribute. So you're not supposed to write many pages of text. Just get in contact with the Ukraine engineers, get their knowledge, get their experience, put it down in some, well, we don't know, Google Doc, GitHub, we don't care, everything will work, and we take it from there. Am I correct here?
Yeah, I just return back to the slide. It says the volunteers work on the brain dump, and you have us, RIPE and CC, as your secretariat to help with taking it further and to make it like a nice text document.
And we got the first volunteer. Thank you, Jim. You wanted to add something?
Yeah. Yes, I did. I just wanted to pick up on something Bennett was saying about asking for other people to give inputs and contribute to this effort. This could be something, in my view, is very simple. Is what sort of things do you think about in your organization about disaster recovery and business continuity? And just put these two things down. It could be things like what happens if the data center catches fire? What happens if a senior member of staff leaves at short notice? But simple things like that, just put them in, simple text, and then we can try and collate these information and turn it into something a bit more substantial. Everybody can offer that kind of input.
Exactly. I think it's Victoria now.
I asked to quickly jump in. We agreed. So I just want to respond to Jim. Sander Stefan, Keep Ukraine Connected Task Force. Because yes, this is an extreme situation in Ukraine. But don't forget, like Yemen is also part of the RIPE region. You know, it's we're actually quite late with this. There's more regions, like Jan and I have very good contacts in Sudan with the Sudanese NOC. They're in trouble now. So if we look further in our own region and outside our own region, I think the target audience for work like this might be a lot bigger than we initially think it is.
Thank you. Victoria.
Hello, hi for all. My name is Victoria Panasiuk. As a representative of the Ukrainian operators business, I can say that we are ready to collect all best practices from our engineers or from our network operators to collect best practices for of ensuring resilience of internet networks under distractions. I can say that our operators learned how to restore networks extremely quickly using different unknown before technologies even. And we have some informal even algorithms how to step by step restore network. And this algorithm concern not only physical level, but also business processes, because every co-owner or every director of the network operator should know how to collect and how to organize step by step the process between engineers to make it quickly and more effective. And the set very important in the condition of war, also maintain a network also on the government level. And we also can say how on our experience how it can be done by the more effective way. I can say that we live in a very unpredictable world, and war in Ukraine, it's not one war, and also many natural disasters can be exist. And no one sitting here, I think, could not be sure that you can avoid war or natural disaster. We couldn't be ready for this, no one. And we can be ready and prepare to doing something for more effective, more quickly restoring and rebuilding network, our networks. And if there's there will be a people who can document best practices, best solutions of quick restoring networks, we will help, and we will do everything possible to share our experience, and it can be very important for every member of this community, of international community.
Thank you. Branimir.
Hi, Branimir Reiter, 5x9 Networks. So first I want to say I really think it is a great thing. So I think this needs to be written down. This experience has to be taken into account. But also I would like for you to consider how to incentivize ISPs to implement these techniques, because I work with a lot of ISPs, and basically ISPs are struggling with traffic load, with business, monetization, and basically some of them are just trying to stay afloat. So it would be worthwhile to see how how ISPs could be, incentivized, how they could be talked to in order to implement these guidelines. Because I personally don't want these guidelines to be just like letters on a paper. It needs to be taken into account and it needs to be implemented. And also, I'm from Croatia. We had some earthquakes a couple of years ago, and we have some experience with burned down the data centers. So I'm happy to help.
Thank you, Vladimir.
So,
actually,
do we have a second volunteer now?
Yeah.
Amazing.
And we are already friends, so that's easy, right? No, thanks. Very good point about the last thing. I personally want someone who initiated this to be just letters on paper, not serving anyone. So we really want it to be useful. That's why we think it's important, because I believe that will be useful. So we will have a discussion about how to make it more visible and more applicable, as you said. Thank you.
One more question.
Victoria. No, Olena.
Alena, thank you very much for your interesting topic. First of all, it is very important for us. And of course, our community ready to share our best experience. And for the, as I have lack of time, I haven't possibility to mention some examples. When, for example, the owner of the company for one moment lose everything, and because he never know, for example, password from account of RIPE NCC account. Of course, we and I have proposition. We can organize open house. Of course, it can be in English, but some of our technical person who have very cool experience in 0 kilometer. They know everybody knows English. That's why maybe we can use some subtitles. That's why we are ready and waiting for time and day. Thank you so much.
Thank you, Olena.
We have online participation. You may know this person. It's Oleg Muravsky. He said you could count me in as well.
Okay, noted.
Now we have 3. Please.
For the records without Peshchenko, Ukraine, I have a question about target audience. Is it only LAR members of RIPE community, or can be more broader community, because it can be useful even for small enterprises, for small ISP who never attended a RIPE meeting and never took part in the RIPE work. So maybe it's worth to make some real document and some summary.
No, of course, RIPE community is much broader than RIPE NCC membership, and everyone is welcome to participate, of course.
You also counted me.
Thank you.
We have 4 now. Jim.
No, actually, what Olena mentioned about open house or open hour, like something online. I believe we should, when we have volunteers, we will discuss the process, like what shared drive we use, either Google or GitHub, that I learned that existed like last week, because I'm not in that technical environment. So I asked Mirjam and Benno and Jan what is like popular between engineers, and they said, yeah, GitHub is cool. So whatever, how people want to organize, and that's already like administrative details we can discuss later to make it this works running smoothly, and you as a community can count on our support. I have a Zoom link, like with unlimited Zoom calls if you need. So
it's Jim and then Vlad.
I just wanted to make a quick clarification to one of the questions that was asked before about the target audience of this document and what would happen to the output from the task force once it was completed. Ordinarily, the output from the task force will be a document which would be published as a RIPE document.
Yes.
And at that case, that document is freely available to anybody who wants it without any kind of restrictions whatsoever. So they're open to everybody, whether they're an LIR or not. Maybe the document will have specific advice on the business continuity and disaster recovery considerations for an LIR. But that's just one small component of all the overall architecture of what needs to be considered here. And if we feel that the document's probably getting too big, maybe we might want to split it into separate things. Business continuity disaster recovery for an LIR, business continuity and disaster recovery for a small medium enterprise. Just have to see where it goes, but it'll be openly available to everybody, and anybody who wants to contribute to the work will be able to do that. All the details are access to the relevant mailing list.
Currently, I don't see the depletion of RIPE document numbers.
Yeah, very true.
Vlad.
Okay, so Jim. Oh. So Vladislav Velikov with several hats, but as a part from the academia, I got several deja vus in your talks until now. I did something similar, and that is something that is useful probably for you. And this is for 2 years I was fighting to create a business continuity framework for NRENs, so National Research and Education Networks, mainly because some NRENs are really big and for them it's easy, but most of them are medium / small / super micro. And for them, getting things, what do you need as pieces is easy, either ISO standards, communities, etc., etc. But then trying to explain technically what is the fastest path doing this is the problem. I think we have some basic documents which are available. They were produced as part of the GEAN project, but they're free reusable. And how we actually combine the different things with something we call experience is useful, as Jim already mentioned, for different set of people to see what happens. And this is mainly connected to disaster and critical disasters involving infrastructure. So we are touching power distribution the same as networks, the same as people, the same as different things. And I can provide that to the task force, at least. Maybe I don't have extreme amount of time, but I'll try my best. So that's half a volunteer.
Thanks, anyway.
4.5 now, okay.
So, no, okay, the chair.
Mirjam Kühne, Vibe Chair. I just want to say I think this is a fantastic initiative. I really welcome that. And I think it's right in the spirit of the Vibe community, you know, to share information, collaborate. Like, I love this idea of like engineers to engineers. I remember when I was studying computer science, I had like a certain subject about expert systems, and the main problem there was how to get the expertise out of the experts. And so the having engineer talking to engineers and getting the expertise out of that, I think that's the brain dump, what you call the brain dump. I think that's going to be essential. I really hope we find enough volunteers, and I'm really looking forward to this. I think it's going to be really powerful coming out of the Vibe community. Thank you.
Dima.
I just want to add that I can probably also be part of that, at least as a half member. I'm not sure what's the workload, but I'm sure I can help a bit with this as well. Thank you.
Is that 5.5?
Something like that, maybe just 5. Let's just be on the. I'd rather under-promise and over-deliver than the opposite.
Well, thank you very much. Thank you, Dima. Okay, anyone else? All right, so we are here all week. If people think about it, if you want to volunteer, talk to Olena or talk to any of us. And I suggest that, Olena, you organize sort of like during this week a meeting of people that already volunteered, and spearhead to have a closer discussion about how to start the work.
Yeah, like team building event.
So thanks. And I like to remember everyone. There's a BCOP task force mailing list at the RIPE, so we will use that also for, well, giving updates or some coordination and some ongoing discussion. So if you haven't done that yet, please subscribe to the BCOP task force mailing. It's low volume, so you won't be spammed by many
Yeah, and you can join anytime.
Yeah.
So if you haven't expressed your willingness to participate now, anytime you want to join for any period of time, is like volunteer work is always welcome.
All right. Thank you very much. I think we are in time to wrap it up. Do we have anything else on the agenda?
Open it.
Open mic. Anyone? Yes, yes, we are standing between you and beer or whiskey. So let's do the open mic quickly. If anyone has any idea about any other work or BCOP. Oh, Thomas.
Yeah, as much as I appreciate Will's ability and willingness to help speakers dodge questions, going back to the first presentation. So with regards to domain filtering on public DNS resolvers, Cloudflare, which is 1.1.1.1, doesn't do it, never. And Quad 9 does it, but not according to any kind of like government related blacklists. It's more of their own stop list. And you can use 9.9.9.10 instead of 4 nines to avoid that filtering as well. Just a comment.
Thank you. Any comments, reaction? Beer time, I think. I think there will be a social events. Yeah. Will be? Yes. Yeah. No. Yes. Yes.
Yeah. There's also meet the board.
I'm looking at Mirjam. Mirjam should know.
There's a meet the board.
She's giving a thumbs up. Beer for everybody. Okay.
Thank you very much for your participation.
Thank you very much.